belonging to a caste, or Nyamakala, include I. The Smith Numu in Bambara, Balo in Fulfulde. 2. The Weaver, Chnabo, in both Fulfulde and Bambara. 3. The Woodworker, both woodcutter and joiner, Saki in Bambara. Labo in Fulfulde. 4. The Leatherworker Garanki in Bambara, Saka in Fulfulde. 5. The Public Entertainer Diali in Bambara, in Fulfulde he is designated by the general NAME for a Nyamakala or MEMBER of a caste, that is, Nyasno. He is better known, perhaps, by the French NAME for him, Griot. Although strictly speaking there is no notion of superiority, the four craftsman classes of Nyamakala have precedence over the Diali class, because they each involve initiation and a special skill and field of knowledge. The Smith ranks highest, followed by the weaver, their crafts being the most initiatory. Members of these two classes may intermarry, since the WOMEN in both are traditional potters and therefore share the same women's initiation. In the MANDE classification the craftsman Nyamakalas always go by threes. There are three kinds of Smith Numu in Bambara, Balo in Fulfulde. A. The mining smith, or smelting smith, WHO extracts mineral ores and smelts metal. The great initiates among these smiths can also work at the forge. B. The blacksmith, who works at the forge but does not extract ore. C. The worker in precious metals or jeweler, WHO is usually attached to a chief or a noble and so may be found in the outer courtyard of his palace. 185. There are three kinds of weaver, Maabo. A. The wool weaver, the most highly initiated. The designs on blankets are always symbolic and are associated with the mysteries of numbers and of cosmogony. Every design has a name. B. The Kirka weaver, WHO weaves huge blankets, mosquito nets, and cotton hangings that may be 6 meters long, with an endless variety of motifs. I have seen some with 165. Each motif has a name and a meaning. The name itself is a symbol that stands for many things. C. THECOMMON weaver, WHO makes simple lengths of white cloth and is not involved in a high degree of initiation. It sometimes happens that ordinary weaving is done by noblemen. For instance, certain Bambara work lengths of white cloth without being of the weaver caste. But they are not initiates and may not weave kirka, wool or mosquito nets. There are three kinds of woodworker, Saki in Bambara, Labo in Fulfulde. A. The maker of mortars, pestles and sacred statuettes. The mortar, in which sacred medicines are pounded, is a ritual object made only from particular kinds of wood. As in the smithy, the two fundamental forces are symbolized. Here, the mortar, like the anvil, represents the feminine pole and the pestle, like the hammer, the masculine. Sacred statuettes are made at the command of a doma inuit. WHO will charge them with sacred energy for some particular use. Besides the charging ritual, the choosing of the wood and the cutting, too, must be carried out under special conditions known only to the woodcutter. The craftsman in wood cuts the wood he needs himself. Therefore he is also a woodcutter, and his initiation is linked with knowledge of the secrets of plants and the bush. Since the tree is regarded as alive and as inhabited by other living spirits, it may not be felled or cut up without particular ritual precautions known to the woodcutter. B. The maker of wooden household utensils or furniture. C. The maker of dugout canoes. The canoe maker must further be initiated into the secrets of water. In Mali, the SOMONO, WHO have become fishermen without. Belonging to the Bozo people, have also begun to manufacture dugouts. They are the MEN1Cs working on the banks of the Niger between Kaulakoro and Mopti. There are three kinds of leather worker, Guranki in Bambara, Saka in Fulfulde. 186. A. The one who makes shoes. B. The one who makes straps, reins, bridles, etc. C. The one who makes saddles, horse collars, etc. Leatherwork, 2, involves initiation, and the Guranki often has the reputation of being a witch. Hunters, fishers, and farmers correspond not to castes but rather to ethnic groups. Their activities are among the most ancient in human society. Gathering, of plants, and hunting, whether on land or water, represent yet other great schools of initiation, for the sacred forces of Mother Earth and the powers of the bush, where animals live, are not to be approached in a random way. Like the smelting smith, the hunter usually knows all the bush incantations and must be thoroughly versed in the science of the animal world. Healers, healing either through plants or through the gift of speech, may belong to any class or ethnic group. They are often domas. Often a people will have a heritage of particular gifts handed down from generation to generation through initiation. Thus the dogon of Mali are reputed to know the secret of leprosy, which they can cure very quickly, without a trace being left, and the secret of the cure for tuberculosis. They are furthermore excellent bone setters. WHO can reset broken bones even in cases of serious fracture. Public entertainers, Diali in Bambara. If the occult and esoteric sciences are the prerogatives of the master of the knife and the chanter of the gods, on the other hand the music, lyric poetry, and tales which enliven popular recreation, and often history as well, are the province of the Diali, a sort of troubadour or minstrel. Whomay wander about the country or may be attached to a family. It has often been wrongly supposed that the Diali were the only possible traditionalists. Who are they? They can be divided into these categories. The musicians, who play every instrument, monochord, guitar, kora, hand drum, and so on. Often wonderful singers, they are preservers and transmitters of ancient music, and composers too. 2. The ambassadors and courtiers responsible for mediating between great families when differences exist. They are always attached to a royal or noble family, sometimes to one particular person. 3. The genealogists, historians, or poets, or menwho are all three in 1. Who are usually also storytellers and great travelers, and not necessarily attached to a family. Tradition confers a special social status on the Diali. Unlike the Haran nobles, they have the right to be shameless, and they enjoy a very great freedom of speech. They may act uninhibitedly, even impudently, and they 187. Sometimes joke about the gravest, holiest things without its mattering. They are under no compulsion either to be discreet or to hold the truth in absolute respect. They can sometimes tell brazen lies without being held to account. That's what the Diali says. So it isn't the true truth, but we take it as it is. This maxim shows well enough how, without being gulled by them. Tradition accepts the fabrications of the Diali, who, the maxim adds, has a crooked mouth. In all Bafour tradition, the noble or the chief is not only prohibited from performing music in public gatherings but is bound to be moderate in expression and speech. Too much talk ill beseems the mouth of a Haran / says the proverb. And so the dialy attached to families quite naturally come to play a role as go-betweens, or even ambassadors, when great or small problems spring up. They are their master's tongue. And attached to a family or a person, they are usually charged with the negotiations called for by any customary occasion, especially marriage negotiations. For example, a young nobleman will not address a woman directly to tell her of his love. He will make his dialy his spokesman, and the dialy will get in touch with the girl, or the girl's female dialy, so he can speak of his master's feelings and praise his merits. Since African society is fundamentally based on dialogue between individuals and discussion between communities or ethnic groups, the dialy are the natural active agents in these exchanges. Authorized to have two tongues in their mouth, they can if need be unsay what they have already said without being held to strict account. This would be impossible for a noble, who is not allowed suddenly to go back on his word or change his decision. A dialy will even shoulder responsibility for a fault he has not committed in order to remedy a situation or save face for the nobles. It is the old wise men of the community at their secret conclaves who have the grave duty of looking at things through the right spectacles, but it is up to the dialy to make what the wise men have decided and ordained actually work. Trained to gather and give out information, they are the great carriers of news, but frequently scandalmongers also. Their Bambara name, dialy, means blood. And indeed like blood they circulate in the body of society, which is cured or falls ill accordingly as they temper or exacerbate conflicts with their words and songs. I should say at once, though, that all this is a matter of general characteristics only, and that the dialy are not all necessarily impudent or shameless. Far from it. Among them there are men who are called dialy fama, dialy kings. These are in no way second to noblemen when it comes to courage, morality, virtues, and wisdom, and they never abuse the rights they have been granted by custom. The dialy used to be a great active agent of human commerce and culture. Often highly intelligent men, they played a very important part in the traditional society of the Bafour because of their influence over nobles and 188 chiefs. Even now, at every opportunity, they stimulate and excite the nobleman's clan pride with their songs, often for the sake of presents but often, too, to encourage him in some difficult situation. For example, during the night of vigil before the circumcision rite they encourage the child or youth to show himself worthy of his forebears by remaining impassive. Your father, so and so, who was killed on the field of battle, swallowed the gruel of flaming iron bullets without blinking. I hope that tomorrow you will not let yourself be afraid of the edge of the blacksmith's knife, they sing among the Fulani. At the stick or sorrow sir Moni among the Borora Fulani of Niger, the songs of the dialy sustain the boy who has to prove his courage and patience by smiling, without a quiver of his eyelids, as he receives stinging lashes from the stick on his breast. The dialy took part in all the battles in history at the side of their masters, whose courage they whipped up by recalling their high pedigree and the great deeds of their forefathers. For the African, the evocation of his family name has great power. Even today one greets him and gives him praise by repeating the name of his lineage. The influence of the dialy on the course of history was good or bad, depending on whether their words spurred the leaders to vainglorious excesses or, as was often the case, recalled them to a sense of their traditional duties. it is clear that the diali are an inseparable part of the history of the great African empires of the Bafor, and their role deserves a thoroughgoing special study. The secret of their power and influence over the Haran nobles resides in their knowledge of genealogy and family history. Some of them have been real specialists in this. Such diali seldom belong to a household, but travel the country in quest of more and more extensive historical information. They can therefore be sure of having an almost magical ability to touch off the enthusiasm of a noble when they come and declaim his genealogy, heraldic devices and history, and, as a matter of course, receive liberal presents from him. A nobleman is capable of stripping himself and his house, and handing over everything he possesses to a diali who has managed to stir his feelings. Wherever they go, then, these genealogist diali are sure to make a good living. But it must not be thought that this is a matter of pay. The idea of remuneration for work done is contrary to the traditional notion of the right of the Nyamakala over the noble classes. 12. Whatever their fortune. To your father, in African languages, can quite as well be an uncle or a grandfather or a forefather. It means the whole paternal line, collaterals included. Noblemen are traditionally obliged to make presents to the diali or to any Nyamakala or Wolaso 1*, even the poorest noble, and even if the asker is infinitely richer than the giver. Generally speaking, it is the diali caste that does the most soliciting. But whatever his gains, a diali is always poor, for he is a lavish spender, counting on the nobles for his sustenance. Oh, sing the questing diali, a nobleman's hand is not stuck to his neck with avarice, it is always ready to dig into his pocket to give to him who asks. And if by any chance the present is not forthcoming, the noble had better beware of trouble from the man with a crooked mouth whose two tongues can ruin many a project, many a reputation. From the economic point of view, therefore, the caste of diali, like all the Nyamakala and Wolaso classes, is a great burden on society, and especially on the noble classes. The gradual change in economic conditions and mores has somewhat altered the state of affairs, with former nobles or former diali accepting remunerative functions, but the custom continues notwithstanding, and people still ruin themselves on the occasion of baptisms or marriages by giving presents to the diali who come to enliven the feasts with their songs. Some modern governments have tried to put an end to the custom but, to my knowledge, have not yet succeeded. The diali, being Nyamakala, must in principle marry within the Nyamakala classes. It is easy to see how the genealogist diali, specializing in family history, and often endowed with prodigious memories, have quite naturally become, as it were, the archivists of African society and, occasionally, great historians. But let us keep in mind that they are not the only persons with such knowledge. The historian diali can, it is true, be called traditionalists, but with this reservation, that theirs is a purely historical branch of tradition and that tradition has many branches. The fact of being born a diali does not necessarily make a man a historian, though it gives him a certain inclination in that direction. Nor does it make him learned in traditional matters, one who has knowledge, far from it. Generally speaking, the diali caste is the one farthest removed from the realms of initiates, these requiring silence, discretion, and control of one's speech. The opportunity of becoming masters of knowledge is not closed to them, however, any more than to anyone else. Just as I am a traditionalist, the traditional master of knowledge in the true sense of the term, can be at the same time a great genealogist and historian, so a diali, like any member of Any social category can become a traditionalist I/OWA if his aptitudes permit. And if he has gone through the corresponding initiations, with the exception, though, of the KOMO initiation, which is forbidden him. Earlier in this chapter I mentioned the example of the two Diali masters of knowledge now living in Mali, Iwa and Bonzumana, the latter being at once a great musician, a historian, and A/OWA traditionalist. The Diali who is also a I/O/WA traditionalist constitutes an absolutely reliable source of information, for his being an initiate gives him a high moral value and makes him subject to the prohibition against lying. He becomes another man. He is the Diali king I spoke of earlier, Whom people consult for his wisdom and his knowledge, and Who, albeit able to entertain, never abuses his customary rights. When a Diali tells a story he is usually asked, is it a Diali story or a Doma story? If it is a Diali story, people say, it's what the Diali say, and they expect a few embellishments of the truth intended to play up the role of such and such a family, embellishments which would not be added by a Doma traditionalist who cares above all for truthful transmission. We have to distinguish, when we are in the presence of a historian Diali, we have to ascertain whether he is an ordinary Diali or a Doma Diali. And yet, it has to be admitted that the factual basis is hardly ever changed. It serves as a springboard for poetical or panegyrical displays which, if they do not falsify, at least decorate it. A misunderstanding which still has its sequel in some French dictionaries ought to be cleared up. The French took the Diali, Whom they called a griot, to be a witch sorcerer, which was not the case. 14 It can happen that a Diali is a Kortetiki, caster of a bad lot, just as it can happen that a Diali is a Doma traditional knower, and that not because he was born a Diali but because he has been initiated and gained his proficiency, good or bad, at the school of some master of his art. The misunderstanding probably arises from the ambivalence of the word griot, which the French sometimes use for all Niamakala, who include the Diali among others, and, more often, for the Diali caste only. Tradition has it that the Niamakala are all Sub'a meaning Aman. Versed in hidden knowledge known only to initiates, a sort of occultist. Tradition excludes from this designation the Diali, who do not lead the life of proper initiates. Therefore it is the Krititsamtun Niamakala who are Sub'at. Among these the Gurunki, the leather worker, does have the reputation of being a Sub'at, a witch, in the bad sense. I am inclined to think that the first European interpreters confused the two terms Sub'at and Subaga, which are close in pronunciation, and that the ambivalence of the term griot did the rest. Since tradition declares that all Niamakala are Sub'at occultists, these interpreters must have understood all Niamakala are Subaga witches, which, because of the double usage, collective or particular, of the word griot, became all griots are witches. Hence the misunderstanding. Be that as it may, the Diali's importance lies not in any powers of sorcery he may have, but in his part in managing speech, which, if one comes down to it, is another form of magic. Before leaving the Diali, let us note some exceptions that may cause confusion. Certain weavers can be found who have abandoned their traditional craft and became guitar players. Fulani call such a man bambado, literally one who is carried on the back, because his expenses are always borne by another man or by the community. These bambado, who are always storytellers, can also be poets, genealogists, and historians. Certain woodcutters, too, may exchange their tools for a guitar and become very good musicians and genealogists. Bakr Ilo and Idris and Gata, who were among the great genealogists I know of in the Upper Volta, were woodcutters turned musicians. But these are exceptions. Again, certain déclassé nobles may become popular entertainers, not musicians, though one s, and they are called Tiaporta, in Bambara and Fulfulda alike. They are then more impudent, more shameless, than the most impudent of Diali, and nobody takes their remarks seriously. They will ask the Diali for presents, to the point where the latter make their escape when they see a Tiaporta coming. While generally speaking music is the Diali's great speciality, there is also a ritual music played by initiates and accompanying ritual ceremonies or dances. The instruments of this sacred music are then true cult objects, which make it possible to communicate with invisible forces. Accordingly, as they are string, wind, or percussion instruments, they are in rapport with the elements of earth, air, and water. Making music for incantations to the spirits of fire is the prerogative of the Association of Fire Eaters, who are called Kurzi Kolonin or Dayangasaro. One becomes a traditionalist. In the Africa of the Bafour, as I have already suggested, anyone could become a/oth traditionalist, that is, a master of knowledge in one or more traditional subjects. Knowledge was open to everyone, initiation being omni-present in one form or another, and acquisition of it depended simply on individual aptitude. Knowledge was so highly esteemed that it had precedence over everything else and conferred nobility. Master of knowledge in any field could sit in the council of elders which governed the community, regardless of his social category, Haran, noble, Nyamakala or Wolaso. Knowledge knows neither race nor the paternal doorway the clan. It ennobles its man. Says the proverb. African education was not systematic like European schooling. It was dispensed throughout life. Life itself was education. In the Bafour, until he was 42, a man was supposed to be at the school of life and had no right to speech in meetings, save exceptionally. He was supposed to be still, listening and deepening the knowledge he had been receiving since his initiation at the age of 21. At 42, he was deemed to have assimilated and deepened the instruction received from youth on. He acquired the right to speak in assemblies and became a teacher in his turn, to give society back what he had received of it. But that did not prevent his continuing to learn from his elders, if he so wished, and soliciting their advice. An old man can always find an older or wiser man than himself, to ask for additional information or for an opinion. Every day, they say, the ear hears what it has never yet heard. Thus education could last a whole lifetime. After learning his craft and following the relevant initiation, the young Kritsam's Nyamakala, ready to fly with his own wings, would usually go from village to village, to increase his sum of knowledge by learning from new masters. He who has not traveled has nothing seen, people say. So he would go from workshop to workshop, covering as much of the country as he could. And from the hills would come down to the plain, those of the plain went up into the mountains, those of the Baladuga came to the Mande. And so on. In his travels the young smith would always wear his bellows slung across his back in order to be recognized, the woodcutter would have his axe or his adze, the weaver carried his loom on his back, dismantled, but held his shuttle or his spool shouldered high. The leather worker held his little pots of dye. And the young man arrived at a big village where craftsmen lived in separate groups, by guilds. People would automatically lead him towards the leather workers' quarter, or the weavers, etc. HOWMUCH he learned in the course of his travels and investigations. Depended on his dexterity, his memory, and above all his character. If he was polite and attractive and obliging, old man would give him secrets they would not hand over to others, for it is said, the old man's secret is bought not with money but with good manners. As for the young Haran, he would spend his childhood in his father's court, and in the village, where he would attend all the meetings, hear everybody's stories and retain as much as he could. In the evening sessions of his age set, each child would retell the stories he had heard, whether historical or initiatory, but in the latter case without grasping the full implications. From 7 on he was automatically part of his village initiation society and began to receive its instruction, which, as I have said, concerned all aspects of life. When an old man tells an initiatory tale in an assembly, he develops its symbolism so as to suit the nature and understanding of his audience. He can make it a simple tale of wonders with a moral, for children, or he can make it a profound lesson in the mysteries of human nature and man's relation with invisible worlds. Each person retains and understands according to his aptitudes. It is the same with the historical tales which give life and spirit to meetings, tales in which the great deeds of the men of old, the country's heroes, are evoked in the most minute detail. A stranger passing through will tell stories of distant lands. And so the child is immersed in a particular cultural ambience which he absorbs as well as his memory permits. His days are marked by history, stories, fables, proverbs and maxims. As a rule the young Haran does not go abroad, since he is destined for the defense of his country. He works with his father, who may be a farmer or a garment maker or be in any other activity reserved for the Haran class. If he is a Fulani, he moves about with his parents' camp, soon learns to tend the herd all alone out in the bush, night and day, and receives the Fulani initiation associated with the symbolism of cattle. Generally speaking, one does not become a/owa traditionalist by staying in one's village. A healer who wants to deepen his knowledge has to travel so as to learn about the different kinds of plants and study with other masters of the subject. The MANWHO travels, discovers and lives other initiations, notes the differences or similarities, broadens the scope of his understanding. Wherever he goes he takes part in meetings, hears historical tales, and lingers where he finds a transmitter of tradition who is skilled in initiation or in genealogy. In this way he comes into contact with the history and traditions of the countries he passes through. One can see that the man who has become a/OMF traditionalist has been a seeker and a questioner all his life and will never cease to be one. The African of the savannah used to travel a great deal. The result was exchange and circulation of knowledge. That is why the collective historical memory in Africa is seldom limited to one territory. Rather it is linked with family lines or ethnic groups that have migrated across the continent. Many caravans used to plow their way across the country using a network of special routes traditionally protected by gods and kings, routes where one was safe from pillage or attack. To do otherwise would have meant exposing oneself either to a raid or to the risk of violating, unawares, some local taboo and paying the consequences dearly. Upon arrival in a strange country, travelers would go and entrust their heads to some man of standing. WHO would thereby become their guarantor, for to touch the stranger is to touch the host himself. The great genealogist is necessarily always a great traveler, while a dialy may rest content with knowing the genealogy of the particular family he is attached to. For a true genealogist, dialy or no, to increase in knowledge he has to travel about the country to learn the main ramifications of an ethnic 194 group and then go abroad to trace the history of the branches that have emigrated. Thus Molom the greatest genealogist I have been privileged to know, possessed the genealogy of all the Fulani of Senegal. When his great age no longer allowed him to go abroad, he sent his son Mamadou to carry on his survey of the Fulani families that had migrated through the Sudan, Mali, with Alhaj Umar. At the time when I knew Molom, he had succeeded in compiling and retaining the past history of about 40 generations. He had the habit of going to every baptism and every funeral in the leading families so as to record the circumstances of deaths and births, which he would add to the list already filed in his astonishing memory. So he was able to declaim to any important Fulani, "You are the son of so-and-so, born so-and-so, the descendant of so-and-so, offspring of so-and-so. Each of them died at such and such a place of such a cause and was buried in such and such a spot," and so on. Or else, so-and-so was baptized on a certain day at a certain hour by the marabout so-and-so. Of course all this information was and still is orally transmitted and recorded by the genealogist's memory alone. People have no idea of what the memory of an illiterate can store up. A story once heard is graven as if on a die and can then be reproduced intact, from the first word to the last, whenever the memory calls on it. Molom died at the age of 105, around 1968 I believe. His son, Mamadou, now 50, lives in Mali, where he is carrying on his father's work by the same purely oral means, being himself illiterate. Wahab Jallo, a contemporary of Mamadou Jallo, also still alive, has carried out a survey of Fulfulde-speaking groups, Fulani and Tukulor peoples, in Chad, Cameroon, the Central African Republic, and even in Zaire, in order to learn the genealogy and history of families that emigrated to those countries. The Jallos are not Diali but a Fulani-speaking group equivalent to the Niamakala class and enjoying the same prerogatives. Talkers and declaimers. Rather than musicians, except for their WOMEN, WHO sing to their OWN accompaniment on rudimentary instruments, they can be storytellers and entertainers, and there are many genealogists among them. Among the Marca, Monde group, genealogists are called Gusir. From the name their group has among the Marca. Genealogist means historian, for a good genealogist knows the history and exploits of every person mentioned, or at least the most outstanding ones. This science is at the very base of history in Africa, for if people are so much interested in history it is not on account of dates but on account of genealogy. So as to be able to trace a given family, clan, or group as it spreads out through time and space. So everyone is a bit of a genealogist in Africa, and capable of going fairly far back in his own family tree. If not, it would be as if he had no identity. 195. Card. In old-time Mali there was no one who did not know at least 10 or 12 generations of his forebears. Among all the old Tukulor who came to Marina with Alhaj Umar, there was not one who did not know his genealogy in the Senegalese Fouta, their country of origin, and his relation to the families that were still there. These were the people Whom. Mamadou Umalam, son of Molom Jallo, came to Mali to consult to continue his father's inquiry. Genealogy is therefore at once a sense of identity, a means of exalting family glory and a resort in case of litigation. For example, a dispute over a Piece of land could be settled by a genealogist, who would state exactly what ancestor had cleared and cultivated the land, to whom he had given it, under what conditions, and so on. Even now, one finds any number of people who belong neither to the Dialy nor the Jalo class but are well up in genealogy and history. In them, we have an important source of information on the history of Africa, at least for a while to come. Each patriarch is a genealogist for his own clan, and the Dialy and Jalos will often come to him for information to supplement what they already know. Generally speaking, every old man in Africa is a master of knowledge in some historical or traditional field. Dialy and Jalos, then, have no monopoly over genealogical knowledge. But it is only they who specialize in declaiming genealogies in front of nobles, for the sake of obtaining gifts. Influence of Islam. The peculiarities of the African memory and the modalities of its oral transmission have not been affected by the widespread Islamization of the Savannah countries, the old Bafour. In fact, as Islam spread, it nowhere adapted African tradition to its own thought but rather adapted itself to African tradition whenever, as was often the case, this did not violate its fundamental principles. The symbiosis that came about was so great that it is occasionally hard to make out what belongs to the one tradition and what to the other. The great Arab Berber family of the Kunta Islamized the region well before the 11th century. As soon as they learned Arabic, the autochthones began to use their ancestral traditions for transmitting and explaining Islam. Great Islamic schools that were purely oral taught the religion in the vernacular tongues, except for the Quran and the texts that form part of canonical prayer. I might mention, among many others, the oral school of Jalgadji, called Kabe, the school of Barani, Amadou Fodia's school in Ferimaque, Niafount district, in Mali, Mohamed Abdoulaye Swadou's school at Dili, Nara district, Mali, and Sheikh Usman Dan Fodio's school in Nigeria and Niger, where all teaching was in Fulfulde. Closer to us, there was Tirno Bakr Salif Zawaya in Bandiagara and the school of Sheikh Salah, the great Dogon Marabout, who is still alive. 196. To give an idea of what the African memory is capable of, most children leaving the Quranic schools knew the entire Quran by heart and could recite it all, in Arabic and in the desired Samadi, without understanding what it meant. In all these schools the basic principles of African tradition were not repudiated but on the contrary used and explained in the light of Quranic revelation. Tirno Bolir, who was a traditionalist both in African matters and in Islam, became famous for his intensive application of this educational method. Quite apart from their having a common vision of the universe as sacred, and the same conception of man and the family, we find in both traditions the same concern for always citing one's sources, isnad, in Arabic, and never changing anything in the master's words, the same respect for the chain of initiatory transmission, Sibylla or chain, in Arabic, and the same system of initiatory ways of life that make it possible to deepen through experience what is known through faith, in Islam, the great Sufi congregation or tariqa. Plural Turuk, the chain of which goes back to the Prophet himself. The existing categories of traditional masters of knowledge were now added those of the Marabouts, widely read in Arabic or in Islamic jurisprudence, and the great Sufi sheikhs, although the structures of society, castes and traditional crafts, were preserved even in the most Islamized environments and continued to convey their particular initiations. Know. Ledge of Islamic subjects constituted a new source of ennoblement. Thus, Alpha Ali, d. 1958, a Jalo by birth, was the greatest authority on Islamic subjects in the Bandiagara district, like his whole family before him and his son after him. 1-6. HOWA body of oral material was collected. To give a practical illustration of how historical or other stories live and are preserved with strict fidelity in the collective memory of an oral tradition. Society, I shall tell how I managed to assemble, solely on the basis of oral tradition, elements that enabled me to write the history of the Fulani Empire of Elasina in the 18th century. 11. As I belonged to the family of Tijani, ruler of the province, from childhood on I had ideal conditions for hearing and retaining. My father Tijani's house at Bandiagara was always full of people. Night and day there were great gatherings at which everyone would talk about a great variety of traditional matters. My father's family having been closely involved in the events of their day. The stories were often about history, and each person would relate a well-known episode of some battle or other noteworthy occurrence. I was always present at these gatherings. I lost not one word, and my memory, like virgin wax, recorded everything. It was there that, from early childhood, I knew Kaulel, the great Fulfulde speaking storyteller, genealogist and historian. I followed him about everywhere and learned many tales and stories which I would proudly tell over again to the boys in MYH set, to the point where they nicknamed me Kaulel, which means Little Kaulel. As the result of circumstances beyond my control, I went with my family to many countries, where I was always able to be in touch with great traditionalists. Thus when my father was obliged to live in Bugani, where Kaulel had followed us, I made the acquaintance of the great Bambara Doma Danfo Sign, and later of his younger brother Latif. Later on, at Bamako and at Kadi, my father Tijani's court was practically reconstituted, and traditionalists from all countries flocked to it, realizing that there they would meet other masters of knowledge in whose company they could control or even increase their own knowledge, for one always finds someone more learned than oneself. That was where I began to learn a good deal about the history of the Fulani Empire of Messina, both in the Makanunki version, that is, the version of people originating in Messina, partisans of the Shekau Amadou family, and in the version of the Tukulor, their antagonists, and also in the version of other peoples, Bambara, Marka, Sarakol, Songhay, and so on, who had taken part in what happened, or been present. Starting, then, from a well-prepared personal position, I set out to collect information systematically. My method consisted of recording stories first of all without caring about truthfulness or possible exaggeration. Next, I compared the Makanunki stories with those of the Tukulor or the other peoples involved. One can always do this, find groups in every region whose stories will provide a control for statements made by the principals. It was a long task. Gathering information took me over 15 years, it meant journeys that took me from the Fouta-Jalon, Senegal, to Kano, Nigeria, so that I could retrace the routes both Shekau Amadou and Al-Hajj Umar had followed in all their travels. In this way I recorded the stories of at least 1,000 informants. In the end I kept only those statements that agreed, those that were congruous with both the Makanunki and Tukulor traditions and also with those of the other peoples concerned, the sources for which I cited in my book. I found that on the whole 1,000 informants had respected the truth of events. The thread of the story was everywhere the same. The differences, which affected only minor details, were due to the quality of the reciter's memory, or his particular spirit. Depending on what ethnic group he belonged to, he might tend to minimize certain defeats or try to find some excuse for them. But he did not change the basic data. Under the influence 198 of the musical accompaniment, a storyteller might let himself be a trifle carried away by his enthusiasm, but the general outline remained the same. Places, battles, victories and defeats, meetings and parleys, things said by the chief characters, and so forth. That experience proved to me that oral tradition was perfectly valid from the scholarly point of view. Not only is it possible to compare the versions of different peoples, as I did, to exercise a control, but society itself exerts a permanent auto-control. No reciter could allow himself to change the facts. For there would always be comrades or elders in his entourage who would immediately pick up the error and call him a liar to his face, a gravely injurious accusation. Professor Montiel once mentioned me as having reported in the history of the Fulani Empire of Messina stories which his father had collected 50 years earlier and not one word of which had varied. That gives some idea of the fidelity with which data are preserved in oral tradition. Characteristics of the African memory. Among all the peoples of the world, it has been found that those persons who do not write have the most highly developed memory. I have given the example of genealogists able to retain an unbelievable mass of data, but one could also adduce the example of certain illiterate businessmen. I still know many such, handling deals that may involve tens of millions of francs, lending to many persons as they travel about, and keeping in their head the most accurate account of all these movements of merchandise and money without the slightest written note and without making the slightest mistake. Datum to be remembered is inscribed on the traditionalist's memory at one stroke as on virgin wax, and there it remains, constantly available, in its entirety. 18. One peculiarity of the African memory is its restoring the recorded event or story in its entirety, like a film that unreels from beginning to end, and restoring it in the present. It is a matter not of remembering, but of bringing up into the present a past event in which everyone participates, the person who is reciting and his audience. The whole art of the storyteller lies in that. No one is a storyteller unless he can report a thing as it happened live in such a way that his hearers, like himself, become new living, active witnesses of it. Every African is, to some extent, a storyteller. When a stranger arrives in a village he bows and says, "I am your stranger." They reply, "This house is open to you. Enter in peace." Then they say, "Give us news." Then he relates his whole history. From the time he left home, what he has seen and heard, what has happened to him, and so on, and that in such a way that his hearers are with him on his travels and relieve them with him. That is why the tense of a story is always in the present. In general, African memory records the whole scene, the setting, the characters, their words, even their clothing to the smallest detail. In the Tukulor war stories we know what embroidered Bubu the great hero Umeral Dondo wore in a given battle, who his groom was and what became of him, what the name of his horse was and what became of him, and so on. All these details give color to the story and help make the scene come alive. That is why the traditionalist cannot summarize, or can only do so with great difficulty. If he is asked to summarize a scene, for him that is the same thing as making it disappear. By tradition he has no right to do that. Every detail has its importance for the truth of the picture. He tells the story in its entirety or not at all. He will answer such a request with, "If you haven't time to listen to me, I'll tell the story some other day." In the same way, he is not afraid of repeating himself. No one gets tired of hearing the same story told over in the same words, as he has perhaps told it many times over already. Each time the whole film unreels again. The event is there, restored. The past becomes the present. Life is not to be summarized. At most, one can shorten a story for children if one has to, telescoping certain sequences, but then it will not be taken for true. When dealing with adults, one relates a fact or one refuses to speak. This peculiarity of the traditional African memory, bound up in a context of oral tradition, is in itself a guarantee of authenticity. As for the memory of the traditionalists, especially the Datna traditionalists or masters who encompass vast fields of traditional knowledge, this is a veritable library in which the archives are not classified, but are completely inventoried. For a modern mind it is chaos, but for traditionalists if there is chaos it is in the manner of molecules of water that mingle in the sea to form one living whole. In that sea they move with the ease of a fish. The intangible catalogue cards of oral tradition are maxims, proverbs, tales, legends, myths, etc., which may be skeleton outlines to be developed further or subject entries for didactic stories, old or improvised. For example, stories, especially initiation stories, have a basic thread which never varies but to which the narrator may add flourishes, developments or teachings suited to the understanding of his listeners. It is the same with myths, which are digests of knowledge in synthetic form which the initiate may always elaborate or go into more deeply for his pupils. We must pay attention to the contents of myths and not catalogue them too quickly. Realities of very various orders are often concealed in them. 200. Sometimes they are even to be understood at several levels simultaneously. While some myths refer to esoteric knowledge and veil what they teach, even as they pass it on down through the centuries, others may bear some relation to actual events. Take the example of Theanaba, the mythical Fulani serpent. Legend traces its adventures and its migration through the African savanna from the Atlantic Ocean. Around 1921 the engineer Bellarmé, who was in charge of building the Sanzanding Dam, was curious enough to follow the trail of the geographical clues in this legend, which he had learned from Hammadi Gaudo, a great Fulani knower. The result was that to his surprise he discovered the path of the former bed of the river Niger. Conclusion. For Africa the present era is one of complexity and commotion. In Africa, different worlds, different mentalities, different periods are superimposed, interfering with one another, sometimes influencing one another, not always understanding. The 20th century is cheek by jowl with the Middle Ages, the West with the East. Cartesianism, a particular way of thinking the world, brushes against animism, a particular way of living it and experiencing it in the whole being. The modern young leaders govern with mental patterns and systems of law or ideologies directly inherited from foreign models, peoples, and realities which depend on other laws and other mental patterns. For instance, in most of the territories of former French West Africa, the legal code worked out on the morrow of independence by our young jurists, fresh out of French universities, is purely and simply copied from the Napoleonic Code. The result is that the population hitherto governed by sacred, inherited ancestral customs which had ensured social cohesion does not understand why it is being judged and condemned in the name of a custom that is not its own, that it does not know, and that does not square with the fundamental realities of the country. The whole drama of what I shall call basic Africa is that it is often being governed by an intellectual minority who no longer understand it, along principles that are incongruous with it. For the NEW African intelligentsia, trained in Western university disciplines, tradition very often has ceased to live. Tradition is a matter of old men's tales. However, it must be said that for some time now a great many cultivated young people have felt a growing and urgent need to turn back towards ancestral traditions and disengage the fundamental values in them, in order to find their own roots and the secret of their own innermost identity. By contrast, in basic Africa, which is usually far from the big towns, those western islands, tradition has remained alive and, as I have indicated, a very great number of its representatives or repositories can still be found. But for how much longer? 201. The great problem of traditional Africa is in fact the break in transmission. In the former French colonies, the first great break came with the War of 1914, most of the young MEN having enlisted to go and fight in France, whence many of them never returned. These young MEN left the country at the age when they ought to have been undergoing the great initiations and deepening their knowledge under the guidance of their elders. The fact that it was compulsory for important men to send their sons to white schools, so as to cut them off from tradition, also fostered this process. The major preoccupation of the colonial power was, understandably, to clear away autochthonous traditions as far as possible, and plant its own conceptions in their place. Schools, secular or religious, were the essential instruments of this undermining. The modern education our young MEN have received since the end of the last war finished off the process and created a true phenomenon of acculturation. Initiation, fleeing the large towns, took refuge in the bush, where, because of the attraction of the large towns, and because of new needs, the old MEN found fewer and fewer docile ears to which they could transmit their teaching. For, in the stock phrase, teaching can only be given by the sweet-smelling mouth to the well-cleaned ear, that is, the keenly receptive ear. For oral tradition and all that bears on it, therefore, we stand today in the presence of the last generation of great repositories. That is why the work of collecting must be intensified over the next 10 or 15 years, after which the last great living monuments of African culture will have vanished, and with them the irreplaceable treasures of a peculiar education, at once material, psychological and spiritual, based on a feeling for the unity of life, the sources of which are lost in the mists of time. To succeed in this great work of collection, the researcher must arm himself with great patience and remember that he must have the heart of a dove, the skin of a crocodile, and the stomach of an ostrich. The heart of a dove, so as never to become heated or angry even if disagreeable things are said to him. If people refuse to answer his question, it is pointless to insist, he may as well go sit on another branch. A dispute here will have repercussions elsewhere, whereas a discreet departure will make him regretted and often lead to his being summoned back. The skin of a crocodile, so as to be able to lie down anywhere at all, on anything at all, without a fuss. And the stomach of an ostrich, so as to be able to eat no matter what without being disgusted or falling ill. But, most important condition of all, the researcher must be capable of renouncing the habit of judging everything according to his own criteria. To discover a new world one must be able to forget one's own, otherwise one merely carries that along with one and does not keep one's ears open. The Africa of the old initiates warns the young researcher, through the mouth of Tirno Bakr, the sage of Bandiagara. If you wish to know who I am, if you wish me to teach you what I know, Cease for the while to be what you are, and forget what you know. African archaeology and its techniques including dating techniques. Z. Iskander. Introduction. When an archaeologist discovers an artifact, he usually starts studying it by purely archaeological means, such as recording the stratum in which it was found, reading the text found on it, describing its shape, finding its dimensions, etc. The data obtained will then be studied stratigraphically, philologically and typologically, and sometimes important archaeological information may be obtained as regards its date, origin, etc. In most cases, however, the archaeologist may not be able to find any data which answer his questions or help him draw any conclusion from the information available. In such cases, he has to submit his find to other disciplines for scientific investigation. This investigation is supposed to give useful information about its material, origin, technique of manufacture, date, purpose for which it was used, etc. It might be stressed, however, that this investigation should only be considered as another criterion by which the archaeologist can tackle a particular problem. The scientific evidence should be taken together with such points as stylistic, philological and stratigraphy. Considerations. 1. Other scientific techniques which may assist archaeology are field surveys of archaeological sites underground without digging and the conservation of the antiques and monuments discovered. Scientific techniques used apply to all archaeology. They apply to African archaeology in the same way as to European, Asian or American archaeology, but sometimes the methods of application differ. The subject is very wide, and therefore we shall deal with the following items in a general way without entering into much laboratory detail. I. Analytical techniques used in archaeometry. 2. Aims of archaeometric investigation and analysis. 3. Dating techniques. 4. Techniques used in archaeological prospecting. 5. Techniques of conservation. Analytical techniques in archaeometry. Techniques of analysis have increased to such a degree that it is sometimes difficult to decide what technique to use on a particular sample to get the information needed. In the following section, this question is discussed from all its aspects. Choice of the method of analysis to be used. Archaeological samples are exceptionally valuable for two reasons. First is that the quantity of material available is usually so small that it may be hardly sufficient for one complete analysis, and if completely used it may not be possible to replace it. The second is that a part of the sample has to be kept for future reference or display. Accordingly, great care has to be taken to ensure that the greatest amount of information may be obtained from an archaeometric analysis. The criteria determining the method of analysis to be adopted can be summarized as follows. 2. Availability of material. If the amount of available material is big enough, wet chemical analysis is preferable for determining the percentages of the principal constituent elements in the sample, since this method gives the most accurate results. Atomic absorption analysis can be applied to determine the percentages of the alkali metals such as sodium, potassium, and lithium. For trace elements and compounds, however, X-ray fluorescence and X-ray diffraction analyses are to be preferred, although they will give results which may be only within 10 to 20% of the correct answer. If only a very small amount of the sample is available and several elements have to be estimated, it can be best analyzed by spectrophotometric methods or by X-ray diffraction methods. If the archaeologist is not willing to provide a piece, however small, of the object, the material can be analyzed by emission spectrometry or by X-ray fluorescence, provided the size and shape of the object permit the apparatus in question to be used. Kind of material to be analyzed. Archaeological materials vary greatly in kind. Some of them are wholly or partly organic, such as foods, ointments, resins, oils, waxes, etc. Others are inorganic, such as metals, pigments, ceramics, glass, plaster, etc. Organic materials are usually submitted to ignition, saponification, solvent extraction, infrared survey, thermal analysis, or chromatographic analysis. Inorganic materials are submitted to ordinary wet chemical analysis. Emission spectrometry, X-ray fluorescence, X-ray diffraction, or neutron activation, according to the information needed. 2 IOC. CIT. 207. Kind of information needed. To save time and expense, the analysis must be performed according to a well-planned program designed in cooperation with the archaeologist to answer specific questions. For example, ancient copper and bronze look superficially similar, so in order to differentiate between them, only tin is tested for. This is usually done by treating a small part of the sample with concentrated nitric acid followed by dilution with distilled water when a white precipitate of metastannic acid is formed. This test can even be carried out by the archaeologist himself. Also, lead minerals were used at one time for glazing ceramics in Egypt, therefore only lead need be tested to determine roughly the date at which a glazed object was made. Presentation of results. Since the archaeologists WHO are going to study the results of scientific investigation and use them for their commentary, and conclusions are not usually themselves scientists, the results should be presented to them in an easily understandable manner. Thus they should not, for example, be expressed as gram equivalents of a certain constituent per iograms of sample. It will be more helpful to express all results as percentages so that they may be universally understood. Moreover, this will make comparison of results between different laboratories easier. Methods of examination and analysis. In the light of these considerations, we can list the most important analytical techniques used in archaeometry as follows. Microscopic examination. To get a preliminary idea about an ancient material or artifact, an examination with a simple magnifying glass, IOX or 20x, is often very useful. A better device for such an examination is a binocular pattern having a magnification of 7x, 10x, or 20x and a long working distance between object glasses and focal plane. This latter feature permits observation of the bottom of deep cavities into which magnifying glasses cannot enter. To obtain a clearer idea, the sample can be examined with a compound microscope 100x, 200x, 400x, and 1250x with oil immersion. Microscopic examination can be applied for the following purposes. A. Identification. In most cases it is possible to identify a given sample, whether pure or composed of a heterogeneous mixture, by studying microscopically its grain size or the crystalline forms of its constituents. B. Qualitative analysis. Techniques are now available for precipitation, dissolution, observation of gas evolution and other processes which can be 208 carried out on a minute part of the sample. 3. For example, if a small part of the sample is put on a slide and a drop of water is added to it, it can be observed whether it dissolves or not. If a drop of silver nitrate solution is added to this solution and a white precipitate insoluble in nitric acid is formed, a chloride anion is present. C. Quantitative analysis. microscopic methods are particularly valuable. In the quantitative analysis of complex heterogeneous mixtures which are not readily amenable to ordinary chemical methods. For this is usually done by counting the number and determining the size of the different components of a powdered sample. The volume percentages of the components in the mixture can be converted into approximate weight percentages if the density of each component is known. 5. Radiography. Radiography is essential in the examination of works of art to detect whether there are any objects stuffed, for instance, inside a wrapped mummy, or whether there is any decorative inlay hidden under layers of corrosion. Such information is necessary to decide on the correct procedure to follow in unwrapping mummies or conserving metallic artifacts. Taking X-rays of the royal mummies in the Cairo Museum, for example, revealed that some of even the unwrapped ones still have jewelry which has escaped detection because it lies under thick layers of resin. 6, Plate 9.1. Specific gravity determination. Gold in antiquity usually contains silver or copper. Gold objects are so precious that in most cases no samples, however small, can be spared from them for analysis. Cayley, therefore, thought of applying the method of specific gravity determination, which is a completely non-destructive method, to find out the percentage of gold in artifacts. 7. This method is very easy and is conducted by using Archimedes' LAW. If the weight of the object in air is Wgm, and its weight in water is Xgm, its specific gravity, Sg, will W. Since the Sg of gold, 19:3, is nearly double that of silver, 10:5, or of copper, 89, the presence of small amounts of silver or copper can be detected. Assuming that platinum is absent, that the alloying component is defined, silver or copper, and that no contraction occurs in alloying, the likely error in determining the gold content is of the order of I%. Ordinary chemical analysis by wet methods. These methods are indispensable in archaeological work for the study of the material of the artifact as well as for deciding a suitable method for its conservation. They are usually used for the qualitative and quantitative analyses of mortars, plasters, corrosion products of metallic artifacts, food stuffs, cosmetic materials, refuse of embalming materials, etc. A description of the methods used for such analyses is not included in this work. All chemists working in the field of archaeology are well acquainted with them. They are described in detail in analytical chemistry textbooks such as those of Koldhoff ETA/8 for inorganic materials, and in the work of Iskander 9 and Strauss 10 for organic and inorganic materials. Iron. Objects discovered at Niani, Guinea, and dating from about the 13th to the 15th centuries of our era have been chemically analyzed and proved to contain copper, phosphorus, nickel, tungsten, titanium, and molybdenum as impurities probably present in the ores used. 11. Emission spectrometry. This technique is used for the analysis of ancient bronzes, ceramics, mortars, pigments, etc. There are several factors which make emission spectrometry particularly useful when compared with other methods of trace analysis. The sensitivity achieved is generally adequate and it permits the detection of a high proportion, up to 20%, of most of the elements present. Moreover, all the proportions of the elements present in the sample can be recorded by lines on a photographic plate in one exposure and so provides a permanent record which can be referred to at will. ANEW. Variation in emission spectrometry has been provided by the development of the laser milliprobe spectrometer. 12 Spectrographic analysis of the naturalistic Nigerian Ife bronzes showed that they are made not of bronze, but of brass. 13. Atomic absorption analysis. This method is suitable for samples of any inorganic material such as metals, cements, solders, glass, glaze, salts, etc. The advantages of this method in archaeometry are that a high degree of accuracy can be achieved, about 1% error, using samples of 5 to 10 mg, that major, minor and trace elements can be determined in the same sample, and that the technique is a standard one so that interlaboratory comparisons can be made with confidence, as the possible sources of experimental error can be more easily controlled. 14. X-ray fluorescence. Excitation of a specimen by X-rays provides a useful method for analysis. The principle is that when an atom is bombarded with X-rays of high energy, an electron is removed from an inner orbit of the atom, and the vacancy thus created is filled by an electron from an outer orbit. The difference in energy between upper and lower level appears as secondary or fluorescent X-rays characteristic of the elements composing the specimen. Since the depth of penetration of the X-rays is limited, this method can only be used on the surface of objects, and accordingly it would only be suitable in the analysis of such objects as glass, faience, and pottery, glazes, obsidian and most kinds of stone. Ancient metal objects, however, suffer depletion, since the less noble metals partly migrate towards the surface, and therefore a surface analysis of such objects by this method may give very different results from that obtained if the whole object were analyzed. 16. Neutron activation analysis. In this technique a group of samples and chemical standards of known composition are placed in a nuclear reactor and irradiated with thermal energy neutrons. SOME of the isotopes so produced will have suitable half-lives and will emit Y-rays. Since each radioisotope emits Y-rays having wavelengths characteristic only of that isotope, the analysis of these rays enables us to identify the elements present in the specimen and to determine the concentration of both the main elements and the trace elements in it. Neutrons and Y-rays have a much greater penetrating power than X-rays. This allows an analysis from a greater thickness of specimen and hence decuprification effects in metals can be ignored. 17. In performing such an analysis, however, it has to be borne in mind that if the specimen has to be returned to the museum, the residual radioactivity must decay to a low level in a reasonable time. Radiosilver, for example, has an isotope of 225 days half-life, and if too high an irradiation dose is given to a silver object it might not be possible to return it to the museum for hundreds of years. 8. In such a case, therefore, an extremely small amount of the silver is taken from the specimen by rubbing it against a small disc of roughened quartz. This streaked quartz is then irradiated in the reactor and analyzed for silver, gold, copper, antimony, and arsenic in the usual way. This method has been applied very recently to the study of glass beads in African archaeology, subjecting them to 2 neutron activations. First bombardment was brief and the samples were analyzed immediately after. For short-lived isotopes, second bombardment was intense and continued for 8 hours. The samples were set aside for a few days and analyzed. For medium-lived isotopes, set aside again, and later analyzed for long-lived isotopes. 19. A survey of the many applications of this technique in archaeometry is given by Sayer and Myers. 20. Aims of archaeometric analysis. Most important aims of scientific investigation and analysis in archaeometry are the following. The exact identification of materials. An exact identification of archaeological material is essential to ensure an accurate description because a significant interpretation of the object concerned usually depends on knowing the exact nature of the material it comprises. Errors of identification are, unfortunately, not infrequent in the older archaeological literature and have caused a lot of perplexity. Copper is sometimes confused with bronze, although the discovery and use of bronze posits a certain cultural revolution. Bronze is sometimes confused with brass, and hence a wrong conclusion may be reached as to the date of the object since brass was first made at about the middle of the 1st century before our era, while bronze had been known and used some 20 centuries earlier. 21. Since most inaccurate identifications arose from a dependence on visual appearance, it must be emphasized that the identification of archaeological material must be based upon chemical examination or X-ray diffraction analysis so that misleading interpretations may be avoided. Translation of UNKNOWN ancient words. Accurate identification serves sometimes to clarify the meaning of unknown words. For example, 2 pots were found in the tomb of King Horaha, 1st dynasty, about 3100 before our era, at Saqqara in Egypt. On each of these pots is written in hieroglyphic the word Sarid whose meaning was not known. Chemical analysis showed that the contents were cheese and 19c. C. Davison, 1973. 20e. V. Sayer and P. Myers, 1971. 21e. R. Cayley, 1948. 212. It was therefore concluded that Sarid meant cheese. 22. Another example is the hieroglyphic word bekan written on some stone statues. Since the stone had been identified as greywacke, schist, in some other cases and this word was used in texts connected with Wadi, Hammamat, it was concluded that most probably bekan meant the greywacke of Wadi. Hammamat. 2-3. Detection of the sources of materials. The presence of numerous specimens of a material of foreign origin at an archaeological site is a clear indication of the import of such a material through trade or commerce. If the source of this material can be located, then the path of the trade can be established. For example, it is known that obsidian does not occur in Egypt, nevertheless, it was used in Egypt as early as pre-dynastic times, before 3100 before our era. Some objects made of this obsidian were examined and compared with the obsidian found in neighboring countries. It was found to be very similar to the obsidian of Ethiopia, hence it is concluded that it was imported from Ethiopia and that there had been trade relations between the two countries from very early times. 24. Determination of trace elements in pottery by neutron activation or X-ray fluorescence can afford a means of studying trade routes both locally and between different countries. 25. Trace impurities in copper ores and artifacts can help also in establishing the relationship between the artifacts and the kind of ore from which the material of the object was derived. 26. Determination of nickel in an ancient iron artifact affords a means of deciding whether it is meteoric iron or man-made iron, since meteoric iron always contains nickel in the ratio of 4 to 20%. The famous iron dagger of Tutankhamun has been examined for the author by emission spectral analysis, and it has been shown that the iron of the dagger contains a good quantity of nickel, thus proving that the iron is of meteoric origin. Finding out the purpose for which a material was used. Sometimes it is difficult to know for what purpose a certain material was meant to be used. In this respect chemical analysis may be of great help. 4. Example, in the tomb of Neferupta, about 1800 before our era, which was discovered in the Fayum in Egypt in 1956, a very large alabaster jar was found to contain 2 to 5 kilograms of a strange material. Chemical analysis showed it to be composed mainly of 48-25% galena, natural lead sulfide, and 51-6% resin, i.e. of galena and resin in the ratio of I approximately. Such a composition had never been found before, and therefore the reason why it had been put in the tomb was completely obscure. However, on consulting the prescriptions given in the Ebers Papyrus, it was found that prescription No. 402 states, another remedy for the removal of white spots which have arisen in the 2 eyes, black coal galena and KTWA resin are ground fine and put in both eyes. From this text and the chemical composition of the material contained in the jar, it was concluded that this was a medicament for the eyes, that Neferupta most probably had glaucoma in one or both of her eyes, and that is why she was provided with a great quantity of this medicament for use in the hereafter. 27. Determination of the details of ancient technical processes. Examination of ancient objects by scientific methods can yield information about the techniques utilized by ancient people in their chemical arts and industries. This can be shown by the following examples. Manufacture of Egyptian blue. Specimens of this blue pigment have been examined chemically, microscopically and by X-ray diffractometry, as well as a similar blue frit, which has been reproduced experimentally. These studies proved that Egyptian blue was made in ancient times by heating to 840 degrees Celsius a mixture of sand or powdered quartz, powdered limestone, malachite, and a flux of common salt or natron. 28. Microscopic examination of metal objects. Metallographic examination of metal objects can show whether they were produced by casting or by hammering or by a combination of both. 4. Example, a copper staple from the Cheops boat discovered in 1954 behind the Great Pyramid at Giza has been examined metallographically, and it was revealed that the metal has a fragmented dendritic character, plate 9.2. Thus proving that it had been shaped by hammering. 29. Examination of the refuse of embalming materials. Examination of samples of the refuse of embalming materials discovered in Saqqara, Luxor, and Materia in Egypt proved that they contain a small proportion of soaps of solid fatty acids which were formed as a result of the saponification of the fats of the body by the action of natron during mummification. From this it was concluded that in the process of mummification such materials had been used for the temporary stuffing of the body cavities prior to its dehydration in a heap of natron on the bed of mummification. 3 degrees. Glass fritting crucibles. The scientific investigation of some of the remains of a glass factory in Wadi el-Natron showed that glass was manufactured in 2 stages in Egypt during the Roman period. The first stage was to prepare the glass frit by heating together a mixture of silica quartz, calcium carbonate and natron, or plant ash or both, in a special kind of crucible, the fritting crucible, at a temperature less than 0 degree C. The clay of which this crucible was made contained a high proportion of sand and finely chopped straw. Such a mixture would produce a highly porous pottery when baked, a characteristic which was clearly intended by the ancient glass maker so that he could easily release the frit block, plate 9.3, by breaking the crucible. So it was used only once. The second stage was to obtain a good quality glass of various colors. The frit blocks were ground into a fine homogeneous powder and divided into small batches. To each batch certain colorant oxides, opacifiers or decolorizing agents were added and reheated until complete fusion in order to obtain the kind of glass required. 31. Testing of authenticity. For many years, the historic and aesthetic approach was the only method of judging authenticity. In more recent years, great progress in scientific examination has made it possible to judge the genuineness of an object with greater certainty. The most effective scientific methods used for testing authenticity are the following. Examination under ultraviolet light. This technique is particularly useful for the examination of ivories and marbles. Under ultraviolet light, different marbles fluoresce different colors, and the surface of ancient marble frequently has a characteristic fluorescent color which is very different from that of fresh stone of the same kind. On this basis also, alterations or repairs in an ancient marble or ivory object or a painting, which are not visible in ordinary light, become strikingly conspicuous when the object is scrutinized under ultra-violet light. Similarly, infrared light and X-rays have been found useful in the detection of forgery. 32. Examination of the surface corrosion crust. Ancient metals usually corrode slowly, and a coherent corrosion layer or crust is formed in the course of time. In metal fakes, an artificial crust is usually applied to the surface to give it an ancient appearance. This crust is found to be comparatively loose and can be removed by solvents such as water, ethyl alcohol, acetone, or pyridine. Moreover, on copper and bronze objects, this artificial crust will in most cases be composed of one layer and can easily be distinguished from the naturally formed crust, which is always composed of at least two layers, the inner of red cuprous oxide and the outer of green basic copper carbonate or basic sulfate or chloride. Such an arrangement cannot be intentionally imitated in such a way as to deceive an experienced chemist in an archaeological museum. Analysis of the material of the object. A very striking example of such a technique is the analysis of the core of ancient Egyptian faience. While the core of the genuine ancient Egyptian faience is made up of quartz frit, the body core of modern faience fakes is usually made of kaolin or china clay, and this affords a quick and reliable test of authenticity. Another example is that ancient metals contain certain impurities such as arsenic, nickel, manganese, etc., since the ancient metallurgical techniques did not adequately refine metals. Therefore, if a small sample taken from an inconspicuous place on the artifact is analyzed by neutron activation or X-ray fluorescence and proves to be free of such trace elements, the object is most probably a fake. Identification of pigments and media in painting. By microchemical techniques it is possible to identify the pigments used in a painting with reasonable accuracy. If the pigment proves to be among the recently discovered ones, the painting is a fake. For example, a painting, purportedly a 15th century profile portrait, was examined by Young. The blue pigment proved to be synthetic ultramarine, which was not discovered and used as a pigment before the 19th century. The white pigment was found to be titanium oxide, which was not used in painting before 1920. The painting proved, therefore, to be a forgery. 33. Examination of surface patina and polish. Most stones acquire in the course of time a surface patina or desert varnish. This is formed as a result of the migration of iron and manganese salts to the surface, where they are deposited as oxides which form a kind of epidermis or patina. Since this patina forms a part of the stone, it is coherent to the surface and cannot easily be removed by washing with a neutral solvent or by scraping. It is consequently possible to distinguish an authentic aged surface from a freshly carved surface even if it is artificially patinated. Apart from the naturally formed patina, the marks of ancient carving and polishing may afford means of deciding authenticity. These marks still show themselves as irregular intersecting lines under the surface patina of stone or metal and are easily distinguishable from the regular parallel lines due to recent polishing, since the ancient people did not use coarse files in carving, nor fine files or emery paper for polishing. Testing the thermoluminescence of pottery. In pottery as well as in the soil in which it is buried, there exists a very small percentage of radioactive elements. These emit a certain amount of radiation which causes an accumulation of electrons over thousands of years in the body of the pottery. On heating such pottery to a temperature above 500 degrees Celsius, the accumulated electrons are released as thermoluminescence, which varies according to the age of the pottery. Thermoluminescence, therefore, provides museum curators with very powerful evidence as to whether a pottery object is imitation or genuine. The sample for testing is obtained by drilling a small hole in an inconspicuous position, and the powder obtained is heated to above 50 degrees C in darkness. If thermoluminescence is produced, the pottery is genuine; if not, it is a forgery. 34. Dating techniques. Science affords several techniques for dating ancient materials. The main techniques used in this respect are the following. ROUGH dating by archaeometric analysis. An analysis of specimens of the same groups of materials, such as mortars, glass, faience, metals, and pigments, but of different known dates, may give results which can be used as a clue to indicate roughly dates for other specimens of unknown dates. The following examples illustrate this. Dating by analysis of glass beads from West Africa. Dichroic Akora beads, which appear blue by reflected light and greenish yellow by transmitted light, were subjected to X-ray fluorescence analysis. They were found to fall into two groups. Group A was found to be much poorer in lead, less than 0.05%, and arsenic, less than 0.05%. Then Group B, in which lead is about 27% and arsenic is about 2%. There is also a smaller difference in the manganese content. Group A 0 to 3 plus or minus 0.01%, Group B about 0.05%. Other elements determined were iron, cobalt, copper, zinc, rubidium, strontium, tin, antimony and barium, but no striking differences were noted. Group A beads are found in West Africa in relatively old inland sites, 430 to 1290 of our era, while Group B is found only in younger contexts. The finding of such beads in a tomb or a stratum can afford, therefore, a means for indicating roughly its date. 35. Dating of Southern African paintings by analysis of albuminous binders. Paintings may be dated by determining the number of amino acids in their albuminous binders after hydrolysis. This method has been used to determine the ages of 133 rock paintings from southern Africa with 24% accuracy. The White Lady of Brandberg proved to be 1200 to 1800 years old. Limpopo paintings ranged from 100 to 800 years in age. Drakensberg samples ranged from 60 to 800 years in age. The number of amino acids which could be identified decreased with the age of the painting. From 10 in the binders 5 to 10 years old to 1 in materials 1200 to 1800 years old. 36. Dating by analysis of mortars. Analysis of various mortars used in Egypt showed that lime mortar was not used before the time of Ptolemy I, 323 to 285 before our era. 37 ANY. Monument whose bricks or stones were bound together with lime mortar. Would, therefore, belong to a period later than 323 before our era. Radiocarbon dating. Basic principle. WHE and cosmic rays strike the atoms in the upper layers of the atmosphere. They cause them to disintegrate into tiny fragments, among which is the neutron. The neutrons produced bombard the most abundant atom in air, namely nitrogen of mass 14, converting it into carbon of atomic weight 14. This newly formed carbon 14 is radioactive and combines with oxygen from the air, forming I4C02, and is mixed with the ordinary carbon dioxide, which contains mainly non-radioactive carbon atoms of masses 12 and 13 in abundances of 99 and 1% respectively. This carbon 14 enters into the plants together with the ordinary 2C02 and 3C02, forming their tissues by the process of photosynthesis. Since animals feed on plants, all the living animal and vegetable world should be very weakly radioactive owing to the presence of a minute proportion of carbon 14, approximately 1 atom of carbon 14 to a million atoms of ordinary carbon. Atmospheric carbon dioxide also enters the oceans as dissolved carbonate, so this too should be weakly radioactive, and any shells and deposits formed from it. 38. At death, the ancient organic matter is supposed to have had the same radioactivity as living organic material at the present time. But after death, isolation occurs, i.e. further uptake or exchange of radiocarbon would cease, and the carbon-14 starts to decay, or as Professor Libby expressed it, the radiocarbon clock starts ticking. 39. If the radioactivity of an ancient sample is measured and compared with the activity of a modern sample, it is possible, knowing the half-life of carbon-14, 40, to calculate the age of the ancient sample by applying a radioactive decay equation. Materials most suitable for radioactive dating. The materials suitable for this technique must be of organic nature, such as wood, charcoal, bone, leather, cloth, grasses, foodstuffs, shells, etc., but the best suited are those derived from plants growing within a single year, such as reeds, cereals, grass, or flax. The samples should not be treated with any chemicals when first collected, and should be put directly into glass containers or nylon bags to eliminate contamination with any new organic matter. The procedure in general consists of 4 steps, namely, purification of the sample, combustion, purification of the carbon dioxide gas obtained, and, finally, counting of the particles emitted. Results and prospects. In order to test the accuracy of this method, a comparative study of historically well-dated samples and radiocarbon dates has been undertaken. For since the oldest and best understood historical sequence is the chronology of Egypt, it was decided internationally to measure the radiocarbon content of a long series of archaeologically precisely dated Egyptian samples belonging to the time period from the First Dynasty, about 3100 before our era, to the 30th Dynasty, 378 to 341 before our era. The dating was carried out in several laboratories at the same time, using both 55-68-year half-life as well as the newer and physically more correct value of 5730 plus 40 years. The results of these laboratory tests showed that radiocarbon dates, using the 5730-year half-life, match well with the historical chronology back to the time of King Senusret III, i.e. to about 1800 before our era, but there are wide divergences between the two dates for the earlier samples. If, however, a correction factor, the Stu versus correction, is applied to the samples which antedate 1800 before our era, the Results will be found to be in agreement with the archaeological dates to within 50 to 100 years at most. 42 for example, reeds taken from the mastaba of Ka'etzak-Tara, 1st dynasty, were dated in the British Museum Research Laboratory. The radiocarbon date obtained is 2450 plus 65 before our era. ON. Applying the correction factor, its date was calculated as 2928 plus or minus 65 before our era, which is very close to its historical date, 2900 before our era. 43. The speculation at the moment is whether the main deviation is due to a weakening of the Earth's magnetic field 44 or to variations in the intensity of the solar wind which fends off cosmic rays. 45. Moreover, the actual half-life of radiocarbon is not entirely certain. Some other causes are under consideration and research is being carried out in many laboratories on this problem. If all these questions were answered, it would be possible to date with greater precision on periods earlier than 1800 before our era. Until then, conventional radiocarbon measurements of ancient organic samples from these periods must be corrected as indicated above. Potassium-argon dating. The limitation of radiocarbon dating to about 70,000 years leaves a long gap in the chronology of biological and geological development, extending from this date to about 10 million years earlier. For this very early period it would be possible to apply established geological radioactive methods based on the rates of change in certain substances such as the change of uranium-235 to lead-207 which has a half-life of 710 million years, or rubidium-87 to strontium-87 which has a half-life of 13,900 million years. The gap can be filled to some extent by applying the technique of potassium-argon dating. 46. In fact, this method is used particularly for the dating of lower geological ages, but by using large samples of a substance of comparatively small grain size, but not less than 100 Y, and containing only little atmospheric argon, it is possible to apply it to comparatively more recent periods which may even overlap with carbon-14 results. 47. Basic principle. Potassium as we find it now in nature contains 93 to 2% potassium 39, 6 to 8% potassium 41 and 0.18% or potassium 40. At the time of the formation of the Earth the abundance of potassium 40 was about 0 to 2%, but most of it decayed into two daughter products, calcium 40 and argon 40. Since potassium 40 has a very long half-life, 1,330 million years, a small amount of it amounting to 0.00118% is still present. For 100 atoms of potassium 40 which decay, 89 become calcium 40 by beta decay, and 11 become argon 40 by capture of beta particles. Argon is a gas and is retained between the grains of the mineral. 48. The potassium-argon dating has found a number of applications for the following reasons. A. Potassium exists in the Earth's crust to the extent of 2 to 8% by weight and hence it is one of the most abundant elements and is contained in almost all materials. B. Argon 40 can be measured more easily than most other elements, even in very small concentrations. C. The half-life of potassium is long enough for appreciable amounts of argon 40 to be formed in potassium minerals within geologically interesting periods. By measuring the concentration of the radiogenic argon 40 and the total content of potassium of a mineral, it is possible to determine the age of the mineral by applying a radioactive decay equation. 49. Problems to be solved by potassium-argon dating. Potassium argon dating has recently been applied to calculate the in situ first order rate constant for the racemization of aspartic acid in old bones. Once the racemization reaction has been calibrated for a site, the reaction can be used to date other bones from the deposit. Ages deduced by this method are in good agreement with radiocarbon ages. These results provide evidence that racemization is an important chronological tool for dating bones, which are either too old or too small for radiocarbon dating. As an example of the application of this technique for dating fossil MAN, a piece of Rhodesian MAN from Broken Hill, Zambia, was analyzed and tentatively assigned an age of about N0000 years. S-degree THE problems which can be solved with the help of potassium argon dating of the Pliocene and Pleistocene. Periods include the determination of an absolute timescale dating the origin of MAN, the coincidence in time of fossils in the different parts of the Earth, and the origin of tektites as well as other special geological problems. Potassium argon dating has been used to determine the ages of the basalt layers and the overlying tuff layers in Old Uve with the aim of determining the absolute age of the Zinjanthropus remains which were found near the bottom of bed I of tuff. Kurt and Ivernden concluded that the basalts at Old Uve are at least 4 million years old, but are unreliable for dating purposes because of chemical alterations visible in thin sections of all dated Old Uve basalts except those associated with the older pebble tool industry. Gentner and Lippold comment on the different results obtained by reporting that as no further inconsistency exists between the dates of the overlying tuff and the basalts, an age of 2 million years for Zinjanthropus seems to be possible. 51. Archaeomagnetic dating. In order to give a simplified idea about this technique, we shall deal with the following items. Paleomagnetism. This term signifies the study of the remnant magnetism of archaeological remains. It is based on the fact that the magnetic field of the Earth is changing continuously in direction and intensity. Observations over the past 50 years indicate that the changes in direction are at the rate of 0 to 2 degrees of longitude westward per year. 52 Archaeomagnetic investigations based on the measurement of remnant magnetization in baked archaeological objects and in rocks show that the Earth's magnetic intensity during the past 8,500 years had its maximum around 400 to 100 before our era when the field reached 6 times its present intensity, and its minimum around 4,000 before our era when the field dropped to around 0.6 times its present intensity. 53. These effects or variations in direction and intensity are termed secular variation. This is of a regional nature, and it is the basis of magnetic dating. Since the changes in the Earth's magnetic field leave their record in baked pottery as thermoremnant magnetism, TRM. Application of the TRM for archaeological dating. For magnetic dating of baked clay which has remained in situ since firing, it is necessary first to establish the behavior of the geomagnetic field direction by measurements on archaeological structures of known age for the region in which dating application is to be made. THE results are plotted in a curve showing the secular variation in that region over a long period of time. Knowing the direction of the magnetic field recorded in a baked clay of unknown date in the same region, it is possible to determine its date of firing by reference to this secular variation curve. The most suitable samples for magnetic dating are baked clays from kilns, ovens and hearths which have remained in their original places until now. Since a portable magnetometer has not yet been produced to measure their geomagnetic field direction in situ, samples must be removed for measurement in a fixed magnetometer in a laboratory. It is essential that each sample should be marked with its original orientation to serve as a reference for the direction of its OWN remnant magnetism. This is done in practice by capping it with plaster of Paris, taking care that the top surface is horizontal and marking the direction of the geographic north on the horizontal surface of the mold before the sample is detached. In this way, the ancient declination, d, and the ancient angle of inclination, I, can both be determined. 54to compensate for anomalies. 6 or more samples should be taken, preferably from different parts of the structure and in a symmetrical pattern. 55. Archaeomagnetic results for D and I have been obtained for England, France, Japan, Iceland, and Russia. As far as I know, the method has not yet been tried in Africa. It is hoped, however, that it may be applied very shortly. For dating in African archaeology, especially since the method has been appreciably improved in the last few years. Thermoluminescent dating. Thermoluminescence is the emission of light when a substance is heated. It is quite different from red-hot glow, and it is due to the release of energy, which has been stored as trapped electrons in the heated material. Origin. All pottery and porcelain contain small proportions of radioactive components, a few parts per million of uranium and thorium and a few % of potassium. In addition, there are radioactive impurities in the surrounding burial soil, as well as cosmic rays which can penetrate the soil to the burial place of the pottery. These will emit radiations which will bombard the crystalline materials such as quartz in the pottery. The resultant ionization will produce electrons which may become trapped within the crystal structure. These electron traps are metastable, and when a sample of the ceramic is heated, the traps will be dissipated and the excess energy appears as a photon of light. The intensity of this light or thermoluminescence will be directly related to the age. It is also dependent on the particular thermoluminescence constituents in the pottery sample and surroundings. 56 by measuring the amounts of uranium, thorium and potassium present in the pottery fragment and in the soil, the radiation dose received by the fragment each year can be calculated. In principle, the age is then directly calculated using the following relation: 57. Accumulated radiation dose. Age equals dose per year. Accuracy of results and prospects. At present, an absolute accuracy of around plus or minus 10% is achieved. This is somewhat poorer than is obtainable with radiocarbon dating, and is attributed to many difficulties which have arisen, such as the uncertainty about the burial circumstances, and the uncertainty about the degree of wetness of the burial place, which affects the dose rate due to radioisotopes in the pottery fragment. It is hoped, however, that further research will solve such difficulties, but, for various practical reasons, it is not likely to improve this result to a greater precision than plus or minus 5% error. 58. Despite this low accuracy, however, this technique has the advantage over radiocarbon dating that pottery is much more abundant in more archaeological sites than organic material, and that the event dated is the actual firing of the pottery, whereas in the case of radiocarbon dating of wood or charcoal, the event dated is the cutting of a tree and not the date of using it in antiquity. This technique will have a very important application in Egypt. Neolithic and pre-dynastic cultures in Egypt have so far been mainly dated by the types of pottery characteristic of these cultures according to the sequence dating system first invented by Flinders Petrie. 59 NOW. It will be possible by thermoluminescence dating to determine the absolute dates of these cultures. Techniques used in archaeological prospecting. The basic aim of scientific techniques in field prospecting is to discover information on buried archaeological sites either before or instead of excavations. This saves much time, effort, and expense. Archaeological prospecting by scientific methods includes the following techniques. Air photography. This technique is basically used for the recognition of a feature by its geometrical pattern. It has two main applications. First is that it gives a more distant and thus a clearer view fitting the individual surface traces together into more meaningful patterns. 60. The aerial photographs can then be used to identify the areas which have to be excavated to give a complete picture of the whole archaeological complex. This method has been applied for the study of the Karnak temples at Luxor in Egypt, where the area of the site is about 120 hectares. Second application is that it reveals the existence of buried archaeological structures in cultivated land from crop marks. Crop marks result from different moisture conditions in the soil. Crop above a buried stone wall will be weak, showing up as a lightened line, while above a buried ditch, the crop is richer and therefore darker in appearance. From the geometrical layout of these traces, the buried structures can be recognized and excavated. 61. Soil analysis. Remains of ancient inhabited cities and ancient cemeteries can usually be located by an analysis of the soil. Since calcium phosphate is the main constituent of bones and man's other waste materials, its percentage will naturally be much higher in areas of occupation or burial. Therefore, the limits of such archaeological zones can be found by analyzing soil samples taken at regular intervals from the zone and measuring their phosphate content. Pollen analysis. Pollination in flowering plants usually takes place by the action of birds, insects or wind. Flowers pollinated by wind produce large quantities of pollen grains, most of which fall to the ground without being fertilized. These pollen grains usually decay, but if they happen to fall on suitable soil, such as mud or peat bogs, they may become fossilized and can easily be examined under the microscope. Identification and enumeration of the various types of pollen present in a sample is of potential value in archaeology as a means of providing information about the ecological environment in which human remains and artifacts are situated, and a knowledge of the ecological environment may in turn point to the kind of life which prevailed at that time. Pollen analysis is only useful as a technique for dating, however, if the pollen spectra can be related to a time scale based on some direct dating methods such as radiocarbon dating. For further details of this technique, see Fahegri and Iverson, 62 and Dimbleby, 63. Electrical resistivity surveying. This was the first geophysical technique to be adapted to archaeology. In this technique, an electrical voltage is applied to the ground and the resistance to the flow of electric current is measured. The resistance depends upon the nature of the ground, the quantity of water retained in its pores and its content of soluble salts. Hard compact rocks such as granite and diorite have a very high resistivity compared with clay soil. Therefore, resistivity surveying will mainly apply to the detection of stone-built structures buried in MUD soil and earth-field features cut into rock. 64. The normal system used in this method is to insert 4 metal probes into the ground, pass the current between the 2 outer probes and measure the resistivity between the inner 2. The value of the resistance obtained is a rough average for the material beneath the inner probes down to a depth of approximately 1 to 5 times the distance between them, as long as it is fairly uniform. 55. Normally almost all the applications of resistivity surveying consist of making lines of reading, keeping the same contact arrangement and separations in order to locate changes in the measured resistivity values. Often these lines will be combined to give an overall rectangular grid of values, and the location of buried features will be indicated by the parts, which give abnormal readings. This technique has now been somewhat replaced by magnetic prospecting. This is mainly due to some disadvantages, mainly the slow survey speed and dependence on long-term climatic effects, coupled with the fact that the interpretation of results tends to be difficult except in the simplest cases. 66. Magnetic surveying. This is the most common technique used now in archaeological prospecting. In this technique, the intensity of the Earth's magnetic field is measured at points above the present ground surface in the site to be prospected. The variations in these measurements can reveal the presence of archaeological features. By this technique it is possible to detect buried remains of iron, baked pottery structures such as kilns and furnaces, soil-filled pits cut into rock, or rock structures buried in clay soil. The variations due to buried iron objects are very large, but those due to the other categories are very much weaker. Consequently, the technique of magnetic surveying cannot be of any use unless the detecting instrument is sufficiently sensitive to detect very small variations, besides being speedy and simple to operate. 67. The Archaeological Research Laboratory of Oxford University has succeeded in developing a proton magnetometer, which meets all these requirements. 68. It is composed of two parts, the detector bottle and the counter. The detector bottle is carried on a wooden tripod and moved by one operator from point to point over the area to be surveyed. A second operator controls the counter and records the readings. In plan form, The interpretation of the plan should identify the situation and outlines of buried archaeological structures. 69. Other forms of magnetometers have been developed, namely, the differential proton magnetometer, the fluxgate gradiometer, 70. The cesium magnetometer, the electron spin resonance pump magnetometer. 7. Every one of these has advantages, but the most useful form for almost all cases is, however, the differential proton magnetometer. The magnetic method has several advantages over the resistivity method, since it is simpler and faster, and its results are easier to interpret. 72. Probing the Egyptian pyramids with cosmic rays. Cosmic rays consist of a stream of electrically charged particles known as /I mesons or muons. These rays reach the Earth with equal intensity from all points in the sky. A square meter is struck by some IOOO muons per second, whatever its direction may be. Cosmic rays have a very high penetrating power and are much more penetrating than X-rays, and their velocity is almost equal to the velocity of light. Probing with these rays is useful because the muons lose energy as they pass through matter. The loss of energy, or absorption of muons, is proportional to the density and thickness of the matter through which they pass. The intensity or quantity of cosmic rays which passes can be estimated by a device known as the spark chamber, which in the case of the pyramids was placed inside a subterranean chamber. Muons which have passed through a void, or an unknown chamber or passage, would be slowed down to a lesser degree than those which traverse the solid rock, and therefore the cosmic rays which pass through voids would have a greater intensity, and this will be shown by the spark chambers. With two spark chambers oriented horizontally, and about 0.3 meters apart from each other in the vertical direction, it would be possible not only to detect any hidden chamber, but also to indicate its location to within a few meters. Excavation would then be conducted to reach the predicted void or chamber. Probing started in the second pyramid, which belongs to King Chephren. of the 4th dynasty, 2600 before our era. THE data were analyzed by means of a computer and the results were announced on April 30, 1969. Indicating two important facts. The first is that the burial chamber of the king does not fall exactly in the center of the base of the pyramid but lies a few meters towards the north. This finding agrees with the surveying results, thus proving the validity of this technique for probing the pyramids. The second fact is that the upper third of this pyramid does not contain any unknown chambers or corridors. The experiment had to be repeated using another apparatus which was designed in such a way that it would be able to probe the whole pyramid. The analysis of the recorded data indicated that the whole pyramid does not contain any unknown voids, a fact which agrees with archaeological expectations. Techniques of conservation. It is not intended here to describe the technical methods used in the conservation of artifacts made of various materials, such as pottery, faience, glass, ivory, bone, wood, leather, papyrus, woven fabrics, metals, etc., since these are very varied and need much more space than is allowed for this chapter. For their conservation, reference is made to the more 227 specialized books 73 and periodicals, particularly Studies in Conservation, the Journal of the International Institute for Conservation of Historic and Artistic Works, London. The most serious problems of conservation in Africa, however, are the great fragility of materials and the violent deterioration of stone monuments. Great fragility of materials. Owing to the excessive heat and dryness of many countries in Africa, artifacts made of organic materials, such as parchment, papyrus, leather, wood, ivory, etc., have become extremely fragile. Such materials should be handled with great care, lest they should crumble into tiny fragments. They have at first to be kept for some time in a closed wet system, wrapped in damp blotting paper sheets, or treated with steam in a steam box, to restore their malleability wholly or partly. They can then be safely unrolled or unfolded without their breaking into pieces. After regaining their malleability, such artifacts should be exhibited or kept in air-conditioned museums or storehouses at a temperature of 17 degrees plus or minus 2 degrees Celsius and relative humidity of 60 to 65%, so that they may not become brittle again as they would if exposed to dry climatic conditions. Violent deterioration of stone monuments. This grave problem will be discussed in more detail. Main causes of deterioration. The main agencies which cause the severe decay of stone in African monuments are a. Migration of salts. Soluble salts migrate in the presence of water or moisture from the saline soil into the stone monuments by capillary action. In dry conditions, these salts pass in the form of aqueous solutions from the inside of the stone to its outer surface, and may crystallize under the surface, causing it to flake out. These effects are more pronounced on the surface itself, causing its disintegration, or may crystallize at the bottom of walls or columns where the stone meets the saline soil, as can be seen in some of the columns of the Bowen Temple, Sudan, Plate 9.4. b. Drastic atmospheric agencies. In Africa, the stone is badly affected by the great variations in temperature and humidity. These lead to the gradual flaking out of the surface layers of most kinds of stone. In many places, especially in coastal regions, both factors of decay act together, leading to very serious deterioration of the monuments, as can be seen very conspicuously in the Roman temples at Leptis Magna and Sabrata in Libya. Surface treatment and its inadequacy. Extensive trials have been made to consolidate deteriorated stone surfaces by treating them with organic preservatives or inorganic silicates. Such treatment proved not only to be ineffective, but also to be deleterious, since it accelerates deterioration and flaking out of the stone. The failure of these trials has been stressed by the International Symposia on the Conservation of Stone Monuments, which declared that the problem of strengthening stone is still far from solved and that this difficult problem must be approached with care. International efforts to solve the problem. The difficulty of the problem and its seriousness led ICOMOS and the International Center for Conservation to form in 1967 a committee of 10 specialists in stone conservation to study the problem. THE Group has made many studies and presented several reports and continued its activities up to the end of 1975 to draft a series of standard tests to evaluate the degrees of deterioration of stone and the efficiency of various conservation treatments. New Hope. Professor Lewin has developed a new method for the strengthening of limestone and marble surfaces. 74. It comprises the treatment of the deteriorated parts with a hot concentrated solution of barium hydroxide, about 20%, containing some urea, about 10%, and glycerol, about 15%. The method depends chemically on the replacement of the calcium ions in the decayed stone with barium ions. THE treatment causes the stone to become markedly harder and more resistant to the action of deteriorating agents. Since the newly formed barium carbonate forms a continuous part of the body of the stone and does not form a surface coat, which has different properties from those of the inside, this method offered a new hope that the treated surfaces would not scale off and would protect the underlying layers from attack by weathering agents. This treatment was applied in July 1973 for strengthening the disintegrating surface of the neck of the limestone statue of the Sphinx at Giza. The result is satisfactory up to the time of writing, but we shall have to keep the neck under observation for 10 more years at least before we can report on the validity of this technique for the conservation of deteriorating limestone. Remedial measures. Despite the hope we have in Lewin's technique, the problem of conserving stone monuments by chemical treatments has to be considered still unsolved. Certain mechanical measures, however, are recommended to 74 SZ Lewin, 1968. 229. Protect the monuments from the action of deteriorating agencies, namely a. The surfaces of outdoor monuments which are exposed to direct sun rays should not be treated with any preservative solutions which close the pores of the stone, otherwise the surface layers will scale off. b. The soil in which the monuments are constructed must be desalinated periodically by washing with water drained off by a well-designed drainage system. c. Whenever possible, the stone monument is to be insulated from the salty soil to cut off the migration of the soluble salts from the soil to the stone. The insulation can be done by introducing a lead sheet or a thick layer of bitumen under the statue, wall, or column, etc. d. If the monument contains soluble salts which cause efflorescence or cryptofluorescence, these salts have to be extracted by washing with water and or by coating the salt-infected parts with wet sandy clay several times until the stone becomes almost completely free from soluble salts. e. If the monument is fairly small, it can be removed from the open air to a museum or a shelter in order to protect its surfaces from the deleterious effects of atmospheric agencies. An alternative solution is to keep it in its original place and construct a shelter over it. f. A missing roof should be rebuilt to protect interior mural paint. Ings or reliefs from the action of direct sunlight and rain and decrease to some extent the deterioration due to great variations in temperature and humidity. Recommendations for restoration. Since an erroneous treatment of artifacts or monuments may cause more damage or even complete deterioration, some of the important rules of restoration which have been recommended in international conferences may be quoted. A. The patina of old monuments should not be washed off or removed in any way to show the original color of the stone. The cleaning of the facades should be confined to dust removal so as to keep the patina untouched, since it is the most important archaeological character a monument possesses. B. In the restoration of ancient monuments, only the falling parts have to be rebuilt in their original places. Replacements and additions should be avoided unless they are needed for supporting the fallen parts or for protecting the old surfaces from being attacked by weathering agents. C. In all cases of rebuilding, a mortar should be intercalated between the stones so that their weights may be evenly distributed to prevent strains or cracks in the structure. D. The mortar used for the renovation of walls should, as a rule, be identical with the original mortar unless the latter is of gypsum. The use of cement is not to be recommended in the case of buildings constructed of sedimentary rocks such as limestone or sandstone. The mortar most recommended in all cases of rebuilding is salt-free. 230. Lime putty mortar, since it is fairly malleable and porous and would not therefore prevent slight movement of stones due to changes in temperature, and consequently no strains or cracks would occur. F. As regards methods for distinguishing the surfaces of the added stones, the following are worth noting. The facing can be slightly inset from the vertical surface of the original stonework. 2. Different materials could be used but the dimensions of the original blocks be restored. 3. Alternatively, the same type of material could be used but the form and dimensions of the blocks could be made different from those in the original parts. 4. The alignment of the stone courses and all the joints could be conformed to, but new blocks molded using a conglomerate of stone chips of uneven sizes. V. Identification marks carrying the date of restoration could be incised on all new stones. 6. The surface of the new stones could be made entirely distinct from that of the old by pecking it with a pointed tool to give a certain grain or engraving it deeply with a graver to let it acquire a certain geometrical design, preferably of parallel or intersecting lines. P. Diagni. Edicoididna one, fulfolda. Lamii decaldum, wolof. Speech is what gives shape to the past. The African sees a link between history and language. This view is common to Bantu, Yoruba, and Mande. But that is not its originality. Indeed, an Arab or a Greek before the time of Thucydides would certainly agree with the Fulani dictum that narrative is where we meet the past, hanki koi daral arati. What is special about the link between history and language in the African tradition lies in the view of history and language to which that tradition, on the whole, has adhered. Language and thought are often identified, and history is seen not as science but as wisdom and as an art of living. History aims at knowledge of the past. Linguistics is a science of language and speech. Historical narrative and historical works are contents and forms of thought. Language itself is the medium and prop of such thought. Thus, obviously, linguistics and history each have their domain, their particular subject matter and their methods. Nevertheless, there is interaction between them, at least from 2 points of view. Language as a system and tool of communication is a historical phenomenon. It has its own history. as the medium of thought, and that of the past and knowledge of the past, it is the channel and the most important source of historical evidence. Thus linguistics, used here in its widest sense, covers an area of research which supplies history with at least two kinds of data: first, linguistic information properly speaking, and secondly, evidence, which might be termed supralinguistic. Linguistics can be used to see beyond the evidence of thought, beyond the conceptual apparatus used in a language and the oral or written evidence, to the history of men and their civilizations. Once the problem is thus defined, it is easier to see what common ground there is between the historian and the linguist working on Africa. 0. Linguistic sciences and history. All the sciences that take language and thought as their subject matter can contribute to historical research. However, some have a more direct connection with history. This is the established view, though it may, on further reflection, be questionable. Thus it is usual to say the study of relationships between languages is the crossroads between linguistics and history. It is not so easy to say the same of an analysis of the development of material furnished by written or oral texts and by the vocabulary of a language. Yet both types of research are concerned with the facts of language or thought, and thus with the facts of history. Here, European historiography has suggested a separation between historical science properly speaking and literary history or the history of ideas. This distinction is justifiable only in certain contexts. The Congo of the Bantu civilization, the Igbo of Guinea or the Susu of the Sudan have left few, if any, texts which meet the norms of modern historical science. On the other hand, as far as sources of information are concerned, they did produce an abundant oral literature, divided more or less clearly into genres and works which one might nowadays be tempted to classify under the heading of short stories, narratives of various kinds, chronicles, historical epics, legends, myths, philosophical or cosmogoniae works, or technical, religious or sacred thinking. In them, the historically true is mingled with fiction and the purely imaginary with events that can be precisely dated. In order to reconstruct the history of the Congo, the Igbo, or the Susu, use is made not only of the critical analysis of such literature and oral tradition, but also of the critical analysis of their discourse, their techniques, and knowledge through the deciphering of the languages, concepts, and vocabulary which they used, and which still, taken together, reveal the history of each of the groups. We shall refer to various sciences and methods which can be used to guide the African historian. But the list will not be exhaustive. This may be a good thing from the point of view of clarity. The linguist sets reasonable limits to his study, and this enables him to study particular areas in detail. He thus leaves the study of the history of ideas, the sciences, economics, or literature to the appropriate experts. Who then take into account the linguistic dimension of their investigations. Science of classification and the history of the African peoples. To classify languages is to uncover the relationships between the peoples who speak them, and the history of those peoples. Several types of classification may be distinguished. 234. Genetic classification. This classification establishes relationships and affiliations within a linguistic family, and thus helps at least to some extent to re-establish the historical unity of peoples and cultures using languages derived from a common stock. Typological classification. This method of classification groups together languages having obvious structural or systemic similarities and affinities. Languages of identical or quite different origin may have the same kinds of lexical structure, as regards nouns, verbs, or pronouns, whilst at the same time being genetically, historically or geographically far removed. The tendency to use the same noun and verb form is found both in Wolof and English. Lagi by. To work, and. But despite this typological similarity, the two idioms are far removed, both genetically and geographically. Moreover, languages may belong to the same family but be of different types. Their kinship rests on their possession of a convincing amount of a common vocabulary, even though they have developed along different structural lines. Sometimes, owing to lexical borrowings and losses, the differences may be revealed in the lexicon itself. The classifications of African languages so far drawn up do not, for example, group together some members of the so-called Chadic or the so-called Senegal-Guinea families of languages. Yet, on further consideration, their phonological systems, morphology and syntactical structure suggest that, typologically, the majority at any rate of these languages in fact belong together. Geographical classification. This method of classification is mainly the result of an instinctive tendency to compare and group together languages which at the present time exist in any one setting. It is often founded on inadequate data. Where Africa is concerned, this classification, though based on evident geographical considerations, leaves out of account such phenomena as migrations and overlappings of peoples. Coel, Delafosse, Westermann, and Greenberg mainly used topological and geographical denominations and groupings. They thus categorize languages as being West Atlantic, Niger-Congo, Senegal-Guinea, Niger-Chad, and so on. A valid classification of African languages requires procedures which ensure that the forms, vocabulary and linguistic structures which it is proposed to use as elements in a comparison are not only representative of the languages to be compared, but also belong to the original heritage of those languages. Any resemblance should be due neither to borrowing nor to earlier or more recent contacts. 235. For historical reasons which are familiar, Arabic and the Semitic languages and also French, Portuguese, Afrikaans, and English have been depositing a considerable amount of vocabulary in many African languages for several centuries, sometimes for thousands of years. Some variants of Kiswahili contain more than 60% of lexical borrowings from Arabic. It is easy to go one step further, out of religious enthusiasm or lack of scientific care, and conclude that Kiswahili belongs to the Semito-Arabic group. This conclusion has, indeed, sometimes been drawn. Forms which were originally common to more than one language may in the course of time have undergone phonetic, morphological, or structural changes. This development, which is bound by philological rules, is a well-known and analyzable phenomenon. Even the meanings of these forms, the meanings of the words in the vocabulary to be compared, may have varied within the limits of a semantic field which it is possible to some extent to define. The modern form of Wolof, for instance, shows the failure of the final vowel after a geminate, bop or fad replacing bapa or fada, which are still preserved by the Gambians and Lebu. The ancient Egyptian form Neds has become Nedo in modern Fulfulde, and Nid in Wolof. The Bantu says Mutamuntu, the Hausa Mutu, the Mande Mixi or Moxo, the Fo Ngbito, the Mina Igbito, etc. The Egyptian Zemet once meant burnt or black. Today it is used in the sense of ashes, burns, etc. The historical reconstruction of a language as a method of rediscovering the vocabulary and common structural heritage takes account of these Changes. The reconstruction method makes it possible to retrace the history of a language or a language family. It helps to establish the original proto-language, and to date the times at which the various branches split off. To this extent, reconstruction is an invaluable taxonomic aid. Various criteria and techniques are used to reconstruct a language and reinvent its original components. Sound shifts play an important part in the reconstruction of a proto-language or the establishment of a family relationship. It is known, for example, that in one variant the P becomes F and in another the U becomes 0. It is possible, by positing fa pa, lu equals lo, to reconstruct the original phonetic system and forms. Phonological reconstruction. This is a step in the reconstruction of the lexical base and the original vocabulary. The phonemes are not the only things that change, the morphology and structure also develop. The subject function in Latin is indicated by an inflection called the nominative, whereas in languages of Latin origin or influenced by Latin, this function is indicated mainly by word order. Homo vidit equals vidit homo equals l homo vu equals the man saw. In reconstructing proto-languages, Proto-Bantu, Proto-Chadic, etc. 236. Reference is always made to the vocabulary, the common lexical stock. It is thus possible to make a lexical count and work out percentages of words in common. J.H. Greenberg v. Classification mainly relies on this technique. And D. Sapir in his work on the West Atlantic Group 2 also uses this method. He concludes that Sira and Fulani, which he places in the same group, have 37% of words in common, Baga, Koba, and Temne have 79%. Temne and Sira have only 5%, and Baisari and Saifen also 5%. Yet he groups all these languages together in the same family. But the extent of common vocabulary, something that may easily be borrowed, is not enough to prove or disprove a historical link. We therefore take other factors, for example, similarity of typological features or identity of structure, into account by comparing, for example, pronominal, verbal or nominal systems, and so on. The typological component, taken together with the data furnished by lexical and phonological analysis, makes it possible to arrive at results which are all the more convincing in that history and outside influence have been taken into account. Reconstruction also aims to date the period when this common heritage was shared within a proto-language and taken over by related languages then in the process of differentiation. It is concerned to establish the character of the original language that gave rise to the various languages traceable to a single proto-language. Reconstruction and dating can also be used to determine the age of lexical and structural material collected in the course of the study of the languages, and, through comparison, to define with varying degrees of certainty the level at which the languages in question are related. These techniques also provide precise landmarks in the history of the separation of peoples who originally belonged to the same cultural and linguistic world. At the same time, they shed light on the history of ethnic groups and multinational or multi-ethnic civilizations. In research concerned with the recent age and written languages, the task is relatively simple. But in research which goes back 4,000 years or more before our era, the scarcity of evidence makes for difficulties. The task, however, simply becomes one of working out the history of decisive periods of linguistic change. The processes of change in vocabulary or structure, which are examined with this purpose, as we shall see, are very slow. and difficult to grasp. To make up for the scarcity of information, there are techniques of varying effectiveness. Glottochronology is one of the most recent of such techniques which has been applied in the African field. Its principle is that of dating the lexical development of a language from the rate of change of its vocabulary, its cultural vocabulary, philosophical concepts, techniques, etc., and basic vocabulary, names of parts of the body, numbers from 1 to 5, the words for natural phenomena, etc. Glottochronology, as a technique, is intended. 1 J.H. Greenberg, 1963a. 2D. Sapir, 1971b. 237. To provide information on the age and the stage and state of development of lexical terms and forms. The fundamental or basic vocabulary develops relatively slowly in early societies, at least when there are no catastrophic historical changes of influences. In Black Africa, in particular, the work of Delafosse has enabled us to form an idea of this rate of development by using lists of words recorded in writing since the 11th century. Delafosse's work deals with the vocabulary of the languages of the Sudan collected in Arabic texts. Such vocabulary remains almost unchanged over 1,000 years of history. Not only is the development of the basic vocabulary slow, it is also suggested by proponents of glottochronology that the rate is constant in all languages. This is the view of Swadesh, who has sought to apply this theory to African languages. Tests carried out in some specific contexts seem to confirm this hypothesis. Glottochronology postulates a rate of change among the items of the basic vocabulary which can be measured in percentages. The ratio of vocabulary retention, the theory goes, varies between 81 plus 2 and 85 plus or minus 0 to 4% for a given period of 1,000 years. On this basis, glottochronology has provided a number of conclusions by applying the following equation. T equals jog underscore C underscore 1 to 4 log R. T equals duration, C equals percentage of terms COMMON to the languages being compared, R equals ratio of retention. The question is whether, on the basis of the results obtained, glottochronology can be considered a valid time gauge, a sort of historical time clock. In fact, the findings fall short of expectations. For one simple reason, in a context of linguistic overlapping and lexical interference, the extent of which it is difficult to determine, and with no precise evidence from written or other sources, it is not easy in the present state of research to arrange the data in series, to distinguish between normal change and changes due to borrowing, even within the basic lexicon. In the future, however, a classificatory science which applied all these techniques would provide the key to ethnic and linguistic relationships, linguistic classifications and ethno-cultural relations. Despite some remarkable studies, the problem of linguistic and ethnical relationships in Africa is far from being solved. In many areas, intuition still takes precedence over scientifically established proof in the detection of such relationships. The idea and the notion of a Bantu community uniting the vast majority of Central and Southern African peoples were born in the 19th century with the work of W. H. I. Bleek. In his famous book, published in 1862, Bleek established the close relationship between the languages and dialectal variants spoken over a vast area inhabited by ethnic groups differing in various degrees from one another, and using languages 238, which showed various degrees of intercomprehensibility. Similarities of language and culture are obviously most apparent in a situation where the Ethnic groups concerned are living side by side, as in the case with the so-called Bantu peoples. In some cases, distance in space and time creates problems. Fulani are a good example of this. From the Senegal basin to the Nile Valley, they live in groups which are often isolated within the areas inhabited by very different peoples. Douala of Cameroon speak a Bantu language which, in practice, may be considered to belong to the same Bantu subgroup as Lingala, just as are the languages of Mbandaka or Kinshasa, despite the distance which separates it from the communities which speak the last two languages, and despite its relative isolation from them. Pharaonic Egyptian, which was spoken 5,000 years ago, offers some striking resemblances to Hausa, Wolof and Songhay. 3. There are also phenomena of overlapping. Major universal, unifying languages continue for various reasons, political, economic, cultural, etc., to serve as a basis for the integration of different ethnic groups. As they advance, they wipe out languages and cultures through their social pressure and their historical weight, often leaving only remnants behind. Lingala, Hausa, Swahili, Yoruba, Chui, Igbo, Bambara Diola, Fulfulde. Arabic and Wolof are spoken by millions or even tens of millions of speakers of different origins. As vehicles of communication, they have greatly outgrown their original ethnic and geographical framework, to become languages of civilization and to peoples whose origins were often very different. The Fulani and the Serer constitute the great majority of Wolof speakers in Senegal. Wolof was originally the language of a Lebu ethnic group, traces of which are found on the frontier between Senegal and Mauritania. Nowadays, the Lebu are only a small minority living in the Cape Verde Peninsula. With the urbanization of Senegal, however, Wolof culture and language are effacing many dialects before our very eyes. Serer, Lebu, Fulani, Diola, Noon, etc., belong to the ethnic groups of the same names which a few centuries ago were playing a very important part in the history of the area. This is a general development. Kiswahili, which is spoken by tens of millions of Bantu speakers, arose from a Zanzibar dialect used initially by a few villages. It spread very quickly over a relatively homogeneous Bantu linguistic area, until it now constitutes, together with Lingala, Central and Southern Africa's main language of communication. Between 50 and 60 million people speak one of these two languages, or a closely related language. In this area, Zaire, Congo, Central African Republic, Uganda, Tanzania, Kenya, Zambia, Malawi, South Africa, Sudan, Ethiopia, etc. Traditional African thinking has often shown a great awareness, not only of such overlapping, but also of the role that linguistics can play in explaining and elucidating history. In African tradition, many anecdotes tell of the relationship between different languages or of the more or less mythical origin of their differentiation. Often, the observations are correct. This is true of the similarities between Fulfulde and Serer, whose speakers almost intuitively assert the close ethnic and linguistic relationship existing between them. Mande, Bantu speakers, Akan and Fulani, who think of themselves as people of the same language, sometimes intuitively feel themselves to be members of groups, or subgroups, of the single, common family. In most cases, however, the observable relationships exist only because of a need to assimilate with or coexist with a community which has a position of some influence within the ethnic group. For a traditional saga will only command allegiance if the peoples concerned accept the fact of their kinship, whether this is founded in reality or myth. However, the traditional linguistic knowledge of African societies does not provide any clear indications of the existence of an ancient science, or of systematic thinking on such relationships. This contrasts with what may be noted in other spheres, for example, in etymological science, in linguistic analysis itself, or even in relation to lexical phenomena. The Fulani, Bantu, or Wolof master of speech and eloquence is often very consciously interested in and well informed about the origin of words. The historian of Kaur, for instance, will amuse himself picking out borrowings, or breaking down a word to show its origin. Barjal says the guardian of the Kaur tradition comes from Bar and Jal. He goes on to explain both the formal contraction which the constituent parts of the word undergo, and its context and meanings, in an article by A. Tal. There are some examples relating to such work by traditional etymologists among the Mossi and the Germanic. The application of classificatory science to linguistics begins with S. W. Coel, W. H. Iblique and European research. The beginnings of that science were the works of the 19th century Indo-European comparativists, and research into African linguistics began with their disciples. In regional studies, there has been much work of considerable import. Hence, if not for the originality or adequacy of its interpretations, at least for the quantity of data collected. W. H. Iblique 5 was one of the first to set out to establish that the Bantu languages were related, and in this field he preceded authors like Meinhof or Johnston. The contribution made by Delafosse 6 to the study of West African languages is well known. The same is true of the contributions made by C. R. Lepsius, 7a. N. Tucker 8 and G. W. Murray 9 to the study of the Nilotic languages, and Bassett to that of the Berber languages. The study of ancient Egyptian, so essential for African research, and of the Semitic or Indo-European languages of North Africa and even the Punic and Graeco-Latin languages, has also been of great value. As is stressed by J.H. Greenberg, 10, the author of the most recent and now most controversial classification of the African languages, the most noted modern writings on the continent as a whole are those of Drexel 1 and Meinhof 12. These are neither the first nor the only books in the field. Coel 13 as early as 1856, and Migiad 1-4 in 1914, proposed methods and types of classification. Baumann and Westermann, 15 in 1940, propound an interesting system for the same purpose. This work, however, remains controversial and is questionable for two main reasons. The first reason is that African linguistics has not escaped ethno-centric ideology. In this connection, the criticisms recently voiced by J. H. Greenberg himself are in perfect agreement with those expressed by Cheek and Tadiop 20 years ago in Nations Nigres et Cultures, and repeated with the addition of more up-to-date information by T. Obenga in his paper to the 1977 Lagos Festival. The second reason is purely scientific. Almost all linguists feel that attempts at classification are premature. Indispensable methodological precautions are not being taken. The properly analyzed and processed material, which is necessary for a genetic or even a typological comparison between African languages, has not been assembled. The need for more research. Even the task of simply listing all African languages is fraught with difficulties. Work on such a list has not yet achieved any very precise results. At a rough estimate, there are in Africa between 1,300 and 1,500 systems of speech which may be classified as languages. Progress has certainly been made in recent years, though the right climate does not yet exist for a really thorough work of synthesis, since some languages have still to be precisely identified and accurately analyzed, and until this has been done, they can hardly be classified. A few specific examples will serve to illustrate the depth of the controversy and the extent of the uncertainty. The first two examples concern the dialects to be found on the present geographical frontier of the Hamido-Semitic family and the Black African family. The third concerns the West Atlantic, or Senegal-Guinea, group. From the work of Meinhof, 16 Delafosse, 17 Meek, 18 Lucas, 19 and Cohen, 20 to that of Greenberg in 1948, A. N. Tucker and M. A. Bryan in 1966, 21, and the recent criticisms of T. Obenga, 22. It emerges that there is no complete agreement either on the data, the method of classification, the members of the groups, or the genesis and character of the relationships of the languages between the Nile and the Chad Basin. Yet geography, in particular, and proximity unquestionably give these languages a real unity. The age-old parallel existence of Black African and Semitic languages has led to a large stock of mutual borrowings. These two-way contributions make it difficult to draw the line between the original stock and outside acquisitions. The problem is to know whether the vocabulary proper to ancient Egyptian, Hausa, Coptic, Baghermian, Sara and the Chadic languages that occurs in Berber and in Semitic languages such as Arabic and Amharic is evidence of a family relationship or simply of borrowing. Data for ancient Egyptian goes back 4,000 years and that for Semitic 2,500 years. Comparable analysis of Chadic, Berber, and Cushitic does not exist. 4 times prior to the 19th or 20th centuries of our era. In 1947 M. Cohen published his essay Comparatif sur le vocabulaire et la phonétique du Chamido-Semitique, in which he compares Egyptian, Berber, Semitic, Cushitic and Hausa, to which he makes occasional reference. In 1949 Laslaw 23 and Hintsa 24 began to challenge Cohen's findings and even to question his methods. J.H. Greenberg, having in mind that the very notion of a Hamido-Semitic group was disputed, widened the range of its components. He suggested a separate fifth member, Chadic, and renamed the whole group Hamitic, and later, Afroasiatic. These conclusions provoked controversy from the moment of their publication. Polotsky 25 doubted whether it was possible at present to accept the existence of 5 branches. Greenberg, be it noted, repeated, still without carrying conviction, the predominantly geographical thesis about Chadic and its connections which he put forward in an article in Languages of the World. One only needs to refer to the contradictory classifications of Greenberg, Tucker and Bryan, constantly brought into question even by the authors themselves, to gain an idea of the inconclusive nature of their proposals. Recent work gives substance to the notion of a Chadic family, the borders of which extend far beyond the shores of the lake. Newman and Ma26 in 1966 and Ilis Vichy 27 in 1967 have improved our knowledge of Proto-Chadic. The work of Y. P. Capril 28 has charted its expansion in Chad itself. On the basis of systematic observation, a genetic link might be suggested between the Sara and Chadic groups and several languages classified as West Atlantic, Serer, Fulfulde, Wolof, Safen, etc. 29. These attributions alone cast doubt upon the whole attempt at classification, as is emphasized by C. T. Hodge in an excellent article. 30. The major problem of the nature of the links between the languages of the frontier between the Black African and the Hamido-Semitic languages remains unresolved. The sheer volume of published work that identifies the world of African culture with Semitic is a further problem. There is still a problem of the membership and even of the identity of the Black African language family. The Symposium on the Peopling of Ancient Egypt, organized by UNESCO in Cairo in 1974, emphasized this. On this occasion Professor S. Son Aaron recalled, by way of illustrating these uncertainties, that the Egyptian language could not be isolated from its African context and its origin could not be fully explained in terms of Semitic. Final report, p. 29. Cushitic is another example of the present uncertain state of research and classification. Greenberg, Tucker, and Bryan and the Soviet scholar Dolgopol-Jayskij have recently put forward three differing, not to say contradictory, classifications for the complex of languages, Somali, Gala, Sidamo, Mbugu, etc., that goes by the name of Cushitic. Dolgopol-Jayskij's classification hinges upon a phonological type of reconstruction based on a limited number of examples. In particular, he compares the labials, p, b and f, and dentals, t and d, in the languages, and classifies them in 10 sub-groups, whereas his colleagues identify from 3 to 5. Greenberg ignores the phonological, morphological, and grammatical data and concentrates mainly on a comparison of vocabulary. But here, borrowing plays an important part. Tucker and Bryan, WHO criticize Greenberg's method, offer a classification based on a comparison of the pronoun system and the verb structure. They themselves regard the inclusion of some of the languages that they group together as doubtful, and emphasize the purely tentative nature of their approach. One can only observe that the outstanding feature of the classifications set forth here is their provisional nature. The same difficulties arise as regards the languages geographically bounded on the west by the Atlantic and extending along the coast from southern Mauritania to Sierra Leone. In 1854 Coel, in his Polyglotta Africana, classified them under the heading West Atlantic, basing his identification on their changes of prefix or initial or final inflection. This is a typical feature of Bantu but is not enough to define a group. Moreover, Coel later came to regard all these languages as unclassified. Delafosse in 1924-31 and Westermann in 1928 asserted that the West Atlantic languages constituted a genetic group, and in 1963 Greenberg 32 gave his whole-hearted approval to this. He called them the extreme western group of the Niger-Congo family. In the same year Wilson 33 and Dalby 34, while noting the internal typological similarities of the group, completely rejected the idea of regarding these languages as a homogeneous and related group. In details of morphology, syntax, and vocabulary, wrote Wilson, the West Atlantic or Senegal Guinea group is by no means an entity. Indeed, recent work by D. Sapir, 35, published in 1974, shows that there is no more than 5 to 10% common vocabulary between the great majority of these languages, the only unifying factor in most cases, as has been suggested elsewhere, being geography. Here as in the Nile-Chad area, migration intermingled peoples of different origins, they are bracketed together, perhaps too hastily, in the absence of precise information that would enlighten history and the historian. It is here, moreover, that linguistics as a tool of historical research suffers at present from serious limitations. The research worker is faced by the twin obstacles mentioned above. Research has met with no success because it remains incomplete and embryonic. In the second place, the tentative results of research can often not be used because they are falsified by distortions of approach and ideology. Ideological distortions. History is the favorite haunt of ideology. Ideology develops around and within it. The earliest works on the African past and on African languages coincided with the European colonial expansion. Such works were strongly tainted with the contemporary notions of racial supremacy. The ethnocentric viewpoint was the natural expression of the need to judge the value of any civilization by internal reference. It led men to appropriate to themselves the most distinctive points of any civilization in order to legitimize their world dominance in thought and power. The theories of the primacy of the civilizing Indo-European, Aryan or white man are evidence of excesses which still today leave profound reverberations in a number of works on African history and linguistics. 36. Egypt was for a long time set on one side by comparison with the rest of the continent, or rejuvenated for the benefit of Mesopotamia or other centers of civilization which were assumed, on the basis of unsupported speculation, to be Indo-European or Semitic. Benin art was allotted imaginary founders. A systematic theory of Hamitization 37 was worked out, so as to explain by external influences any interesting cultural features in Black Africa. Whilst seeking to promote a strictly scientific methodology, Greenberg, whose contribution, though not entirely beyond dispute, remains very fresh and important, sometimes echoes the negative aspects of ethnocentric ideology. Seligman and Meinhof, and also after them authors as important as Delafosse, Baumann, Westermann and Muller, put forward some staggeringly unscientific arguments, based as they are on prejudices of the kind expressed by Meinhof when he wrote, in the course of history, one phenomenon has constantly recurred, namely that the Hamitic peoples have subjugated and ruled over the black-skinned peoples. Such an observation shows how careful we must be today when using any material which linguistic research makes available to historians or human scientists in general. The vagueness of the use of the term Hamite, wrote Greenberg, as a linguistic term, together with its extension as a racial term for a type viewed primarily as Caucasoid, has led to a racial theory in which the majority of the native population of Negro Africa is considered to be the result of a mixture between Hamites and Negroes. Thus in Races of Africa, c.g. Seligman calls the speakers of Nilo-Hamitic languages racially half Hamites, while the Bantu are also supposed to be another variety of Hamiticized Negroes. And this, Greenberg continued, on the basis of the speculations of Meinhof, for which he never produced the slightest proof. For the very good reason that no proof is possible, to the effect that, as Seligman says, Bantu is a mixed language, so to speak, descended of a Hamitic father and a Negro mother. The east/west and north/south migrations of the African peoples have confused the ethnic, racial, and linguistic map of the continent. This has been shown in many studies of the evidence of personal names, place names, and purely linguistic facts carried about the basic vocabulary itself. The languages of Senegal like Wolof, Diola, Fulfulde and Sira show considerably more similarities to the Bantu languages of South Africa, Tanzania, Cameroon, and Zaire than to the languages of the Mande family, by which they are Geographically surrounded. The lexicon, the structure, and the essential principles of written ancient Egyptian, as we shall see below, are closer to corresponding phenomena in languages such as Wolof or Hausa, or to the Dahomean graphic tradition, than to the Hamido-Semitic linguistic systems, to which they have been incautiously assimilated. Ancient Egyptian, Hausa, and the languages of the Rwanda pastoralists. The Abyssinians, the Fulani, and the Nubians are baptized Hamido-Semitic. On the strength of obviously flimsy data or of an utterly unconvincing methodology and choice of criteria. The Fulani are perhaps of mixed blood just as the Luba, the Susu, the Songhay, and many black peoples in their former or present habitat had contacts with white peoples, although this interbreeding hypothesis is now distinctly questionable as a result of recent discoveries about the process of pigmentation mutation. In its phonology, vocabulary, and structure, Fulfulde bears a closer resemblance to Sira than to any other known language, so much so that the Sira and the Fulani themselves suggest that their relationship is not only linguistic but ethnic. This has not deterred scholars such as Muller, Jeffries, Meinhof, Delafosse, and Westermann from seeking to establish a white origin for the Fulani on the grounds that Fulfulde is a Proto-Hamitic language. 38W. Taylor goes as far as to write, from its wealth of vocabulary, its sonorous diction and the delicate shades of meaning it can express, I certainly do not think it Fulfulde belongs to the Black Sudanese family. All these comments show how widespread the confusion is between categories as different as language, way of life and race, not to mention the concept of ethnic group which is used according to taste to refer to one or more of these categories. As Greenberg has pointed out, the simple equation of Hamites with cattle ownership and conquest must be abandoned. In West Africa there is a 100% negative correlation, for the Hausa agriculturalists who speak a Hamitic language were conquered by cattle-owning Fulani. Speaking a Black African, Sudanic or Niger-Congo language. Another inversion of the stereotype which one might note is that of the great age and continuity of rule by the Sudanic-speaking Mande or Wolof over peoples so hastily assimilated to Hamitic as the so-called pre-Hamitic Fulani or the Berbers. None of the classifications drawn up for the whole or parts of Africa can so far be considered unquestionably sound from a scientific point of view. Ethnocentricity has gone a long way to distort analysis of the material. In many cases all we are left with is guesswork, the begging of questions and quick overall surveys. A number of conditions must be fulfilled if we are to study African languages according to strictly scientific principles such as will help to clarify the history of the peoples and civilizations of Africa. First, such work must be free from obsession with irrelevant ideas derived from the study of Semitic or Indo-European languages, which are part of European history. Furthermore, if we are to establish the relationships between the African languages, we must cite early linguistic evidence, and not geographical distribution, early or late influences, explanatory schema chosen a priori, or linguistic features which are marginal in relation to the main facts of the language systems. Auxiliary sciences. Analyze a culturalist, or typological analysis 39 as it is called in English, is part of a science which studies the origin and spread of cultural features, ideas, techniques, and so on. German scholars were first in the practical application of this method, with the study of cultural cycles by Frobenius, Westermann and Baumann, and so on. Such studies have often been concerned with the spread of crops and agricultural techniques, pastoral methods, the invention and spread of iron working and other metal working techniques, the use of the horse and the Development of ontological notions of the pantheon of the gods or of artistic forms. On occasion, however, typology has exceeded its brief. In particular, it has introduced many errors into classificatory linguistics. Extremely incautious writers have felt bound to infer linguistic relationships from cultural features alone when such phenomena are often due to borrowing, contact or convergence. Onomastics is the science of names, place names, toponyms, personal names, anthroponyms, names of watercourses, hydronyms, and so on. Onomastics is closely connected with vocabularies. Ethnic communities, which have for a time remained relatively homogeneous, as well as ethno-linguistic groups which are more heterogeneous in their membership and have a language in common, create their names mainly by reference to the realities of their languages. They provide the territorial or geographical milieu which they inhabit or have inhabited with characteristic names. Equally, it is possible, by personal names, to establish the ethnic makeup of a community. In general, the Syri are called John, Ju'av, Sin, Tur, Jara, etc., while the Berbers and the Bantu speakers each have their own sets of names. Anthroponymy plays an important part in the history of ethnic groups in political or cultural communities. The study of the names in use among the Tukulor of Senegal, for instance, shows that we are dealing with a very heterogeneous ethno-linguistic community. This Fulfulde-speaking group, established along the river Senegal, and on the borders of Mali and Mauritania, is culturally very homogeneous. They have a highly developed national sentiment. In fact, the community is a combination of Fulani, who supplied the language, and of Mande, Serer, Lebu Wolof and Berber. Toponymy and hydronymy are also essential for the study of the migration of peoples. Using the names of former or existing villages, precise maps can be drawn up showing the movements of the Mande, whose villages have names containing Dugu. In the same way, we can draw up a toponymy map of the former or present habitation of the Fulani who use the term Sar for their settlements. A similar map can be drawn for the Wolof using the term Kur, for the Arabo-Berbers using Daru, for the Hausa, and so on. Semantic anthropology. Semantic anthropology or ethnolinguistics is a new approach which attempts to discover man's culture from his language. It is based on an overall analysis of all the data which can be culled from the language of an ethnic group or heterogeneous linguistic community possessing a common language to express its culture, thought and history. This method goes beyond the mere collection of written and oral traditions and literature. It involves reconstruction of the whole set of ideas in a language, not necessarily in relation to a systematic work or systematic discourse. Such research thus operates at both infra- and supralinguistic levels to establish from vocabulary, thought patterning, procedures of formalization, of conceptualization and structuring of a language, the various types of knowledge within which the specific worldview and history of the community speaking a given language are crystallized. Ethno-linguistics uncovers systems, metaphysical conceptions, ethics, ontology, aesthetics, logic, religion, knowledge of techniques, and so on. Thus, the written and oral literature relating the past of the Hausa, together with their religious documents, fables, legal, medical, metallurgical, and educational practices, sheds light both on the development of the content of Hausa thought and on their history and culture. 248. In predominantly oral civilizations in which written texts are rare, diachronic interpretation based on the comparison of texts from different periods is virtually impossible. In such cases, linguistics becomes an invaluable means for the rediscovery of the intellectual heritage, almost a sort of time machine. The oral cultures which are traced through semantic anthropology provide us not only with works to be collected and recorded, but also with authors and with the specialties of those authors. ANY African oral or written culture, such as that of the Wolof, has left its philosopher, like Ndamal Gosaz, its political historian, like Saa Basi, its master of speech and eloquence, its master of epic and story, like Ibn Mbeng 40, and also its inventors of pharmaceutical, medical, and agricultural or astronomical techniques. 41 These works and their authors are excellent sources for analyzing the evolutionary dynamism of the culture of a society in all its various forms. Bantu ontology can be deciphered, and even interpreted and systematized, simply by reference to Bantu words relating to the human being in the world, and also on the basis of the process of elaboration and conceptualization which, working through Bantu words and utterances, gives form to the views that the Bantu languages have of such phenomena. Language being as it were the crystallizing point for all the intellectual and material tools fashioned by succeeding generations, we may think of a people's historical experience as being deposited in stratigraphy layers within the very tissue of the language, an adjunct to records and historical thought. Nowadays the importance of oral tradition in African history is readily admitted. Traditionalist griots are even asked to scholarly conferences. There have been suggestions that university posts should be created for them, and even that historical research and teaching should be entrusted to them. On the whole, the preeminence of spoken over written material is still a fact today, in Africa, as elsewhere in predominantly rural traditional cultures. Oracy has its own methods of elaborating and defining the results of thought. While written and oral forms of thought cover the same ground, the means and methods of their conception and transmission are not always the same. 4.2. We shall simply note that written thought, literature in the narrow sense, has a greater tendency to become fixed for all time, as it is set down. This distinguishes it from oral tradition, which offers greater latitude for invention and myth creation. On the level of language, the spoken word has also greater potential for dialectalization because there is less control over its development. A language used mainly for oral expression remains closer to the people and more exposed to the distortions which regular use brings about in its structure, in its sounds, and even in the forms which it borrows. A literary language, on the other hand, tends more towards unification. In addition, it has a more important visual side to it, because it has, among its means of expression, graphical features which give it a particular character, an orthography which conflicts with its phonology, a system of punctuation, etc. Oral language, on the other hand, makes greater use of sound as a means of signifying thought through cadence, rhythm, assonance, or dissonance and other vocal tricks. The importance of the role played by memory, to compensate for the absence of the written medium, also affects the character of the spoken word and the forms it uses. It consciously submits to the restraints of mnemonic techniques, a specific science for the memorizing of texts. Written records and oral tradition thus become complementary, and unite their respective virtues. 43. Moreover, oral accounts, once they are transcribed, become literary texts. 44. Graphical tradition, African writing. Nature and origin of the needs which are met by the invention of writing differ according to context and have not always been clearly brought out. Writing as an instrument of commerce and administration is a phenomenon of urban civilization, but this is not necessarily the origin of all writing. In Africa, not only in the age of the pharaohs but also under the kings of Dahomey or the Mandinga Munsas, writing served mainly non-material needs. Egyptian writing and that of the Dahomey bas-reliefs or the Bambara or Dogon ideograms had, in their original context, two purposes. First was to materialize thought and to enshrine something of religious or sacred significance. According to legend, Egyptian writing was invented by the god Thought, and long remained confined principally to temples and the use of priests. It served to record secrets designed for the use of initiates or as a medium for a type of thought conceived as an active substance to be materialized in the word or writing itself. Second great function assigned to literary records in civilizations of purely African origin coincides with the need to perpetuate history. Both Egyptian writing and that of the palaces of Abomey are used to glorify sovereigns and peoples. WHO are concerned that their feats should be remembered. Same purpose preoccupied the Bambara or Dogon as they carved their ideographs on the walls of Bandiagara. There are more than affinities between the Rekid of Kingale, which was a message-carrying ceremonial axe, and the palette of Narmer. Not only is the spirit the same, but also the principles and techniques of writing. 45. Egyptian writing, as we have said, is attributed to the god Thought. WHO also invented magic and science, as did the jackal-headed god of the Dogon, who is himself the guardian of the word, knowledge, and effective speech. Few experts who have studied, often most minutely, the systems of writing originating from Africa have all without exception ignored the seemingly obvious and technically demonstrable link between the best known Egyptian hieroglyphs and the writing systems of Black Africa. Egyptian hieroglyph remained fundamentally pictographic in its original function as an instrument of the temples. Like its Dahomean counterpart, it makes as strong as possible a reference to the image. It is a deliberately realistic writing concerned to materialize living beings, objects, and ideas in the most concrete and substantial manner, rather as if to store or conserve their natural qualities. It is not by chance that the distortion of pictographic writing by the use of a cursive script, which alters and disfigures the objects represented, is allowed only outside the temples. Hieratic writing, which was used principally for secular purposes, despite the implications of its Greek etymology, and popular demotic writing, with its even more simplified signs, are non-sacred, utilitarian systems. The Egyptian priest, the hieroglyph has, in addition to its other qualities, as M. Cohen so rightly emphasizes, a power of magical evocation. And this explains, in his opinion, why images of maleficent creatures are either omitted or mutilated. Here we have an ontological viewpoint which is deeply rooted and steeped in the Negro African tradition. For thousands of years, this tradition remained incapable of secularizing thought and its oral or graphic media, as the Indo-Europeans and especially the Greeks had done. Bambara, the Yoruba, the Nsabidi, and the Dogon priests have exactly the same view of the writing systems which they use in their temples or their divination ceremonies. Unity of the writing systems originating from Africa lies not only in the ideological presuppositions which give those systems their functions and nature, but in the technique of transcription itself. Continually throughout the history of African writing systems, 3 techniques for the graphic recording of thought are relevant: the use of the image, through pictograms depicting the creature or the object, the use of the symbol to represent an entity through ideograms, which are signs with no direct link of physical resemblance to the concept they symbolize, and finally the use of phonograms, each representing one whole set of homophones, that is, of entities denoted by the same sound or group of sounds. This is the principle of pictophonographic writing. It is revealing to compare the palette of Narmer and the Rickettese of Galais, or Decodanu. Both transcribe thought on the same principles. And the palette, we have the image of a king seizing a defeated enemy by the hair in order to dispatch him, while the rest of the conquered army flees beneath the feet of the gigantic pharaoh. The pictograms are clear and eloquent. The other signs are ideograms. One such distinct sign is an oval, ta, symbolizing the earth. Above is a group of signs and a square as the emblem of the pharaoh's name, Horus. A fish and a bird make up the name of the pharaoh. The two images are pictophonograms. The Ricket of Gazo shows the Dahomey sovereign in the form of a buffalo, as pharaoh is symbolized by a falcon. His teeth are bared, meaning that he sows panic among his enemies from earliest youth. In this case, we have an example of a symbolic representation. Others are more significant. The Ricket of King Decodanu or Decodanu, which is older, 1625-50, and is described by L.E. Harris, shows even more clearly the principle of the Dahomey hieroglyph. The text on the axe blade can be read as follows: there is a pictographic symbol representing a silexta, with below the symbol of the earth, Ko, having a hole in the middle, Donon. These signs are pictograms used here as pictophonograms. By combining them, as in the case of the pharaoh's name in the Narmer palette, we get the name of the Dahomey king Decodanu. Dahomey writing bears the strongest possible likeness to the Egyptian hieroglyphs and the principles and spirit of that system. It reveals the three techniques used by Egyptian graphics: the pictographic image, the ideographic symbol and the pictophonographic sign. 46. The Soviet scholar Dmitry A. Oldrog, in an article outstanding for the synthesis it presents, has reasserted that, as Cheek and Tatiop first pointed out, the hieroglyphic system survived until recently in Black Africa. In his historical description of the three kingdoms of Congo, Matamba, and Angola, published in 1687, Cavazi de Montecudolo asserts that hieroglyphic writing was used in these areas. In 1896, a hieroglyphic inscription was discovered on the rocks at Tete in Mozambique, beside the Zambezi. The text of the inscription was published at the time. Cheek and Tatiop notes elsewhere the use of a late pictographic writing system in Bale, where recently traces of hieroglyphs have been discovered on 1,000-year-old baobabs. The Vai of Liberia for many years used a pictographic writing system on strips of bark. Meroitic writing, which grew up on the southern limits of ancient Egypt, is unquestionably a continuation of ancient Egyptian writing. The latter inspired the former, or else the former gave rise to the latter, or shares a common origin with it. The ideographic systems of writing, however, seem to have been more durable on Western Black African soil than were the hieroglyphs. In practice, the vast majority of African peoples are familiar with the use of ideograms either in divining techniques or in their use by priests of religion and engravers of works of art, and so on. The Gurma have a very elaborate system of divination. The diviner, the Tumbipwalo, draws signs in the sand and interprets them. Then he issues a kind of prescription consisting of abstract signs carved with a knife on a piece of calabash to denote the altars, the places where the client must go to make sacrifices, what kind of animal must be sacrificed, how. many times, and so on. It is in fact a system of coded writing. The IFA divination system, which is found all along the coast of the Gulf of Benin, is also remarkably rich. The diviner shuffles palm nuts from one hand to the other 8 times, and according to the number of nuts remaining in his left hand he writes a figure on a tray sprinkled with dust or on the ground. Tables, to a possible maximum of 256, are thereby drawn up, of which the 16 most important constitute the Odu, threads, or words of the gods ruled by Ifa, the god of destiny. Everyone must sacrifice to his Odu, but at the same time take account of those of his relatives and ancestors, his country, and so on. The permutations are legion, and the multiplicity of Odu are combined in a sort of mythological strategy which is also a graphological technique. The collection of ideographic systems 47 has given a rich yield, especially in savanna countries which have retained their traditional religion and are relatively little affected by Islam. This is no coincidence. Experts, of which Mijiad was one of the first, have uncovered some of these systems. Dogon ideographic writing has been described by M. Griel and G. Dieterlen, who analyzed the Bambara graphic system and made a good survey of the area's systems. Nsibidi ideography, which is used by the Igbo of southern Nigeria, was discovered by Europeans at the end of the last century. It is based on transcribing principles that were very widespread throughout the Guinea coastlands. Phonetic writing, 48, which systematizes the use of phonograms, represents simple or complex sounds by regular signs. Such systems, in the opinion of the author, appear in Africa as a late development. The hieroglyphs of ancient Egypt and of Dahomey represent many sounds with signs, but purely phonetic systems based on the word, the syllable or the single phoneme, the latter being alphabetic transcription, mark a new stage. 49. Berber writing, which is used among the Tuareg of the Sahara and which is still known by the name of Tayfinak, is said to have developed under Punic influence through contact with Carthage. The Nubian writing system was formed in the 10th century through contact with Coptic writing, which in turn grew up under Greek influence. The alphabet used for Amharic and Tigrinya in Ethiopia is derived from the Sabaean writing of southern Arabia. The West African syllabic and alphabetic writing systems that were very widespread on the Guinea coast and in Sudanese areas from the end of the 18th century may have arisen by internal developments, or may have taken on their final form under the distant or not so distant influence of an outside element of European or Arab origin. 50. Vi writing became known in Europe in 1834 through the discoveries of Eric Bates, and in 1849 through those of Coel. It developed in an area where traces of the hieroglyphic system had been noted. Momolu Masekwe, a 19th century Liberian consul in England, described the principles of the hieroglyphic system used in his area at that time. 51. Mamalu reports that, to express victory over an enemy, the Vi drew on a strip of bark, instead of papyrus, the outline of a man running with his hands on his head. A dot is placed alongside the image to indicate large numbers of fleeing men, a routed army. In this use of a dot to denote the plural instead of the dashes used in the Nile Valley in antiquity, we find features of pharaonic script. Thus the Vi may have altered their earlier system in the direction of phonetic transcription. Today, we have instances similar to that of Vi writing among many West African peoples, the Malinke, Mande, Bassa, Gertz, Capel, Toma, etc. Wolof and Serer have also recently been provided with graphical systems based on these principles. Contrary to the commonly held view, the use of writing has been a permanent feature of African history and thought, from the palette of Narmer to the Rekat of Galay. The wealth of writing systems and of evidence of their use bears witness to this fact. Post-pharaonic African writing systems followed a normal development. And there are many reasons for this. Quite simply, this development was adapted to the historical context and the historical requirements of an affluent rural society and economy. Its members were not forced by the pressures of poverty to consolidate in their OWNH their material or intellectual acquisitions, because these were not continually threatened. An ecology providing an easy balance between resources and population gave most African civilizations and their cultural features the power to wax and wane geographically while always preserving their essence, their principles. From the point of view of internal equilibrium, there was no great risk. But external forces and the growing effects of progress made such fragility a handicap. Conclusion. Linguistics is absolutely essential to the development of an African science of history. However, it will be able to make its contribution only if a great effort is undertaken. So far its contribution has been relatively slight and, in many instances, scientifically unsound. Research is underway. The precision of its methods has increased, and the area of its investigations has broadened considerably. In this context, we can expect the analysis of African languages to contribute in the near future to the clarification of important points of the history of the continent. Theories on the races and history of Africa. J. Zerbo. The concept of race is one of the most difficult to define in scientific terms. If we agree with most scholars since Darwin that mankind is a single stock, 1. The theory of races can only be developed scientifically within the context of evolution. Raciation is part of the overall process of evolutionary differentiation. As J. Ruffy has pointed out, it requires two conditions: first, breeding isolation, often partial, which gradually produces a special genetic and morphological situation. Raciation thus arises from a difference of gene stock, caused either by genetic drift, that is, the random transmission of genes allows a given gene to be transmitted more often than another, unless, of course, the allele is more widespread, or by natural selection. The latter leads to adaptive differentiation, by which a group tends to preserve the genetic equipment that best adapts it to a given environment. In Africa both processes have clearly gone on. Genetic drift, which works most powerfully within small groups, will have operated within limited populations, which are in any case liable to undergo a social process of binary fission at times of territorial and succession disputes, and also because of the great expanses of virgin land available to them. The genetic inheritance of endogamous and forest-dwelling peoples will have been particularly affected by this process, while natural selection will have operated in environments as diverse as desert, dense forest, high plateaus, and mangrove coasts. What it amounts to, in biological terms, is that the members of one race share certain genetic factors which in another racial group are replaced by their alleles, whilst in half-breeds both gene types exist together. As was to be expected, races were originally identified according to visible criteria, but deeper realities gradually came to be taken into account. Indeed, outward features and inward phenomena are not completely unrelated, for although the color of the skin is determined by hereditary mechanisms which depend on certain genes, it is also affected by the environment. A positive correlation has been noted between stature and the highest temperature of the hottest month, and a negative correlation between height and humidity. Similarly, a narrow nose warms the air better in a colder climate and humidifies dry air. This is why the nasal index of people south of the Sahara shows a marked tendency to rise as one passes from the desert through the savanna to the forest. Although they have the same number of sweat glands as whites, they perspire more. And this keeps their body and skin at a lower temperature. There are therefore several stages in the scientific investigation of races. The morphological approach. Rickstedt defines races as natural zoological groupings of forms belonging to the hominid family whose members display the same typical set of standard and hereditary characteristics from the morphological and behavioral points of view. A whole arsenal of observations and measurements now exists, ranging from data concerning skin color and hair form or quantity of body hair to those concerning metrical and non-metrical features, or even including the anterior femoral flexure and the cusps and grooves of molars. Special attention has been given to the cephalic index because it relates to the part of the head which houses the brain. Dixon, for example, establishes various types on the basis of 3 indices combined in various ways, namely, the horizontal cephalic index, the vertical cephalic index and the nasal index. But out of the 27 possible combinations only 8, those occurring most often, have been accepted as representative of fundamental types, the other 18 being considered to be mixtures. Morphological characteristics, however, are merely a more or less distorted version of the genetic stock. They are seldom all found combined in a perfect prototype. It is a matter, rather, of particularly striking features of the interaction between man and his environment, which is to say that they are much more acquired than innate. This illustrates one of the most serious weaknesses of the morphological and the typological approach, in which the exceptions are eventually found to be more important and more numerous than the rule. In addition, we should not overlook the academic disputes over the methods of measurement, how, when, and so on, which make it impossible to draw valid comparisons. Multivariate distance data and coefficients of racial resemblance format and shape data, the generalized distance of nihil novus, all these lend themselves to processing, but a race is a real biological entity which has to be examined as a living whole and not as a dissected specimen. The demographic or population approach. Accordingly, this method concentrates from the outset on group factors, gene pool or genome, which are less prone to variation than the genetic structure of individuals in varying circumstances. Indeed, it is the frequency of characteristics observed in a race, rather than the characteristics. 262. Theories on the races and history of Africa themselves which are significant for the identification of a race. NOW that the morphological method has been practically abandoned. 2 Serological or genetic factors can be classified according to more objective rules. According to Landman, a race is a group of human beings WHO, except in a few cases, display more genotypical similarities, and also very often more phenotypic similarities, to one another than to members of other groups. Alex Saf also follows a demographic approach to the question of race using purely geographical names, North Europeans, Southern Africans, and so on. Schwadecki and Boyd have emphasized genetic systematics. Distribution of blood groups A, B and O, combinations of the rhesus factor, the gene of the saliva secretion, and so on. Blood group specialists also take anatomy into account, but at the molecular level. They are concerned with describing the minute structure of those human cells whose antigen structure and enzyme systems are differentiated, the most convenient tissue for this purpose being the blood. Blood markers have made possible a historic qualitative advance in the Scientific identification of human groups. They have decisive advantages over morphological criteria, starting with the fact that they are almost always monometric, that is, their presence depends on a single gene, whereas the cephalic index, for instance, is the product of a number of factors that are not easy to pinpoint. 3. Again, while morphological criteria are translated into figures which lead up to arbitrary and ill-defined distinctions, as for instance between the typical brachycephal and the typical dolichocephal, with blood markers, it is a case of one thing or the other. A person is either group A or not, Rh positive or Rh negative, and so on. Furthermore, blood factors are almost completely unaffected by environmental influences, the hemotype being permanently fixed at the time of the formation of the zygote. Hence blood markers are free from the subjectivism of morphological typing. Individuals are described in terms of genotypes, and populations in terms of genotype frequencies. The high degree of precision of these factors makes up for the fact that they represent only a small part of the mass of genes that go to make up a genome. This has made possible the compilation of an atlas of the traditional races. 3 categories of blood factors have been established. SOME, such as the blood groups in the ABO system, occur in all the traditional races, without exception, and hence no doubt antedate hominization. Others, such as the variants in the Rh system, are omnipresent but preponderate in certain races. Thus the R chromosome is mainly found in whites, while the Ro chromosome, the so-called African chromosome, has a particularly high frequency of occurrence in blacks south of the Sahara. These are therefore certainly systems dating from the time when MAN began to move into a variety of ecological niches. Another category of variants indicates even clearer racial demarcation lines, as for instance the Sutter and Henshaw factors, found almost only in blacks, and the Kell antigen, found mainly in whites. Though never completely exclusive, they have been termed racial markers. Lastly, some factors are very localized geographically, as for instance hemoglobin C among the peoples of the Volta Plateau. Though blood factors have no direct value as adaptations, they are not unrelated to the infective and parasitic aspects of the environment. The latter may operate selectively on blood factors with survival value, thus leading, for instance, to the presence of characteristic hemoglobins. An example is the S hemoglobins, associated with the presence of sickle cells or drepanocytes among the red corpuscles, which have been detected in the blood of blacks in Africa and Asia. Hemoglobin S, HbS, which is dangerous only in the case of homozygotes, represents an adaptation to the presence of Plasmodium falciparum, the malaria parasite. The study of blood groups over wide areas makes it possible to construct isogenic curves showing the geographical distribution of blood factors throughout the world. Together with the computation of genetic chronology, it gives us some idea of the interrelationships between different populations, and the direction of the gene flows makes it possible to reconstruct the earlier stages in their evolution. But the blood group and population method, despite its remarkable achievements, comes up against difficulties. For one thing, its parameters are multiplying at a tremendous rate, and are already producing results which are odd to the point of being regarded by some as aberrant. Thus L. Cavalli-Sforza's phylogenetic tree of the peoples of the world departs from the anthropometric classification. The latter puts African pygmies and San on the same anthropometric branch as the Aborigines of Australia and New Guinea, whereas on the phylogenetic tree Pygmies and San are closer to the French and English, and Australian Aborigines are closer to the Japanese and Chinese. For in other words, anthropometric characteristics are more affected by the climate than genes are, so that morphological affinities are more a matter of similar environments than of similar heredities. The work of R.C. Llewellyn, based on blood group research, shows that for the world as a whole over 85% of variations occur within nations. There is only a 7% variation between nations belonging to the same traditional race, and only 7% between the traditional races. In short, there is more difference between individuals in the same racial group than there is between races. This is why more and more scientists are adopting the radical position of theories on the races and history of Africa, denying the existence of race altogether. According to J. Ruffy, in the early days of mankind, small groups of individuals, living in very different, widely separated ecological areas, became differentiated in response to very powerful selective pressures, their technical resources being extremely limited, and gave rise to the variants Homo erectus, Homo neanderthalensis, and the earliest Homo sapiens. The facies, for instance, which is the part of the body most exposed to specific environments, evolved differentially. Black pigmentation in the skin developed in tropical regions, and so on. But this differentiating tendency was soon halted, and remained embryonic. Man everywhere began to adapt himself to his environment, not morphologically but culturally, that is, in clothing, habitat, food, and so on. Man born in the tropics, a hot climate, evolved for a long time as Australopithecus, and Homo habilis and even Homo erectus. It was only during the Second Ice Age, thanks to his efficient control of fire, that Homo erectus opted to live in cold climates. The human species is moving from polytypic to monotypic, and this process of racial standardization seems to be irreversible. The whole of mankind must be regarded nowadays as a single pool of intercommunicating genes. 5. In 1952, Livingstone published his famous article on the non-existence of human races. In view of the enormous complexity and therefore the inconsistency of the criteria adopted for the description of races, he recommended that the Linnean classification system should be abandoned, and suggested a genealogical tree instead. In areas which are not isolated, the frequency of certain traits or genes changes gradually in various directions, and the differences between two populations are proportional to the physical distance between them, following a kind of geographical gradient, Klein. By relating each distinctive trait to the selection and adaptation factors that may have contributed to its development, we find frequency rates apparently linked far more closely to technological, cultural, and other factors which do not at all coincide with the distribution map of races. 6. Whenever a different criterion is adopted, color of the skin, cephalic index, nasal index, genetic characteristics, and so on, a different map is obtained. That is why some scientists have come to the conclusion that the whole theory of races is unconvincing and can be regarded as mythical. In the light of the most recent advances in human genetics, no biologist nowadays any longer admits the existence of races within the human species. 7. Biologically speaking, skin color is a negligible element in relation to the genome as a whole. Bentley Glass considers that the white race differs from the black by no more than 6 pairs of genes. In terms of numbers of genes, there are often greater variations than this among whites, and among blacks likewise. And the strength of this, UNESCO, having held a conference of international experts, issued a declaration to the effect that race is not so much a biological phenomenon as a social myth. 8. The truth of this is demonstrated by the fact that in South Africa a Japanese is regarded as an honorary white and a Chinese as colored. Higher Nas compares mankind to a network of genetic territories, of collective genomes forming peoples that resemble each other in varying degrees, the qualitative distance of which is expressed by a quantitative estimate, numerical taxonomy. The boundaries of such territories, as defined on the basis of climatic gradient, fluctuate, in fact, with all the changes which affect the visible features, phenotypes, and the serological data, genotypes, of communities. This bears out Darwin's brilliant intuition that any race seems, in the last analysis, to be identified with an endless process similar to those observed in fluid dynamics, and all peoples have been and are becoming hybridized. In fact, whenever one people come together with another, the result can be analyzed in scientific terms as a gene migration, and a gene flow affects the biological capital of both. But even if this was a more scientific approach, even if these shifting genetic territories were really accepted by the communities concerned, could we say that racial feelings would thereby be eradicated? For their visible and tangible differences would still be in evidence in the form of phenotypical features. Ever since the assertion by Nazis, and by other pseudo-intellectuals, as well as Hitler, that Mediterranean man represents an intermediate level between the Aryan, Prometheus of mankind, and the black, half-ape by descent, the racial myth dies hard. Impenitent morphologists still feebly foster the wretched idea. 9. Linnaeus, writing in the 18th century, subdivided the human species into 6 races: American, European, African, Asiatic, savage, and monstrous. We may be sure that racialists fall into one or other of the last 2 categories. From all these theories, theses, and hypotheses, let us therefore single out for closer scrutiny the dynamic character of racial phenomena, bearing in mind that we are dealing with slow and complex processes of change, occurring at many different levels, among which variations in the color of the skin, even if measured by an electrospectrophotometer, and the shape of the nose rank so low as to be almost negligible. Interacting factors in racial dynamics deserve special attention, namely, the genetic heritage, which can be regarded as a gigantic biological data bank in action, and the environment in the broadest sense of the term, since in this context it starts with the fetal environment. The changes resulting from the interaction of these 2 basic factors may occur either in the form of selection and gene migration, crossbreeding, which is difficult to verify, or in the form of genetic drift or gene mutation, which is a matter of chance. In short, it is the entire history of a population that accounts for the different aspects of its present racial facies, including group attitudes, religion and dietary, clothing and other customs. In this context, what can we say about race where the African continent is concerned? A historical analysis of the subject is difficult, since human fossils are not well preserved owing to the humidity and the acidity of African soils. It can be said, however, that contrary to the European theories which sought to explain the peopling of Africa by migrations from Asia, 10, the population of Africa is for the most part indigenous. Several writers think that the color of the skin of the earliest inhabitants of the continent living in tropical latitudes must have been dark. Brace, 1964, since the color black is a natural protection against harmful rays, and against ultraviolet rays in particular. The pale skin and light-colored eyes of the peoples of the north are held to be secondary characteristics caused by mutation or selective pressure. Cole, 1965. Today, although WE cannot draw hard and fast boundaries, WE can identify two major racial groups on the African continent living on either side of the Sahara. In the north there is the Arab Berber group, which derives its genetic heritage from the Mediterranean peoples, Libyans, Semites, Phoenicians, Assyrians, Greeks, Romans, Turks, etc., and in the south there is the Negro group. A point to note is that climatic changes, which have sometimes obliterated the desert, have resulted in much mixing population groups over thousands of years. Nei Masatoshi and A. R. Roykut-Huri carried out a study 11 of the genetic differences within and between the Caucasoid and Mongoloid groups, using several dozen blood markers. They used correlation coefficients to establish the approximate dates when these peoples diverged and came into being as distinct groups. The Negroid grouping seems to have become distinct 120,000 years ago, whilst the Mongoloids and Caucasoids only separated 55,000 years ago. According to J. Ruffy, this chronology fits in with the greater part of our basic group data. 12 From that period onward, much interbreeding took place on the African continent. Attempts have even been made to bring out the biological distances between populations by statistical analysis of their main components. Jacquard set out to do this, using 5 blood group systems comprising 18 factors, for 27 populations extending from the Mediterranean region to south of the Sahara. 13He obtained 3 main groups comprising 4 aggregates, one to the north, the Caucasoids, consisting of Europeans, the Regwabat, the Saudi Arabs and the Kummer Tuaregs, a southern aggregate consisting of the Negro groups of Agades, and intermediate aggregates including some Bororo Fulani, the Air and Tassili Tuaregs, the Ethiopians, and so on, but also the Haradan, who are traditionally regarded as blacks. It would therefore be a mistake to take this subdivision as supporting the traditional classification into races, for, quite apart from what has been said above, the general shape of the subdivision depends on the amount of data taken into account. If it is very small, the points may be all clustered together. As regards the MEN living south of the Sahara, it should be noted that the original name given them by Linnaeus was Homo Afer, African. They were then called Negroes, and later still blacks, and sometimes the broader term Negroid was used to include all persons resembling the blacks who are found on the fringes of the continent or on other continents. Today, except for a few dissenting voices, the large majority of scholars agree on the basic genetic unity of peoples south of the Sahara. According to Boyd, the author of the genetic classification of human races, there exists only one Negroid group, which spreads over the whole of the sub-Saharan part of the continent, and is also found in Ethiopia, and it differs significantly from all the other major groupings. Research by Hiernaus has yielded remarkably convincing evidence to support this proposition. Without denying that variations are apparent at local levels, he has produced the findings of an analysis of 5,050 distances between 101 populations to show the uniformity of the peoples of the sub-Saharan hyperspace, which embraces the Sudanese as well as the Bantu, the inhabitants of coastal regions, and those of the Sahel, the Khoisan, Pygmies, Nilotic, Fulani and various minor groups such as those akin to the Ethiopians. On the other hand, he also shows the great genetic distance that separates Asian blacks from African blacks. Even in the field of linguistics, which has nothing to do with race but which has been used in racist theories to invent a language hierarchy. Reflecting the so-called racial hierarchy, with the pure Negroes on the bottom rung of the ladder, new systems of classification are shedding more and more light on the basic unity of African languages. Somatic variations can be explained scientifically by the causes of the changes discussed above. In particular, biotopes may give rise at one time to amalgamations of more composite populations, Nile Valley, and at other times to pockets of peoples which develop relatively atypical characteristics, to be found in mountainous country, forests, marshlands, and so on. Lastly, history accounts for other anomalies which have resulted from invasions and migrations, particularly in outlying areas. The biological influence of the Arabian Peninsula on the Horn of Africa is also evident in the peoples of that region, such as the Somali, Gala and Ethiopians, but also, no doubt, in the Tita, Fulani, Tukulor, Songhay, Hausa, and so on. I have seen Marca, Upper Volta, with very typically Semitic profiles. To sum up, the remarkable variety of African phenotypes is a sign that this continent has been evolving over a particularly long period. Such prehistoric fossil remains as are available indicate that the type found south of the Sahara settled over a very vast area stretching from South Africa as far as the northern part of the Sahara, the Sudan region having apparently been at the crossroads of these population movements. It is true that the history of Africa is not a history of races, but the pseudo-scientific myth of the superiority of certain races has all too often been misused to justify a certain historical record. Even today a half-breed is considered to be a white in Brazil and a black in the United States of America. The science of anthropology, which has already amply demonstrated that there is no connection between race and the degree of intelligence, has found on the other hand that such a connection does sometimes exist between race and social class. One may well ask when the historical primacy of culture over biology, which has been evident since man emerged, will finally prevail in thinking on this subject. Allele either of a pair of genes. Selection differential reproduction of genotypes from one generation to another. Gene migration crossing over of reproducing individuals from their original population to an adopted population, crossbreeding, regarded by racialists as deleterious for the superior race, in fact in this context represents an enrichment of the human gene pool. It is thus a positive factor in biological terms, though it may give rise to social problems. Genetic drift, a change in the composition of the genetic heritage which occurs by chance in a small and isolated human group, resulting in a drop in gene frequency or the disappearance of an allele. Mutation, the appearance of a change in a hereditary characteristic through the modification of one or more genes. Migrations and ethnic and linguistic differentiations. Old Rog. Historians were long convinced that the peoples of Africa had never had any history of their own, nor any evolution that was peculiarly theirs. Everything in the nature of a cultural achievement was thought to have been brought to them from elsewhere, by waves of immigrants coming from Asia. Such convictions are reflected in the works of many 19th-century European scholars. They were systematized and crystallized in the form of doctrine in the works of German ethnographers and linguists writing at that period. At that time, Germany was the main center of Africanist studies. Shortly after Africa had been divided up by the great colonial and imperialist powers, works describing the life and customs of the peoples of the colonized countries began to make their appearance in England, France, and Germany. It was in Germany that the potential of the scientific study of the African languages was first recognized. The year 1907 saw the Establishment in Hamburg of the Colonial Institute, which subsequently became a great center of scientific research and was responsible for the publication of the most important theoretical works of the German School of African Studies. Germany was far in advance of the other colonial powers in this field, for in England it was not until 1917 that the School of Oriental Studies began to teach African languages, whilst in France, at that time, the École de langues orientales vivantes paid little attention to them. It was only in 1947 that the School of Oriental Studies in London was renamed the School of Oriental and African Studies. In France, too, the systematic teaching of these languages was not introduced until slightly later. The theories of the German school and recent discoveries. All this explains why Germany played a predominant role in research into the history, ethnography, and languages of Africa in the period immediately preceding the First World War, and also why work which appeared in England, France, and Belgium was based on the theories of German scholars. Thus Western European ethnographers continued to maintain, at the beginning of the 20th century, the view propagated by German scholars that the peoples of Africa had never had a history of their own, and these views provided linguists with a basis for what is known as the Hamitic theory, according to which the development of civilization in Africa was influenced by the Hamitic peoples who came from Asia. An examination of these thoughts shows that they all derive from Hegel, who divided the peoples of the world into two kinds: historical peoples, who had contributed to the development of mankind, and non-historical peoples, who had taken no part in the spiritual development of the world. According to Hegel, there was no historical evolution in Africa proper. The destinies of the northern fringes of the continent could be said to be linked to those of Europe. Carthage, being a Phoenician colony, he considered formed part of Asia, and he saw nothing of the African spirit in Egypt. Hegel's ideas exercised a considerable influence over almost all the scientific research done on Africa in the 19th century, in particular on the first attempt at a history of the peoples of Africa by Swartz, WHO. Compares the history of the races of Europe to the events of a fine sunny day, and that of Africa to a heavy dream which the sleeper, on awakening, soon forgets. It was in Asia, Hegel said, that the light of the spirit dawned and the history of the world began. This was considered to be beyond dispute, and European scholars regarded Asia as the cradle of mankind from which emerged all the peoples who invaded Europe and Africa. It is interesting to note that the English ethnographer Stowe thought it quite certain that the oldest inhabitants of Africa, the San, came from Asia in two separate migratory waves, the first consisting of rock painters, the second of rock engravers, who took another, quite different route. They were said to have crossed the Red Sea by the Bab el Mandeb Strait and then traversed the equatorial forests, reaching the southernmost tip of the continent. The fullest account of the thesis propounded by the German school, fortified by its historical and cultural basis, regarding the progressive occupation of the African continent by successive waves of immigrants, is to be found in the works of the German geographer and traveler, Father Stull. Man. In fact, at the end of the 19th and the beginning of the 20th century, a vigorous offensive was launched against the doctrine of evolution, which constituted the theoretical basis of the works of R. Taylor, L. H. Morgan, Lubbock, and others. The cultural and historical school of thought repudiated the theory of a uniform, overall development of mankind and advanced a diametrically opposed theory, postulating the existence of different cycles of civilization, differentiated by intrinsic elements derived from a mainly material culture. According to These writers, the spread of cultural achievements was due mainly to migrations. First to put forward this view was the German scholar Leo Frobenius, and Ankerman subsequently described the progress of the cycles of civilization across Africa. But it was Stallman who gave the most detailed account of the development of African cultures. He maintained that the original population of Africa consisted of small people, the Pygmies, and the San, possessing virtually no elements of culture. Then arrived in migratory waves from Southeast Asia dark-skinned, fuzzy-haired Negro peoples who spread all over the Sudanese savanna and penetrated into the equatorial forest, bringing with them the beginnings of agriculture, the cultivation of bananas and root crops, the use of wooden implements and bows and arrows, and the building of round and square huts. These people spoke isolating languages. They would have been followed by waves of Proto-Hamites, also from Asia, but in this case from regions further north than those which were the homeland of the Negroes. The newcomers spoke agglutinative languages with noun classes, and they taught the indigenous peoples of Africa the use of the hoe in agriculture, the cultivation of sorghum and other cereals, the rearing of small horned cattle, and so on. The crossbreeding of the Proto-Hamites with the Negro peoples gave birth to the Bantu peoples. They were followed by invasions of waves of fair-skinned Hamites, coming into Africa, some through the Suez Isthmus, and some across the Bab el-Mandeb Strait. They were said to have been the ancestors of the Fulani, Hausa, Maasai, Bari, Gala, and Somali peoples, and also of the Khoikhoi. The latest arrivals brought further elements of culture to Africa, large horned cattle, spears, many uses of leather, shields, and so on. These fair-skinned Hamites, Stallman maintained, came originally from the steppes of Western Asia. They were followed by a wave of Semitic peoples, who provided the basis for the development of the culture of ancient Egypt. They brought with them the cultivation of cereals, the use of the plow and of bronze. They were followed, in Egypt, by the arrival of the Hyksos and the Hebrews, and, in the Ethiopian highlands, by that of the Habesha and the Murri. The last to come were the Arabs, in the 7th century of our era. All these peoples brought with them to Africa new elements of civilization that were quite unknown before their arrival. Stallman's work was published in Hamburg in 1910, not long before the First World War, but his ideas on the gradual building up of African civilization by alien races were developed later by other ethnographers, such as Spanus and Luschen in Germany, Seligman in England, and Honia in Austria. In linguistics, the Hamitic theory began to emerge parallel with the theories of the cultural historic school. The initiator of this theory, Meinhof, held that the ancestors of the present-day San were the oldest autochthonies of Africa, and that they were a race quite distinct from all others, and speaking languages which had click consonants, while the Negroes, considered to be autochthonous in the equatorial and Sudanic zones, spoke tonal and isolating languages with monosyllabic roots. Subsequently, Hamitic peoples entered the Sudan from Arabia by way of North Africa. These newcomers spoke inflected languages, they engaged in cattle breeding and, from the cultural point of view, were on a much higher level than the Negroes. Some of the Hamitic invaders, however, 273, traversed the savannas of East Africa and interbred with the indigenous population to produce the Bantu-speaking peoples. In short, this pattern can be reduced to a film in 4 sequences. At the outset, there were the click languages, and these were followed by the highly rudimentary isolating languages spoken by the Sudanic Negroes. The Mixture of these languages with the Hamitic languages produced the Bantu group of languages of the superior agglutinative type. Finally, the languages spoken by the Hamitic conquerors introduced the inflected languages which were eminently superior. The Hamitic theory was upheld by many linguists and spread from Germany throughout Western Europe and beyond. In the period between the two world wars, however, all these theories collapsed. The first blow they suffered came from the discovery of the Australopithecines in 1924 in South Africa. Other discoveries followed, and are still constantly being made, not only in the southern part of Africa, but also in North Africa and, more particularly, towards the east, in Tanzania, Kenya, and Ethiopia. All these discoveries combine to show, without any possibility of error, that the development of man in all his racial variety took place in Africa. Thus, any theories according to which Africa was populated by consecutive waves of immigrants are untenable. As the celebrated paleoanthropologist, Ehrenberg, so rightly points out, Africa is the only continent where there is evidence, in unbroken chronological sequence, of all the stages in the development of man. In fact, specimens of the Australopithecine age, Pithecanthropoid man, Neanderthal man and Homo sapiens succeeded one another, each with their implements, from the most distant eras right through to the Neolithic age. This bears out Darwin's theory that the remote ancestors of man lived on the African continent. Furthermore, these discoveries proved that it would be totally wrong to deny their endogenous cultural development. In this respect, the rock paintings and petroglyphs in the Atlas Mountains, in southern Africa, and in the Sahara provide striking evidence with far-reaching implications. There is no longer the faintest shadow of doubt about the great depth of the cultural archaeological evidence, since relative chronology, based on the form and treatment of objects and their stratigraphical position, has now been supplemented by absolute dating based on such scientific methods as carbon-14 and potassium-argon. The picture of the pattern of the cultural evolution of the African peoples has been completely transformed. For instance, it has been found that the Neolithic era in Saharan and Sahelian latitudes dates back much further than had been thought. This discovery completely alters the relationship between cultural development in Africa and in the Mediterranean world and, in particular, the Near East. The remains discovered in Tassili and Ager and also at Tadra Takakis, in the borderland between Algeria and Libya, are quite conclusive. Examination of hearths and ceramics discovered here shows that the people 274 were already using pottery from 8000 before our era onwards. At Akakis, a Negroid-type skeleton bearing traces of skin clothing was discovered. The materials examined date to 9000 before our era. A similar date applies to remains, discovered in the Ahagar Mountains, which were subjected to analysis in 3 separate laboratories. From these findings we may conclude that the Neolithic age in Tassili and Ager and Endi is apparently older than the Neolithic age in the countries of the Maghreb and is contemporary with that of southern Europe and Cyrenaica. Of particular significance are the results of research done on organic remains found in Neolithic camps in Lower Nubia. From the results obtained, it has been possible to draw the conclusion that people already gathered and prepared grain from wild cereals in the 13th millennium before our era. Radiocarbon tests on the remains found in the Balana district having indicated the date 12,050 plus or minus 280. The same method of examination applied to remains from the Tuska region gives the date 12,550 plus or minus 490. This proves that the gathering of grain from wild cereals was practiced in the Nile Valley 4,000 years earlier than in the Near East. According to a firmly entrenched historical tradition, any account of the history of Africa should start with Egypt. Today, however, there are good grounds for revising this view. The American Egyptologist Breasted, who wrote in the early years of this century, described the area made up of Egypt, Palestine and Mesopotamia as the Fertile Crescent, and indeed this zone does form a kind of crescent in which the pharaonic civilization took shape, and the city-states of Sumer and Akkad developed. But these date back only to the 6th or 5th millennium before our era, whereas, much earlier than that, the existence of climatic conditions suitable to the development of stock raising and rudimentary agriculture throughout the whole of the area lying between the valley of the Indus and the Atlantic Ocean had favored the emergence of a primitive form of class society and state. Thus, the Fertile Crescent represents only a terminal development in a large region teeming with life where, little by little, me and grew familiar with wild cereals and began to cultivate them, and also began to domesticate large horned cattle, sheep, and goats. Proof of all this is furnished by the study of rock paintings in the Sahara and by radiocarbon dating, together with the analysis of fossil pollens, etc. We may expect that some chronological schema may subsequently be made more precise. However, the theory about the peopling of Africa from Asia is already completely discredited. Instead, Africa must be recognized as the center from which men and techniques were disseminated in one of the key periods in the development of mankind, the early Stone Age. In later eras we find evidence of a reversal of this trend, with migratory currents flowing back to the continent of Africa. 275. Anthropological and linguistic problems. Comparison of the information furnished by the anthropological, linguistic, and cultural research done on the ancient history of Africa shows that anthropology certainly provides the most important and the most reliable data. Anthropological characteristics persist for a very long time, whereas languages undergo rapid changes, sometimes in the course of a few generations, as we see when a people emigrates to another linguistic area or when it is invaded by conquerors speaking a different language. So we see that the black population of North America has retained its original anthropological type unchanged by climatic and geographical conditions, very different from those in their continent of origin, but that its language and culture do not now differ from those of the white population of the United States. Only traces of its ancient African cultural and spiritual background remain in songs, music, dances, and religious beliefs. A parallel case is that of the city descended from the Africans who were taken to India centuries ago from the east coast of Africa. As late as at the beginning of the 19th century, these people still retain their own language, but they now speak the languages of the Hindu people. Amongst Whom they live, Gujarati, Urdu, and others, so that all that remains to indicate their African origin is their physical type. In both these cases, the language the Africans took with them to a foreign land was lost in the course of a generation or two. History of the languages spoken by the aboriginal inhabitants of North Africa may also be cited. After the conquest of the countries of the Maghreb by the Arabs, and more particularly after the invasion by Arab tribes in the 11th century, the population of the countries of North Africa became Arab so far as language and civilization are concerned. Their original languages survive only in parts of Morocco, and in Kabylia, Jebel Nafusa, and the Oases. According to the anthropologists, however, the main characteristics of the original physical type have remained unchanged, which shows that Pological features, while subject to the influence of the biotope on the physical character, are more stable than language or culture. It may be stated on the data at present available that, on the whole, the distribution of modern racial types throughout Africa reproduced the ancient pattern of the major anthropological groups, which are sometimes rather hastily termed races. Various types of the Mediterranean race have been represented in North Africa since a very distant era. East Africa was inhabited by peoples of an Ethiopoid type, as confirmed by the finds of paleoanthropologists in Kenya, and the whole of the extreme southern part of the continent by San groups. The tropical and equatorial forests formerly occupied a much larger area than at present, and it was probably there that the pygmies appeared. They were a separate race whose physical type developed in the special 276 environment of an extremely humid climate and the virtual absence of light in the forest. The Negroid race, called Sudanic or Congolese, developed to meet the conditions of tropical latitudes, in West Africa in particular. Probably because the acidity of tropical soils is not favorable to the preservation of fossils, few skeletal remains have been found for identification and dating. Nonetheless, after the first discoveries made during the excavations at Asilar, Negroid-type skeletons of various, sometimes extremely ancient, periods have been found not only in the Sahara, but also in southern Nigeria, which probably indicates that it was here that this particular human type evolved. The problem of the early peopling of the Sahara has been keenly disputed. But it is quite clear from a study of the rock paintings that a black population predominated in this area. Although other types can also be detected, such as the groups with Afro-Mediterranean features which were also early inhabitants in Egypt. Documents and monuments dating back to the Old Kingdom refer to Timihu Libyan peoples with fair skin and blue eyes, and also to darker skinned Tihenu peoples. Greek historical sources, too, speak of fair-skinned Ethiopians as well as of darker-skinned more southerly Ethiopians. It seems therefore that the ancient population of Libya was made up of different races. Thus we find one Roman author saying that some of the Libyans resemble Ethiopians, whilst others are of Cretan stock. 1 The ethnical composition of the population of the Nile Valley seems to have been very complex. As the Sahara dried up, its peoples retreated towards the humidity of the valley. Ethiopoid and the Afro-Mediterranean groups mingled with Negro groups of the Sudanic type. Same kind of intermingling probably took place in all the fluvio-lacustrine basins adjoining the desert, such as the lower Senegal, the middle Niger and Lake Chad. Since, as has already been stressed, the anthropological profile displays remarkable constancy, often over many thousands of years, it might not be entirely wrong to project some of the main features of the present-day ethnic pattern backwards into prehistory. In any event, a race is formed from the interaction of a great variety of factors progressively, creating different inherited characteristics but also transmitting these different characteristics through heredity. These characteristics derive from the need of a people to adapt itself to its environment, to the conditions of sunlight, temperature, vegetation cover, humidity, and so on. As a general rule, which is naturally subject to many exceptions, anthropologists suppose that the forest African is rather small in stature and light-skinned, whereas the African of the savanna and the Sahel is taller, lean and slim, and darker-skinned. However, things should never be viewed from only one angle, since many factors are at work simultaneously. For instance, the migration of groups bearing different genetic heritages immediately brought two possible sources of mutation into play. The first was the change of biotope, and the second the meeting of different groups. I script ors physiognomici, ed. R. Forster, 1893, Volume I, 389. 277. With the possibility of crossbreeding. Whenever a remarkable somatic resemblance is observed between two ethnic groups that are very remote from each other in space, such as that existing between the Dinka along the upper reaches of the Nile and the Wolof of Senegal, who look alike because they are both dark-skinned and tall, the fact that they live at the same latitude may provide the clue to a perfectly adequate explanation. However, the combination of factors brought into play by the actual march of history should always be borne in mind. 2. In this regard, the highly controversial case of the Pygmies and the San deserves to be studied in greater detail. In the past, it was assumed that there was a racial link between the Pygmies of Africa and those of southern Asia, but that theory now appears to have been discarded. There seems to be every reason for believing that these peoples are the outcome of the adaptation of a certain physical type to its environment, and that this process took place over a very long period of isolation. At the present time, pygmies are to be found in the forests of Cameroon, Gabon, some parts of the Central African Republic, Zaire, and Rwanda. It seems certain, however, that in the past they inhabited a much larger area. The oral traditions of some of the peoples of Western Africa contain references to groups of dwarfs who lived in the forest before the arrival of people of taller stature. The legends of some peoples of Western Europe speak of gnomes versed in the working of metals and living in the mountains. African traditions about dwarfish peoples are, however, to be taken more seriously in view of the fact that we possess historical evidence indicating the existence in the past of pygmies in regions where no trace of them can be found today. The earliest mention of pygmies is found in Egypt in inscriptions dating from the 6th dynasty of the Old Kingdom. Inscribed on the walls of the tomb of Herkhuf III at Aswan is the text of a letter from the pharaoh Pepi XI, in which the young king thanks him for bringing him, as a present, a dwarf named Den, a word found in the modern languages of Ethiopia, for instance in Amharic and its various dialects, and also in the languages Tigrinya, Gala, Kambata, and others in the forms Denk, Dank, Dinky, Donku, Dinka. For the letter states that a similar dwarf had been brought 100 years earlier to the pharaoh Isi, that is to say, during the 5th dynasty. In this connection it is worth recalling the report of an English traveller who spoke of the presence of dwarfs called Doko in some regions of southern Ethiopia. There is thus evidence that, in the past, there were dwarfs living in what is now the Republic of the Sudan and in present-day Ethiopia. The pygmies living in the equatorial forest were gradually supplanted by incoming peoples of tall stature speaking Bantu languages. The pygmies were driven into the densest and most distant parts of the forests of the Ituri and the Uil, as recounted in the Ensong Aliangia, the epic cycle of the Mongo dealing with the peopling of the valley of the Zaire. Similar legends exist also amongst other Bantu-speaking peoples. Thus the isolated groups of pygmies which now exist can be considered as the surviving enclaves that prove the existence of a more extensive population which once inhabited the equatorial and tropical forests of Africa. The San are another very specific group living in the continent of Africa. They are of small stature, with copper-colored or yellowish skin, and their hair grows in tufts. In anthropological studies, they are still put together with the Khoikhoi in a Khoisan race. This no doubt comes by extrapolation from the linguistic classification which places the languages of the San and the Khoikhoi in a single family characterized by the use of phonemic clicks. The term Khoisan, suggested by Shapira and NOW. Adopted in many works, is a combination of two Khoikhoi words, khoi, meaning man, and san, the root sa of which means to gather edible plants, pull up roots, collect fruits, and also to capture small animals. A human group is accordingly styled by its way of life, its mode of production. In point of fact, however, the San and the Khoikhoi have very few common characteristics. Account may be taken of the light color of their skin, and also the presence of click consonants in both their languages. It should be recalled, however, that this is not a specific characteristic. Such clicks exist also in the southeastern Bantu languages, such as Zulu, Xhosa, Soto, Swazi. Examination of the anthropological features of these two groups shows, however, that Khoikhoi and San differ in many respects, for instance, in stature, the Khoikhoi being distinctly taller than the San. They differ also in regard to cranial characteristics, 5 type of hair, and steatopygia, which is very common among the women, whereas the presence of epicanthus is specific to the San. Furthermore, the Khoikhoi and San languages differ as regards both grammatical structure and vocabulary. E. O. J. Westphal, a leading specialist in this field, showed that pronouns, the oldest and most stable part of speech, have remarkably highly developed forms in the Khoi languages. They have 2 genders and 3 numbers singular, dual, and plural. There are inclusive and exclusive forms, whereas in the San languages nothing similar exists. 6. There are therefore not sufficient grounds for classifying the San and Khoikhoi languages in one group. As to the culture of these peoples, they differ in every way. This was, moreover, noted by the first travelers who visited southern Africa in the 17th century, such as Peter Kalb. The Khoikhoi lived in kraals, worked metals and raised cattle, whereas the San lived by hunting and gathering and had no fixed dwellings. Thus, neither anthropologists nor linguists can provide sufficient grounds for assuming the existence of a Khoisan group consisting of Khoikhoi and San. These two groups of peoples have completely different histories. The San are certainly the remnants of the original population of the extreme south of the African continent. They are now confined to the inhospitable and waterless regions of Namibia and the Kalahari. Isolated clusters of them are to be found also in Angola. In former times, they inhabited the savannas of southern and East Africa as far as the borders of Kenya, as the toponymy and hydronymy of these regions bear witness, the local names of rivers and mountains being borrowed from the languages of the San. Click sounding consonants which are characteristic of the San languages have been borrowed by several Bantu languages. Finally, the rock paintings of the high veld of southern Africa show scenes of armed combat between short, light-skinned San and tall, dark-skinned warriors whose ethnic origin can easily be discerned from the shape of the shields they carry. A small ethnic group, the Hadzapai, living in the region of Lake Eyasi in Tanzania, is a further indication of the extent of former San settlement throughout Africa. The language of the Hadzapai has not yet been studied in sufficient detail, but there are grounds for thinking that it is related to those of the San. Sometimes support for the thesis that the San once occupied a much larger area than they do today is sought in the presence of round stones, pierced in the center, throughout East Africa. These ring-shaped stones, called kui by the San, were used for weighting a stick for digging up edible roots. However, it is not proved that this technique was diffused by the San group. Thus, for instance, among the Gala in southern Ethiopia and in the region of Harar, men dig the soil with long stakes called dongora, and these stakes are almost always fitted with such ring-shaped stones. The same device is used to weight the pestle for crushing tobacco. Thus it is not possible to uphold the view that the San formerly wandered everywhere where ring-shaped stones of the Kwi type are found. The earliest population of southern Africa should not, however, be considered solely in terms of the pygmies in the forests and the San in the savannas. Other peoples may have existed alongside these. There is, for instance, the fairly recent discovery in Angola of the Kwati group, which closely resembles the San in its style of life and probably also in language. At the beginning of the 20th century, Vetter studied the Otavi, who are the remnants of former groups. These people are of small stature and live by hunting and gathering. Unlike the San, they have a very dark skin and thick lips. The name by which they call themselves is Nu Koin, which means black people, as opposed to the Khoikhoi, Whom. They called red people. An extremely interesting feature of this group is their system of counting. It differs sharply from the system used by the Khoikhoi, Who count in tens. Groups such as these, which probably exist also in other areas, throw precious light on the very complex problem of the earliest peoples of the forests and savannas of Central and Southern Africa. The complexity of the problem is illustrated in the vocabulary and phonetics of the Bantu languages, for example when the presence of click sounds indicates very early contacts between ethnic groups. It follows that discrepancies exist between Bantu languages sometimes to the extent of differences in the word root structure, as in the case of the Jing group. In the northwest of the Bantu language area, these differences can only be the result of the influence of a pre-existing linguistic substratum. The Pygmies and the San, Who have been considered above, today constitute numerically minute groups compared with the predominant Negro groups and even with the Afro-Mediterranean race of North Africa. The linguistic map of Africa today does not coincide with that of the distribution of racial types, though it may have done so in the remote past. But as the early ethnic groups multiplied, migrated, and crossbred over a long period, the development of languages and the formation of racial types no longer coincided in time. By the process of forming racial types is meant the genetic heritage and gradual adaptation to the environment. At present there is no longer any correlation between racial and linguistic distribution. This is particularly evident in the peoples of the Sudan, a convergence zone for two different types of language families. North Africa, including Mauritania and Ethiopia, belongs to the vast Hamido-Semitic area of languages. This is an inapposite term in that it suggests that the languages of this family fall into two groups, Semitic and Hamitic. In the 19th century, indeed, linguists considered that this linguistic family was composed, on the one hand of the Semitic languages spoken in the Near East, and on the other hand, the Hamitic languages spoken in Africa. But the French Semitist and linguist M. Cohen stated quite rightly that there were no grounds for dividing these languages into two groups. In fact, it is NOW generally agreed that the languages of this family fall into five groups: Semitic, Cushitic, Berber, 7. Ancient Egyptian 8 and the Chad language group. Hence the languages of this great linguistic family are spoken by several races, both Semitic and Black. In the extreme south of the African continent, the San languages, to which the Kwati languages of Angola and Hadzapai in Tanzania have to be added, would seem to belong to a specific group possessing the two general characteristics of the presence of click sounds and an isolating type of structure. The wisest course would perhaps therefore be to classify these languages as Paleo-African, in the same way as the term Paleo-Asian is used for the languages of the peripheral regions of Northeast Asia. The Khoikhoi languages, whose grammatical structure is different, should not be included in this group. The Khoikhoi were cattle breeders 1. who came south with their herds from Northeast Africa and settled in the midst of San indigenous population. Some groups of San adopted the Khoikhoi language, for instance, the ethnic groups found in the Otavi Mountains. It is quite possible that this is also the history of the San central nucleus, especially the Naran. The view that this route may indeed have been taken by the Khoikhoi as they spread from the upper reaches of the Nile in the north across the savannas of East Africa is supported by the existence, not far from Lake Eyasi, in Tanzania, of the small Sanda group, whose language appears to be related to the Khoikhoi languages. The history of the Khoikhoi is, generally speaking, one of the most puzzling problems in the ethnic evolution of Africa. In this connection it may be noted that Westphal thought it possible that the click sounds in the Khoi languages may have been taken from the San languages. This would seem to be an interesting theory, but so far no evidence has been produced in its support. No doubt the savannas of East Africa were the first part of the continent to be inhabited by human beings. This region is inhabited today by peoples of Negro race speaking Bantu languages, but they were preceded by San and Khoikhoi groups, whose survivors are the Sanda and the Hadzapai. Other peoples in the same region speak Cushitic languages, or languages belonging to other linguistic families, Irako, for instance. These languages are those of peoples who lived in these parts before the arrival of the speakers of Bantu languages. Some of Whom made their appearance in comparatively recent times, between the zone of the Semito-Hamitic languages spoken in the north, and the zone of the Paleo-African languages which are spoken in the south of the continent. There is a vast zone inhabited by peoples speaking languages that Delafosse called Negro-African languages, Meinhof and Westermann called Sudanic and Bantu, and which Greenberg now calls languages of the Congo-Kordofanian and Nilo-Saharan families. As early as 1963, I recognized the unity of these languages, proposing that they be called the Zindje languages. Within this general category, linguistic families or groups could have been distinguished by further research. The term Negro-African languages is unsatisfactory. The first part of the term seems to confuse the concepts of race and language. Black inhabitants of the Americas, and sometimes even of parts of Africa itself, speak totally different languages. The second part of this term, African, is also inappropriate because all the languages spoken by the inhabitants of Africa, including Afrikaans, are African languages. Furthermore, the division of the Negro-African languages into two major groupings, Sudanic and Bantu, also appears to be an error, for Westermann's work shows that the languages of the Western Sudan, as regards both structure and vocabulary, have many features in common with the Bantu languages. It was his work which prepared the way for a general revision of the classification of African languages which the German school of linguists had launched in so unfortunate a manner. The classification proposed by Greenberg is based on the method of mass comparison. Whilst taking account of the basic features of grammatical structure, he concentrates attention mainly on vocabulary. Applying this method, In 1954 Greenberg distinguished 16 linguistic families, and then narrowed these DOWN to 12. This number was again subsequently reduced in 1963 to only 4. So rapid a reduction in the number of language families is sufficient indication that the method has not been adequately refined, and it also suggests excessive haste to produce a classification at all costs. Of the 4 families retained by Greenberg, the Afroasiatic group is, in fact, none other than the Semito-Hamitic family. As for the so-called Click language family, later called Khoisan, this comprises the languages of the San and Khoikhoi peoples. As has already been stated, this combination is mistaken. In addition to the Niger-Congo family, to which Greenberg later added the Kordofan languages, he distinguishes a 4th group formed by the Nilo-Saharan languages, but their structure has so far been very little studied. In 1972 Edgar Grigerson, using Greenberg's method, came to the conclusion that all languages of both families constituted but a single language family, for which he proposed the name Congo-Saharan. This opinion is in line with my own proposal to bring all these languages together under the heading of the Zindje group. This group is characterized by the use of varying tones and noun classes, as opposed to the Semito-Hamitic or Erythrean languages with their specific accentuation and grammatical gender. It is not impossible that further studies will reveal the specific character of particular languages or groups of languages within the Zindje or Congo-Saharan family, but this already displays the same type of coherence as does, for instance, the Indo-European family. Within the Great Zindje family, the Bantu languages undoubtedly display a significant homogeneity, as shown by the research of Bleek, Meinhof, and Guthrie. Among the subgroups detected by Westermann in the Sudanic linguistic groups, Mande is quite clearly that with the most positive identity. The west and the east of the Mande group are the languages which Westermann called the West Atlantic and the Gur languages respectively. However, the West Atlantic languages are not as homogeneous as the Mande languages, thus British linguists have seen within the West Atlantic languages a distinct group which they called the Mel languages. In point of fact, this extreme western region of Africa was a place of refuge where successive waves of small peoples were telescoped together under pressure from newcomers. Some of these languages still retain traits characteristic of the Bantu languages, the most striking case being that of Bilam. The earlier hypothesis that the Gur languages constituted a single unit has been disproved by the work of Manassi, an eminent authority in this field. The presence in these languages of noun classes formed in a great variety of ways by the use of prefixes, suffixes, and even affixes, is an indication of the ethnic complexity of the area, which has served as a refuge for many of the so-called Paleo-Nigritic groups, who may be found in mountain areas throughout the Sudan from Senegal to Kordofan. The theory was that they were remnants of the oldest autochthonous inhabitants of the Sudan. This reasoning seems, however, to be entirely without foundation. The composition of this mosaic of groups who have been crowded together in these inhospitable areas is extremely varied as regards both language and physical type. The Sudanese chronicles report on some of these events, thus showing that the process involved was not of very ancient origin. Hence, linguistic fragmentation in Africa has to be linked primarily to historical causes which triggered off waves of migration. All the languages of Africa, those of the eastern Sudan appear to have received the least attention. Among these Sudanese languages, the Nilotic languages form a separate group, or perhaps even a linguistic family, that is to say, a family of genetically related languages developed over a long period of isolation. The extreme complexity of the ethnic and linguistic composition of the peoples of the Eastern Sudan is shown in the remarkable work of the English linguists M. A. Bryan and A. N. Tucker, who devised a very interesting method for differentiating languages on the basis of the significance of a few characteristic linguistic features. This led to the division of the languages of the Eastern Sudan into two groups, the T/K and the N/K languages. Among the linguistic groups of this great Congo-Saharan family, the Bantu languages display so striking a genetic relationship that this must be regarded as being a relatively recent phenomenon. Of all the Zindje language groups, only the Bantu languages form a well-established unit. They undoubtedly constitute a genetically related family. The problem of elucidating the Bantu genesis is one to which not only linguists but also historians and archaeologists are devoting considerable research. But there are a number of theories. Some consider that the Bantu-speaking peoples came from the north and, more precisely, from the Cameroon region or, in the case of those who think they came from a wider area, the Chad Basin. The migration is presumed to have skirted the forest to the north, so as to outflank it on the east side, and then to have passed through East Africa to spread into southern Africa. Other scholars, like H. Johnston, believe that the Bantu came directly from the Central African region, through the Zarine forest. Lastly, some scholars, in line with the theories of the linguist Malcolm Guthrie, who situate the prototype linguistic core of the Bantu among the Luba and Bimba on the Upper Zaire, visualize their original homeland as being in that region. Going even further, the Bantu-speaking peoples are even presented as being a biological and cultural unit, overlooking the point that the term 284 Bantu has only a linguistic reference. However, some archaeologists link the spread of the use of iron in the southern part of the continent with the migration of the Bantu, who are presumed to have brought with them a superior technology. However, when the Portuguese landed on the island of Fernando Po, they found that the population spoke Bubi, a Bantu language, but knew nothing about the use of iron. This mistake of fusing languages and lifestyles or modes of production had already been made by the ethnographers who conceived of Hamite as involving a unity of race, language, and civilization. When historical development is being traced, it is most important not to set about trying to find pure types. It must be remembered that the peoples speaking Bantu languages vary greatly in their anthropological features, the color of their skin, their height, their physical build, and so on. Bantu-speaking people living in the forests have different somatic characteristics from the peoples living in the savanna. There are also great variations in the patrilineal domestic economy and social structure. Some Bantu speakers are matrilineal, while others have a patrilineal system. Some use masks and form secret societies. Others have nothing of the sort. The only thing all these peoples have in common is a similar language structure based on noun classes, the class indices having always a similar phonetic structure derived from a common base. In the savanna of the Sudan, there were apparently groups of peoples who lived side by side for a long time and who spoke languages with noun classes in which differences in tonality played an important part. As the Sahara dried up, these peoples withdrew to moister areas, to the mountains. To the north, the valley of the Nile; to the east, and the Great Paleo-Chad Lake. These groups of hunters and cattle breeders drove out the indigenous groups, who were forced to withdraw towards the south, either into the forest or round it to the east. These migrations were not necessarily connected with the beginning of the diffusion of iron working, but it is certain that the knowledge of metallurgy possessed by some of the newcomers gave them the advantage over other peoples. It so happens that copper deposits and ancient workings are located in the same region as that identified by Guthrie as being the nuclear Bantu area, where the Luba and Bimba languages contain the greatest percentage of words belonging to Acommo and Bantu vocabulary. Swift development of copper production was bound to be an incentive for the subsequent expansion of the civilization. Greater the distance from the nucleus, the less pure the Bantu linguistic type became, for, as they moved away from the center, the Bantu speakers mixed increasingly with peoples speaking other languages. This particular case shows us that the concepts of language, anthropological type and civilization must never be confused, but that, in the gradual settlement of the continent by many kinds of population movement, the 285 mode of production presumably often acted as a principal vector of linguistic expansion and even for the predominance of particular biological features. African linguistic classification. J. H. Greenberg. Nature and purposes of linguistic classification. Like any other set of entities, languages can be classified in an indefinitely large number of ways. One particular method, however, commonly called genetic classification, has certain unique and important characteristics so that when the term classification is employed without further specification in relation to language, it is this type of classification which is meant. It will, accordingly, form the basis for the detailed classification to be set forth in later sections of this chapter. A genetic classification takes the form of sets of hierarchical units with the same logical organization as a biological classification into species, genera, families, and so on, in which the members of the set at each level are included in those of a higher level. It could in fact be set forth in the form of a genealogical tree. For languages to have an immediate common ancestor in such a tree means that they are all the later differentiated continuations of what were once dialects of the same language. We may illustrate this by the well-known example of Indo-European. Since Indo-European has not yet been shown to belong to any higher grouping, this will be our highest level. The Indo-European family is divided into a number of branches, for example, Germanic, Celtic, Slavic, Indo-Iranian and others. This is another way of saying that the original Indo-European speech community eventually divided into a certain number of dialects, Germanic, Celtic, and so on. In turn, Germanic, for example, split into three dialects, Gothic, West Germanic and Scandinavian. These Gothic is extinct but known from earlier records, while West Germanic differentiated into Anglo-Frisian, Low German and High German. Each of these constitutes a group of present-day local dialects, some of which have become the basis of standard languages, for example, German, a High German dialect, Dutch, a Low German dialect, and English, an Anglo-Frisian dialect. The importance of such classifications is that they reflect the actual history of ethnic differentiation in respect to language. Secondly, they form the basis for the application of the methods of comparative linguistics by means of which much of the linguistic history of individual groupings can be reconstructed. Finally, such knowledge of linguistic history provides the Essential basis for inferences regarding the non-linguistic cultural history of the groups concerned. The history of African linguistic classification. It is obvious that without an adequate accumulation of empirical data regarding the languages of Africa, it would not be possible to undertake a comprehensive classification of the languages of the continent. Even minimal satisfaction of this requirement was not present until the earlier part of the 19th century. However, even previous to this period, certain observations relevant to classification had been made, based on an accumulation of data that began essentially in the 17th century when the first grammars and dictionaries of African languages began to appear. For example, Luis Mariano, early in the 17th century, noted that the Malagasy language was very similar to Malay, which proves in an almost certain manner that the first inhabitants came from the ports of Malacca. 2. At a similarly early period, several Portuguese investigators noted the similarity between the languages of Mozambique on the east coast of Africa and Angola and the Congo on the west, thus foreshadowing the notion of a Bantu family of languages covering most of the southern third of the continent. Another example are the descriptions of Ge'ez and Amharic by Job Ludolphus in the 17th century, who showed that these Ethiopian languages were related to Hebrew, Aramaic, and Arabic. The 18th century saw only very modest additions to our knowledge of African languages, but towards the end of that period we find that the basic concept of genetic classification begins to come into clearer focus in the form of specific hypotheses regarding the existence of certain language families. It was such hypotheses that formed the basis in the 19th century of the development of linguistics as a comparative historical science. Works on the history of linguistics commonly cite a statement by William Jones in 1786 to the effect that the relationship of Indo-European languages was the decisive event in regard to these developments. That such ideas were in the air can be seen from the fact that 5 years earlier Marsden had, with at least equal clarity, enunciated a similar hypothesis in regard to the Malayo-Polynesian languages and likewise Gyarmathy for the Finno-Ugric languages. These developments were accompanied by a virtual mania for collecting comparative materials on large numbers of languages. The earliest of these was the Glossarium Comparativum Linguarum Totius Orbis of 1787, sponsored by Catherine the Great of Russia, which included data from 30 African languages in the revised edition of 1790-1. The early 19th century was marked by a great acceleration in the production of grammars and dictionaries of African languages, as well as the publication of comparative word lists of considerable numbers of African languages, such as those of Killam, 1841, Norris, 1841, and Clark, 1843. 3. By far the most important of these in its extent, systematic organization and consistency of phonetic symbolization was the classic Polyglotta Africana, compiled in Freetown, Sierra Leone, by S. W. Coel. 4. This accumulation of data in the first part of the 19th century was paralleled by the first attempts at overall classification, for example, by Balby, and in successive editions of Pritchard's Inquiry into the Physical History of Mankind. 5. In spite of differences in details, certain generally accepted conclusions emerged during the first half of the 19th century. Some of these have stood the test of subsequent research, while in other instances they at least raised the fundamental questions to which subsequent classifiers had to address themselves. The results which had thus been attained by I-860 may be summarized as follows. 1. The term Semitic, introduced by Schulhauser in 1781, was already understood in approximately its present form. 6. The existence of an Ethiopian branch of this family was well established, including Ge'ez, classical Ethiopy, and such modern languages as Amharic and Tigrinya. 2. The resemblances and probable relationships of certain other languages to Semitic were already noted. These included ancient Egyptian, Berber and the Cushitic languages. These latter are spoken mainly in Ethiopia and Somalia. Hausa in West Africa was by some included in this category. These languages were sometimes called Sub-Semitic. The name Hamitic was proposed by Rana in 185. 7. 3. In southern Africa Liechtenstein is credited with making the first clear distinction between the Khoikhoi and San languages on the one hand and the Bantu on the other. 8. The identity of this latter group of closely related languages was by this time clearly recognized. It was variously called the Kafrarian or South African family of languages. The name Bantu, from the word for people, in many of these languages, was first proposed by W. H. I. Bleek, the founder of comparative Bantu studies in 1851, and is the name under which it has been known ever since. 4. There remained a very large group of languages embracing most of those spoken in the western and eastern Sudan which could not be assigned to the groups just mentioned, that is, those which were not Semitic, Hamitic, San or Bantu. These were generally called Negro languages and provided the greatest problem for classifiers. Norris in his 1855 revision of Pritchard's work admitted that they eluded classification and that the Negroes hitherto have been considered as constituting one race rather from physiological than philological evidence. 9. Although all the overall classifications of African languages up to the recent period completely separated Bantu from Negro languages, a few observers noted that some or many of the languages considered to be Negro, especially those in West Africa, showed relationship to Bantu. Apparently the first was Bishop O. E. Vidal in his introduction to Samuel Crowther's Grammar of Yoruba degree. A comprehensive statement is that of Bleek. Who extended the name Bantu to the greater part of Western Africa as far as 13° northern latitude, extending in that region from the lands of Senegal to those of the Upper Nile. 1. This basic idea was revived in modified form much later by Westermann and in a more explicit way by Greenberg in the now current classification. 5. The affiliation of Malagasy to Malayo-Polynesian and hence its non-relationship to the languages of Africa had been already noted as early as the 17th century, as has been seen, and was generally accepted. The decade of the 1860s was noteworthy for two comprehensive classifications which were destined to dominate the field until about 1910. The first of these was that of Lepsius, which appeared in two versions in 1863 and 1880 respectively. 12. The other was that of Friedrich Müller, which likewise had two versions, that of 1867 and 1884. 13. The work of Müller provided the basis of the important study of R.N. Cust, which helped to popularize his work in the English-speaking world. Cust's essay is an extremely valuable source for the bibliography of African linguistics up to that period. Both Lepsius and Müller excluded Malagasy from consideration as linguistically non-African. For the rest, the main problem to which they addressed themselves was that of the Negro languages and their position in Relation to Bantu, since the latter was the one well established and extensive. Grouping of languages spoken by Negro peoples. In both Miller's and Lepsius classifications, racial considerations played a large role, although in different ways. The basis of Lepsius classification was the criterion of types of noun classification. This approach derived from the earlier work of Bleek. 1851, 14. Bleek was impressed by what he considered the fundamental difference between the Bantu languages, which had complex systems of noun classes in which sex-gender played no part, and the Semitic and Hamitic languages which had sex-gender as their principle of noun classification. Pursuing this distinction, Bleek assigned Khoikhoi to Hamitic because it had sex-gender, in spite of its basic similarities in virtually all other respects to the San languages. Lepsius, taking Bleek's general idea as his point of departure, considered that among languages spoken by black populations, Bantu with its non-sex noun classification was fundamental, while the remaining languages were mixed, having undergone Hamitic influence. He classified the languages into 4 groups: 1. Bantu, 2. Mixed Negro, 3. Hamitic, 4. Semitic. Fundamentally there were, however, 2 sets of languages, a. Bantu and Mixed Negro, class languages, and b. Semitic and Hamitic, gender languages. Ultimately the latter should be shown to be related to Indo-European, which also has sex-gender. In fact, Indo-European, Semitic and Hamitic were called by him the Noahite family with its 3 branches, representing the 3 sons of Noah, Japheth, Shem, and Ham. The superiority of the gender languages is explicitly stated. It seems, however, unquestionable that the 3 great branches of gender languages were not only in the past the depositories and the organs of the historical process of human civilization, but that to them, and particularly their youngest branch, the Japhetic, belongs the further hope of the world. 15. The intellectual line of descent of the Hamitic theory from Bleek through Lepsius to the theories of Meinhof at a later period is evident. In Miller's comprehensive work of 1884, the world's known languages are classified on the assumption of a fundamental agreement between physical type and language. His basic divisions are the languages of the straight-haired peoples, the languages of the woolly-haired peoples, and so on. This assumption leads him, for example, to classify Khoikhoi not with Hamitic, like Lepsius, but with Papuan among the languages of the frizzy-haired races. The majority of Negro languages are divided into African Negro and Bantu. His hypothesis on this question is the exact opposite of Lepsius, since he considers the former basic and the latter derivative. A number of languages spoken by black populations are considered to belong to a more culturally advanced group called Nubafola, whose speakers were physically related to Mediterraneans and Dravidians as curly-haired. In CUSD's popularizations of Muller for the English-speaking world, the languages of Africa are divided into the following 6 groups: I. Semitic, 2. Hamite, 3. Nubafola, 4. Negro, 5. Bantu, 6. Khoisan. For some time questions of classification were in abeyance as interest concentrated on the vast scientific task of African language description. Westermann's work on the Sudanic languages, 1911, and Meinhof's on Hamitic, 1912, usher in the modern period. 16. The former of these, whose basic thesis was apparently developed by Westermann under Meinhof's influence, introduced the term Sudanic to embrace virtually all the languages of Africa not included in Semitic. Hamitic, in the extended sense given it by Meinhof, Bantu, or San. It thus embraced essentially all those languages which had earlier been called Negro languages. Westermann selected from this vast assemblage 8 languages. Nowhere is a complete listing given, of which 5 were from the Western Sudan and 3 from the Eastern Sudan, and sought to establish their relationship by a series of etymologies and reconstructed ancestral forms. Meinhof, already famous for his basic work on comparative Bantu, in his book on the languages of the Hamites sought to extend the membership of Hamitic beyond generally accepted bounds to include such languages as Fulani, Maasai and, following Lepsius, Khoikhoi, basically on the criterion of gender. This work contained definite overtones of Hamitic racial superiority. 7. From the joint work of Meinhof and Westermann there thus emerged a five-fold scheme: Semitic, Hamitic, Sudanic, Bantu, San. These results were popularized in the English-speaking world by the writings of Alice Werner and became standard in anthropological and linguistic textbooks. 8. This classification did not remain unchallenged during its period of dominance, approximately 1910 to 50. Though not reflected in the usual textbook treatment, the most significant criticism came from Westermann himself in his important study of 1927 on Western Sudanic languages. 19. In this work he limited his former conception of Sudanic languages to those of West Africa and distinguished by means of detailed lexical and grammatical documentation a number of distinct subgroups within West Sudanic, e.g. West Atlantic, KWA, GR. Even more significantly he pointed to detailed resemblances in vocabulary and grammatical structure between West Sudanic and Bantu, without ever stating their relationship in a fully explicit manner. In fact, Sir Henry Johnston in his vast work on Bantu and Semi-Bantu had considered many West African languages as affiliated with Bantu. 20. In his terminology they were Semi-Bantu. However, he adhered to the typological criterion of noun classification, so that of two closely related languages if one had noun classes it would be Semi-Bantu while the other would not. Brief mention should also be made of several other classifications of the period 1910 to 50 of which only that of Delafosse attained any currency. 1. Of these was proposed by a Drexel who sought to establish an agreement between African language families and cultures, a relationship which was posited by the Culture Chrysler. The French Africanist M. Delafosse, in contrast to the German investigators of the period, limited Hamitic to Berber, to Egyptian and Cushitic and treated all other non-Semitic and non-Khoisan languages as forming a vast Negro-African family. 22. In addition to 16 non-Bantu branches, many of which were established on a geographic rather than a purely linguistic basis, Delafosse apparently considered that Bantu was to be included as Negro-African. Part of Delafosse's terminology is still current among Africanists of French expression. Men should also be made of Mile Homburger who likewise, starting from the notion of African linguistic unity but even more broadly conceived, espoused the theory of an Egyptian source as the explanation of this unity and even, without considering it to be contradictory, an ultimate derivation from the Dravidian languages of India. 23. In 1949-50 in a series of articles in the Southwestern Journal of Anthropology, the present writer outlined what was in many respects a new classification and one which ultimately won broad acceptance. 24. It differed from previous classifications methodologically in a number of ways. It was strictly genetic in the sense described in the introductory section of this paper. Hence massive resemblances among groups of languages involving sound and meaning simultaneously, whether involving roots, vocabulary, or grammatical form ants, were viewed as probative. Resemblances involving sound only, without meaning, for example, agreement in having. Tone or resemblances extending to meaning only without sound, for example, grammatical gender where the phonetic form of the markers did not agree, were considered irrelevant. Such typological features had, as we have seen, figured largely in previous classifications. Thus the mere possession of sex gender was not considered as evidence for relationship. Since, for example, sex gender may and does arise independently in different parts of the world. On the other hand, the existence of a feminine gender marker T in all branches of Afroasiatic, Hamido-Semitic, is a piece of positive evidence for relationship. Similarly, the absence of gender through loss of the category is not in itself negative evidence. This is generally accepted in areas where the comparative method is well established, for example, Indo-European, Persian, Armenian, and Hittite among others do not have sex gender, whereas most other languages of the family do. Earlier classifications, for example, that of Lepsius, did not use and cite any concrete evidence for groupings. Westermann in his work on Sudanic did provide etymologies, but only for 8 languages out of the hundreds involved. The only previous work which did this in detail was Westermann's later work on Western Sudanic, and this only for part of Africa. In the present writer's classification, etymological and specific COMMO and grammatical features were presented for all major groupings based on an exhaustive review of the literature. The most important concrete proposals, some of which have produced a fairly extensive controversial literature, are the following. A. The relationship of Bantu to Western Sudanic based in Westermann's data is accepted. Moreover, Bantu became not a separate branch of the larger family but merely a subgroup within what Westermann called the Banyukongo, semi-Bantu, sub-group of his Western Sudanic. Further, MANY other languages farther east, Adamawa Eastern Branch, are part of the family, which was renamed Niger-Congo. B. Of the proposed extensions of Hamitic by Meinhof, only Hausa was accepted. Further, Hausa is but one member of an extensive branch, Chadic, of Hamido-Semitic. Semitic is included but merely as a single branch coordinate with the others. Hence, Hamitic becomes merely an arbitrary name for non-Semitic branches of the larger family, now renamed Afroasiatic and viewed as consisting of 5 branches: I. Berber, 2. Ancient Egyptian, 3. Semitic, 4. Cushitic, 5. Chadic. 25. C. Negro languages not included in Niger-Congo were shown to belong to another major grouping called Nilo-Saharan. D. Khoikhoi was classified as a San language belonging to the central group of South African Khoisan. The overall result is that African languages are classified into 4 major families, excluding Merina, as described in the following sections, in which each one of these families is considered in detail. 26 in this exposition. Recent proposals modifying or extending the original classification are mentioned, where appropriate, as well as more drastic criticisms. The Afroasiatic languages 27. These languages, also called Hamido-Semitic, cover all of northern Africa, almost all of the eastern Horn of Africa, Ethiopia, Somalia. Some languages of the Cushitic branch are spoken as far south as Tanzania. In addition, the Semitic branch includes languages which at present or in former times included almost the entire Middle East. Afroasiatic is generally analyzed as consisting of 5 about equally differentiated divisions: Berber, 2-8 Ancient, Egyptian, Semitic, Cushitic and Chadic. However, Fleming has recently proposed that the languages which had been hitherto classified as West Cushitic, a group including Kaffa and other languages in southwestern Ethiopia, in fact constitute a sixth branch for which the names Omotic and Aribana have been proposed. 29. The Berber branch of Afroasiatic has less internal differentiation than any other branch of Afroasiatic except Egyptian. Its main division seems to be between the language of the various Tuareg groups in the Sahara and the Berber proper of North Africa and Mauritania. It is probable that the extinct language of the Guanches of the Canary Islands was affiliated with Berber. In addition, mention should be made of the existence of Old Libyan inscriptions which are imperfectly understood but possibly represent an earlier form of Berber. A second branch of Afroasiatic, the Egyptian, is documented in the earlier period by hieroglyphic inscriptions, hieratic papyri, and in the latest period also by documents in the Demotic script. All these scripts represent the same spoken language. In the Christian period this language continued to be spoken and developed an extensive literature written in an alphabet adapted from the Greek. In this later or Coptic form there were a number of literary dialects of which Bohairic still survives in liturgical use in the Coptic Church. After the Arab conquest of Egypt, the ancient Egyptian language gradually lost ground and became extinct as a spoken language probably in the 17th century. The Semitic branch of Afroasiatic has far more internal differentiation than either Berber or Egyptian. It is usually assumed that the most fundamental division within Semitic is between East Semitic and West Semitic. The former is represented only by the long extinct Akkadian, written in cuneiform. It has two basic regional dialects, Southern Babylonian, and Northern Assyrian. West Semitic is in turn divided into Northwest Semitic and Southwest Semitic. The former of these includes Canaanite, Hebrew, Moabite, Phoenician and, probably, Ugaritic, and Aramaic. These only Hebrew, revived as a spoken language within the past century as the language of Israel, and two dialects of Aramaic still survive. The modern forms in Aramaic represent survivals of West Aramaic in the Antileban of Syria, and East Aramaic chiefly in northern Iraq. Southeast Semitic likewise has two divisions, Northern and Southern. The northern branch contains most of the dialects of the Arabian Peninsula and their modern descendants, dominant in a vast area embracing North Africa, the Middle East and parts of the Sudan, i.e. Arabic proper. The southern division consists on the one hand of South Arabic and on the other of the Semitic languages of Ethiopia. South Arabic is known in its earlier form from Minean, Sabaean, and Kadabanian inscriptions and in its contemporary form of Murri and Shari in South Arabia and Socotra, the language of the island of Socotra in the Indian Ocean. The Ethiopian Semitic languages divide into a northern group, Tigrinya, Tigray and Ge'ez or Classical Ethiopi, and a southern group, Amharic, Gurj, Argaba, Gafat, and Harari. The fourth group of Afroasiatic languages, the Cushitic, contains a large number of languages which fall into 5 strongly differentiated branches, the Northern, Central, Eastern, Southern and Western. Northern Cushitic consists essentially of a single language, that of the Beja. The Central Cushitic languages are sometimes called the Agau languages. They were probably once spoken over a continuous area, but their former speakers have largely adopted Ethiopian Semitic languages. The Falasha, or Ethiopian Jews, formerly spoken Agao language. The Central Cushitic. Languages include a northern group, Bilan, Khmer, Kement, and Awiya in the south. Eastern Cushitic includes the two Cushitic languages with the largest number of speakers, Somala and Gala. The Eastern Cushitic languages fall into the following groups: I, Afar, Saho, 2, Somala, Bazo, Rendile, Boni, 3, Gala, Konso, Gidali, Arbori, Warazi, Samai, Jelaba. 301. Magagado, 4, Sidamo, Alaba, Darasa, Hadiya, Kambatha, Burji. Of these, the last or Sidamo Burji is probably to be grouped as a single branch against the three others. The Southern Cushitic languages are spoken in Tanzania. They included Burunji, Goro, Alawa, Ngambia, Asu, Sanyi, and Bugu. This southern group is linguistically closest to Eastern Cushitic and is quite possibly to be classified as merely a subgroup of the latter. One Southern Cushitic language, Mbugu, has been extensively influenced by Bantu both grammatically and lexically, so that some investigators consider it to be a mixed language. The Western Cushitic languages are extremely divergent from the other languages traditionally considered to be Cushitic. At the very least, Cushitic would fall into two groups, Western versus the remainder. As noted earlier, Fleming has proposed that it be considered a separate sixth branch of Afro-Asiatic. The Western Cushitic languages may be divided into two groups. Aribana, for Ari, the term Bako was used in the earlier literature, and the remainder. These in turn may be grouped as follows: 1. Maji, now, Sheko. 2. Janjaro, 3. Kafa, Mocha, Shin-Asha, Southern Mao, 4. Gimira, 5. The Omito group, Western Sidamo, including Chara, male, Baskato, the Welamo cluster, Zais, and Koiragidisha. The last branch of Afro-Asiatic to be considered is Chadic. It includes Hausa, the most widely spoken language in West Africa, and perhaps as many as 100 other languages spoken by much smaller populations. In Greenberg, 1963b, the Chadic languages were divided into 9 subgroups as follows: 1. A. Hausa Gwandara, B. Bedanjism, C. I. Warjawa. Northern Bachi, Group, 2. Barawa, Southern Bachi, Group, D. I. Bolwa Group, 2. Angas Group, 3. Ron Group, 2. Kodoko Group, 3. Bata. Marji, 4. A. Muskoi Group, B. Murakam Group, 5. Gidir, 6. Mandara. Gamergu, 7. Musku, 8. Masabana Group, 9. Eastern Chadic, A. Samrai Group, B. Gabari Group, C. Sokoro Group, D. Module, E. Tuberi, F. Muabi Group. NEWMAN and MA have suggested that of the above subfamilies, 3, and 6, are particularly close to each other, and likewise, 1, and 9. For the former of the groupings the name Biomandara is proposed, and for the latter Plateau Sahel. 30 Nothing is asserted by them regarding the other sub-groups. Niger Kordofanian. This family has 2 branches, very unequal in numbers of speakers and geographical extent. The first, Niger-Congo, covers a very considerable portion of sub-Saharan Africa, including almost all of West Africa and parts of the central and eastern Sudan, and its Bantu sub-branch occupies most of Central, East, and Southern Africa. Kordofanian, the other branch of Niger Kordofanian, is confined to a limited area in the Kordofan region of Sudan. The basic division with Niger-Congo is that between the Mande languages and the rest. In addition to lacking many of the most common lexical items found in the rest of Niger-Congo, Mande has no convincing traces of the noun classification generally found both in Kordofanian and in the remainder of Niger-Congo. There are, of course, many individual languages in Niger-Congo which have lost this system. Because of this divergence of the Mande language, Makarovsky has proposed that Mande is really a branch of Nilo-Saharan, the other large family of Negro-African languages, but the well-known expert on Mande languages, William E. Weimers, disagrees. 31. Within Mande it is now universally agreed that the division between Mande Tan and Mande Fu based on the word for ten first proposed by Delafosse is invalid. 32. The Mande languages may be classified as follows. A. Northern Western Division, I. Northern including Susu Yelanksa, Sinink, Huilanumua, Ligbi, Vikono, Kasanki and Maninka. Bombaradiola, 2. Southwestern, Menbandi, Loko, Loma, Kapel. B. Southern Eastern Division, 1. Southern, Mono, Dan, Tura, Mwa. Nwa, Gan, Guro, 2. Eastern, Samo, Bisa, Busa. A single language Sia Bobo Fing, remains unassigned. It is clearly Mande, but it should perhaps be considered the earliest offshoot within the stock so that genetically it represents one of two branches, the other being Mande proper. The remaining Niger-Congo languages are classified in Greenberg 1963 C, into 5 branches, 1. West Atlantic, 2. Gur, 3. Kwa, 4. Benue. Congo, 5. Adamawa Eastern. However, of these groups, 2, 3, and 4 are particularly close and form a kind of nuclear group within which in particular the boundary between Benue-Congo and Kwa is not clear. 33. The West Atlantic languages, a term introduced by Westermann in 1928, and substantially identical in its membership with the Senegaloguinine of Delafosse and subsequent French investigators, falls into two clearly marked groups, a northern and a southern. This and the internal diversity, particularly in the northern group, has led Dalby to suggest the abandonment of the concept of West Atlantic and to the assertion of the independence of the southern subgroup, consisting of Greenberg's Southern West Atlantic minus Limba. For this group he proposes the term Mel. 3-4. However, in a more recent study David Sapir, buttressed by glottochronological evidence, reasserts the basic unity of West Atlantic as traditionally conceived and includes Limba within the southern branch. 35. The chief innovation that he proposes is that Bijago, the language of the Bijago Islands, should be considered a separate branch coordinate with the northern and southern. This corresponds with MYOWN impression of the divergence of this language. It should be noted that the classification of Fula, considered to be Hamitic by Meinhof and the subject of much controversy, is now by general agreement included within West Atlantic. The classification of West Atlantic is then as follows: A. Northern branch. I. A. Fula, Sirir, B. Wolof, 2. Non group, 3. Diola, Manjak, Balant. 4. A. Tenda, Basari, Bidik, Konyaki, B. Biafata, Pajati, C. Kabiana. Banham, D. Nalu, B. Southern branch, 1. Sua, Konanti, 2. A. Temn. Baga, B. Sherbrokrim, G. Shi, C. Gola, 3. Limba, c. Bijago. Another major grouping within Niger-Congo is Gur. An alternative name is Voltaic, a designation which is particularly common in the French literature. Most recent suggestions regarding subclassification within Gur is that of Bender Samuel, which is followed here in outline. It is noted that the great majority of languages which have been considered to be Gur belong to one very large subgroup called Central Gur by Bender Samuel. 36. This corresponds to the Mossy-Grunchy group of earlier investigations. Central Gur may be divided into three subgroups: 1. More Gurma, 2. Gruzi group, 3. Tamari. Remaining subgroups of Gur are 1. Bargu, Baraba, 2. Lobarai, 3. Bwamu, 4. Kulango, 5. Gurma. Tairama, 6. Win, 7. Sanyafo group, 8. Semet, 9. Dogon. Even granted the validity of AKWA group as distinct from Binya-Congo. As mentioned earlier, there are two subgroups, Kru in the extreme west and Iho in the extreme east, whose assignment to KWA may be considered doubtful. With these reservations, the basic subgroupings of KWA are as follows, stated in approximately west to east order: 1. Kru languages, 2. Western KWA, which includes the UFO, the Akangwang, now sometimes called Volta-Camo, Gaodang, and the so-called Togo remnant languages, 3. Yoruba, Igala, 4. Nuk group, 5. Edo group, 6. Idoma group, 7. Igbo, 8. Iho. Binya-Congo is essentially the same subgroup of Niger-Congo, which was called Binya-Cross or Semi-Bantu by Westermann, with the addition of Bantu within the Bantoid subdivision. There are four basic divisions within Binya-Congo: 1. Plateau languages, 2. Jokonoid, 3. Cross River, containing as its largest language community Effikibabio, 4. Bantoid, consisting of Bantu, Tiv, and a number of smaller languages in the Middle Benue area. A number of languages in Nigeria formerly considered semi-Bantu in the broad sense are now generally agreed to be Bantu. Included here are the Bamileke, Ikoi, and Jarawa groups. The most fundamental division within Bantu itself may be between such languages and Bantu in its conventional acceptation. Within Bantu in this latter sense, the basic division appears to be between Eastern and Western Bantu. For finer subgroupings, the division by Guthrie into zones indicated by letters, but variously modified by different specialists, is current. 37. The assignment of the Bantu grouping as a whole to a subgroup of Binya-Congo, itself a branch of the large Niger-Congo family, has been one of the most controversial aspects of Greenberg's classification. Guthrie in particular espoused the notion that Bantu is genetically independent and that the extensive resemblances to Bantu found in the other Niger-Congo languages is the result of Bantu influences on a fundamentally different group of languages. He has argued on this basis that the original Bantu point of origin is the nuclear area of southern Shaba. Greenberg places it in the Middle Benue Valley in Nigeria because the most closely related languages of the Bantoid subgroup of Binya-Congo are spoken there. 38. The final grouping within Niger-Congo is the Adamawa Eastern Branch. The Adamawa group consists of many relatively small language communities. Among WHOM, the Chumba and Mbum may be mentioned as examples. The Eastern Branch contains a number of languages of major importance, for example, Bia in the Central African Republic and Zanda. 39. In contrast to the vast Niger-Congo family just discussed, the other branch of Niger Kordofanian, namely the Kordofanian languages, contains no language of major importance and shares the Kordofan Hills with various languages of the Nilo-Saharan stock. It may be divided into 5 highly differentiated subgroups, of which one, the TUM group, is the most divergent of all. These subgroups are I. Koalib, 2. Tagali, 3. Taladai, 4. Katla, 5. TUM, also called Kadugli Krongo. 40. The Nilo-Saharan family. The other major Negro-African language stock is Nilo-Saharan. In general, it is spoken north and east of the Niger-Congo languages and is predominant in the Upper Nile Valley and the eastern parts of the Sahara and Sudan. It has, however, a western outlier in Songhay of the Niger Valley. It has one very large branch, Shari Nile, containing the majority of the languages of the entire family. In essentially west to east order, the branches of Nilo-Saharan are as follows: 1. Songhay, 2. Saharan, a. Kanuri Kanembu, b. Tidadaza, c. Zagawa, Berdi, 3. Maban, 4. Furian, 5. Shari Nile, c. The following sections for further details: 6. Koman, Koma, Gonza, Uduk, Gi, Gumuz and Ma. The Shari Nile languages include 2 major groups, Eastern Sudanic and Central Sudanic, and 2 individual languages, Berda and Kunama. Eastern Sudanic is the largest single unit within Nilo-Saharan. It contains the following 10 subgroups: I. Nubian, a. Nile Nubian, b. Kordofan Nubian, c. Midab, d. Bert, 2. Muldidinga groups, 3. Beria, 4. Ingasana, Tabi, 5. Numafidi, 6. T-Main, T-Zumdanab, 7. Mararit group, 8. Daegu, Dajo group, 9. Nilotic divided into a. Western Nilotic, Buran, Luo group and Dinkanur, b. Eastern Nilotic, I. Bari group, 2. Karamohong, Tizo, Turkana, Masai, c. Southern Nilotic, Nandi, Suk, Tatoga, 10. Nyanji Ya, Tiaso, Ik. Considerable controversy exists concerning the classification of 2 sub-groups of Nilotic, namely Eastern and Southern. Meinhof in classifying Masai as Hamitic evidently intended to include other languages of these 2 groups in spite of their close resemblance to the languages classified here as Western Nilotic, for example, Shilluk, Luo, Dinka. His separation of such otherwise similar languages as, for example, Shilluk and Masai was carried out primarily because of the possession of sex gender by the latter. Westermann attempted a compromise position, calling the languages of the Eastern and Southern Nilotes Nilo-Hamitic, presumably on the assumption that they are mixed languages. He reserved the term Nilotic for Western Nilotic. Tucker at first adopted a view of the sort but later moved these languages closer to Nilotic, calling them Paranilotic. 41 other divergent views in the recent period have been those of Hohenberger, who compared Masai to Semitic, and Huntingford, who apparently sought to revive the earlier views of Meinhof that these languages are Hamitic. 42. The other extensive subgroup of Shari Nile is Central Sudanic. It may be divided into 6 subgroups as follows: 1. Bongo Bajirmai, 2. Krish, 3. Moramedi, 4. Mangbatu, 5. Mangbutu F, 6. Lendu. The Khoisan family. All of the Khoisan languages have click sounds and the majority of their speakers belong to the physically distinctive San type. The bulk of the Khoisan languages are spoken in southern Africa. However, there are 2 small populations much farther north in Tanzania. the Hadza and Sanda, with languages differing considerably both from each other and from those of South Africa. Accordingly, the family is divided into 3 branches: 1. Hadza, 2. Sanda, 3. South African Khoisan. South African Khoisan consists of 3 groups of languages: 1. Northern, containing the Northern San languages of the Oan and Kung; 2. Central Khoisan, divided into 2 groups: A. Hiquare, B. Naran, Khoikhoi; 3. Southern San, the internally most differentiated group with a considerable number of individual San languages. 43. As was noted in the section of this chapter dealing with the history of classification, a number of linguists, Bleek, Lepsius, and later Meinhof, separated Khoikhoi from San and assigned it to Hamitic, a modified form of this theory is espoused at the present time by E. O. J. Westphal. 44. He divides Khoisan as described here into 2 independent families. One is Sanda Khoikhoi, consisting of Sanda and the Central Khoisan languages. All these languages except Hiquare have sex gender. Nothing is asserted concerning a possible connection with Hamido-Semitic. Westphal's other group, Hadza San, consists of Hadza and the Northern and Southern San languages. However, he considers the connection between Hadza and the San languages not to be completely established. The Merina language, which has come to dominate the languages of African origin spoken in some regions of the island of Madagascar, is not included in the foregoing classification. Its status as an Austronesian, Malayo-Polynesian, language has never been disputed. Its closest relative within Austronesian is probably the Monyan language of Borneo. 45. Another language not mentioned in the classification is Meroitic. 46. An extinct language written in an alphabet which takes 2 forms, hieroglyphic and cursive. It became extinct about the 4th century of our era and is known only from archaeological remains covering approximately an area from Aswan in southern Egypt to Khartoum in Sudan. While the phonetic values of the letters are known, because of the absence of bilingual inscriptions, our knowledge of lexicon and grammar is limited and uncertain. The earliest theory was that it was Nubian, Griffith. A Hamitic hypothesis, Meinhof, Zillarts, was refuted in an important article by Hintze. More recently, the Nubian hypothesis has been revived in a broadened form by Trigger, who suggests that it belongs to the Eastern Sudanic sub-branch of Nilo-Saharan, to which Nubian also was assigned in the Greenberg classification. 47. Finally, mention should be made of European and Indian languages of recent importation, which in some cases are now spoken by populations born in Africa. English, besides being spoken in South Africa and Zimbabwe, is the language of the descendants of the American blacks who founded Liberia, and is also spoken in creolized form, Crio, in Freetown, Sierra Leone. Afrikaans, closely related to Dutch, is spoken in South Africa. There is a substantial French, Spanish and Italian population in North Africa. A creolized form of Portuguese is the first language of some thousands of speakers in Guinea and elsewhere. Finally, some languages native to India are spoken in East Africa. These include both Aryan and Dravidian languages, most importantly Gujarati. Appendix to Chapter 12. The Language Map of Africa. D. Dalby. Africa, although less densely populated than the world as a whole, one has a greater degree of linguistic complexity than any other continent. 2. As a result, there has until now been no detailed charting of the continental language map of Africa, even though it is a map so badly needed by Historians and others. The Soviet ethnodemographic map of Africa is probably the best substitute to date. 3. Although it suffers from the blurring of linguistic and ethnic distinctions, from the overloading of the map with demographic as well as ethno-linguistic data, and from the rendering of all African names in the Cyrillic alphabet. Other continental maps, of ethnic groups rather than of languages, are in general too grossly oversimplified to be of much scientific value. 4. Some degree of oversimplification is of course inevitable in any attempt to arrive at a continental view of language distribution and relationships in Africa. The only truly accurate map would need to represent every person on the continent with a separate illuminated spot, which would move as the person moved and which would light up in any of up to 2,000 different colors according to the language that person was speaking at the moment. Since such a map is a physical impossibility, we must satisfy ourselves with something less perfect, although hopefully more detailed and accurate than the documents previously available. For the last 10 years, work has been proceeding on a specifically linguistic map of Africa, as opposed to ethnic. And the present article draws attention to aspects of this work which are relevant to the history of Africa. 5. Despite its technical appearance, the comparative study of African languages has often been oversimplistic. There has been a tendency to assume that the complex language map of today has evolved from a much simpler language map in the past, and that linguistic relationships can be expressed in terms of family trees, with a descending hierarchy of levels, families, subfamilies, branches, and so on. A belief that the many hundreds of modern languages in Africa may be traced back in regular order to a handful of proto-languages has led comparative linguistics to examine the possible ultimate and most distant relationships of African languages before establishing on a sound basis their immediate relationships. It has led them to concentrate on the historical process of divergence among languages, with an assumed common origin, to the exclusion of the process of convergence among related languages or of reconvergence among related languages. The ill effects of this approach have been compounded by the fact that the pseudo-historical classifications arrived at by these means have been used also as frameworks of reference, not only for African languages, but even for African peoples, and have consequently exercised an undue influence on historical thinking about Africa. A major priority must therefore be the unscrambling of the linguistic jigsaw of the African language map, reducing it to its immediate components, that is, language groups with a close, overall relationship and with external as well as internal unity. 6 equals complex units, or individual languages which cannot be included within any such group simple units. Such treatment reveals an important characteristic of the language map which has been obscured by previous classifications, namely, the fact that from a total of around 120 complex and simple units in Africa as a whole, over 100 are confined entirely to a single belt extending across Africa, from the coast of Senegal in the west to the Ethiopian and East Africa highlands in the east. 7 expressed in terms of individual languages. 8. Approximately 2/3 of the total for the continent are spoken within this belt, some 5,600 kilometers in length but only 1,100 kilometers in average width. The belt runs immediately to the south of and parallel to the Saharan desert, and, in terms of its location and linguistic complexity, may be usefully termed the sub-Saharan fragmentation belt. Its limits may be determined by reference to physical as well as linguistic geography, being roughly coterminous with the desert fringe in the north, the highland ranges in the east, the forest fringe in the south and the Atlantic coast in the west. Areas of maximal fragmentation, in spatial terms, are located along the northeastern, central, and western margins of the fragmentation belt, at the southern tip of its East African salient, and in a block covering a large part of West Africa. In terms of overall structural and lexical relationships, the most fragmented area is probably in and around the tip of the East African salient, where representatives of all four of Greenberg's postulated African families are spoken within a radius of only 40 kilometers. In this case, and in the case of the Togo Hills, Jos Plateau, Cameroon Highlands, Nabu Hills, and Western Ethiopian Highlands, there appears to be some correlation between mountainous country and intense linguistic fragmentation. 9. It should also be observed that the internal relationship of certain complex units, represented by languages outside as well as by languages within the fragmentation belt, becomes increasingly blurred at the points where they enter the fragmentation belt. Degree. The linguistic and historical importance of defragmentation belt has been obscured by the superimposition of a network of language families and subfamilies, postulated by European and American linguists. Among these, the two most extensive families can be singled out as having more substance and undisputed validity than the two other major families of Greenberg's classification, or even than several of the subfamilies into which they have themselves been traditionally divided. Since the term family implies a more human or biological sequence of descent than is appropriate to the phenomenon of language, the term area of wider affinity may be suggested as a suitable label for each of these two families, especially as they each cover a more or less contiguous area within the African continent. First of these, the northern area of wider affinity, has been traditionally known as Hamido-Semitic and more recently as Afro-Asiatic, Greenberg, or Erithraic, Tucker. Second or southern area of wider affinity, has been known recently under the labels Niger-Congo and Congo-Kordofanian, Greenberg, or Nigritic, Murdoch. 11. There has been no dispute about the overall validity of these two areas of wider affinity, which have been apparent to European linguists since the 17th century 12 and presumably to African observers for very much longer. The relative importance of these two areas of wider affinity is expressed by the fact that they include between them over 80% of the languages spoken in Africa, the southern area of wider affinity itself, including approximately 66% of the individual languages of the continent. In the conservative classification employed for the current language map, the languages of the northern area of wider affinity are treated within a total of 17 complex and simple units, 12 being confined entirely to the fragmentation belt, and the languages of the southern area of wider affinity within a total of 58 complex and simple units, 57 of these being confined entirely to the fragmentation belt. 13. There is an important reason for not establishing intermediate levels of relationship between the ultimate areas of wider affinity at the continental level, and the immediate complex or simple units at the relatively local level. This is the fact that such intermediate levels of linguistic relationship are, for an as yet indeterminate reason, less obvious and difficult to define than the ultimate and immediate levels. Thus it is that the unity of West Atlantic or KWA or GER or Banya-Congo, within the southern area of wider affinity, or the unity of Cushitic or Chadic, within the northern area, has never yet been adequately demonstrated. Although attention was drawn some years ago to this major area of weakness in the traditional European and American classification of African languages, these Intermediate levels of classification continue to figure importantly in the literature. The imposition and maintenance of these arbitrary divisions on the language map of Africa may in some ways be compared to the history of arbitrary colonial divisions on the political map of the continent. Greenberg performed a service to African linguistics in drawing attention to the arbitrary use of the term Hamitic as an intermediate level of classification, 15, but was unfortunately responsible for perpetuating the arbitrary use of many other intermediate levels of classification. Doubts by linguists about several of these have already been referred to, 16 but more. Recently Professor Stewart has published an even clearer rebuttal of Benue Congo, the largest of Greenberg's supposed subfamilies. One important result of all this recent work on the Benue Congo languages was to raise serious doubts about the validity of Benue Congo as a genetic unit. At first it had been taken for granted that Greenberg was correct in his claim that many COMMON innovations could be cited as evidence, even though in fact he cited only one, the word for child. Williamson reports, however, that when regular sound correspondences are taken into consideration, this item turns out not to be confined to the Benue Congo languages and therefore not to be valid evidence. She further reports that in the whole of Volume I of the Benue Congo comparative word list there is not one item which is valid evidence. 17. When Stewart points out the long-standing doubts which had already existed regarding the external unity of Benue Congo. One cannot but wonder why comparative linguists have been so reluctant to abandon its use as part of their classificational framework. Tragically, the whole object lesson of Benue Congo appears to have been lost, and, rather than abandon this and other unproven levels of intermediate classification, Stewart prefers to perpetuate Greenberg's scheme by amalgamating Benue Congo with Kwa and Gur, two equally arbitrary concepts, to form yet another arbitrary subdivision of Niger Congo, 18, now known as Volta Congo. We shall no doubt have to wait for the outcome of more comparative linguistic work before Stewart's Volta Congo is further enlarged to include the whole of Niger Congo or the northern area of wider affinity, the one ultimate level of external and internal unity which is clear and undisputed. Historians should note that the broad acceptance of Greenberg's standard classification rests largely, in respect of Niger Congo, on his own acceptance of Westermann's Gruppen or subfamilies of West African languages. As has already been pointed out, Westermann did not establish the external unity of his Gruppen, 19, while their clear internal unity demonstrates only that their constituent languages belong to the northern area of wider affinity. Although current classifications of African languages deserve to be treated by historians with reservation, one cannot overemphasize the importance of the language map of Africa as a source of information on the prehistory of the continent. More detailed work remains to be undertaken, and one awaits a new generation of historical linguists who are themselves speakers of African languages. They will be in a position to reinforce the essential groundwork of a close and detailed comparison of neighboring and closely related languages. From this stage, it will then be possible to move back to the wider strategic interpretation of the African language map as a whole. Despite its greater degree of linguistic complexity than any other continent, Africa is notable for the fact that 2/3 of its languages belong to a single area of wider affinity, and that a differently composed 2/3 should be confined to the sub-Saharan fragmentation belt. Bantu-speaking Africa is the one region of the continent which has already seen an intensive debate on the prehistorical interpretation of linguistic data. The key to the prehistorical interpretation of such data on a Continental scale, however, will be our better understanding of linguistic relationships within the fragmentation belt, although the scale of the task can scarcely be overestimated. 315. Historical geography. Physical aspects. S. Daira. Introduction. It is, of course, hard to separate African history from its geographical setting. But it would be fruitless to rely on determinist concepts in order to establish the full complexity of the relationships that have been established between African societies and their respective environments. Each community has reacted in its own way to its surroundings. The attempts made, with varying degrees of success, to order the environment bear witness to the degree to which men are organized and to the efficacy of their techniques for making the best of local resources. But for a changing Africa, it is important to look at certain geographical peculiarities which can throw light on the major events of the continent's long geographical and political history. Here the architectural features of Africa as a whole, its extraordinary climatic zonality and the originality of its natural environments have been the inheritances impeding or promoting human activity, while in no way determining its development. In a word, there is nothing simple about the intimate relationships between African nature and the men that live in it, exploit, develop and transform it in accordance with their political structures, technical possibilities, and economic interests. Architectural features of the African continent. It is generally agreed that Africa belongs to a very ancient continent which, before breaking up and slowly drifting apart, included America, Southern Asia and Australia. This continent, Gondwana, is said to have been the result of the earliest orogenic efforts of the Earth's crust, which threw up powerful mountain ranges, generally running southwest/northeast. These plications, greatly eroded by long denudation, were reduced to peneplains, of which the largest are to be found in Africa. Geological originality of Africa. Africa's originality can be seen first of all in the exceptional size of the Pre-Cambrian insular shelf occupying most of its surface. This shelf consists of very ancient and very rigid crystalline, granite, and metamorphic rocks. Shale, quartzite, gneiss, either in the form of outcrops, which cover a third of the continent, or else covered by a layer of sediment and volcanic material of varying thickness. With the exception of the alpine system of the Maghreb and the Hercynian folds of the Cape and the southern Atlas, Africa and Madagascar form an ancient stable platform consisting of a shield which has undergone no appreciable plication since the Precambrian era. Over the shelf, leveled by long erosion, sedimentary formations have been unevenly disposed in subhorizontal layers, varying in age from early primary to quaternary. These sedimentary series, made up of rough, generally sandy material, are more continental than marine, for the sea covered the insular shelf only temporarily and partially. In West Africa the primary sandstones form an aureola within the outcrops of the Pre-Cambrian platform. In southern Africa large continental Permo-Triassic deposits make up the Karoo system, in which the sandstone series are sometimes 7,000 meters thick. In the northern part of the continent, notably in the eastern Sahara and in Nubia, the Jurassic and Cretaceous sandstones are intercalary continental. But in the secondary period, marine series accumulated from the Jurassic to the Eocene in the coastal regions and the basins of the interior. They can be seen in the Gulfs of Senegal, Mauritania, Benin, Gabon, and Angola, the Chad Basin and the coastal plains of East Africa, from Somalia to Mozambique. From the Eocene onwards, terminal continental fluviatile and wind deposits accumulated in the great interior. Basins of Africa. All these series of layers, lying on the rigid shelf, were affected not by plications but by widely sweeping distortions which took place from the primary up to a recent era. Regional upwarpings and large scale subsidences explain the fold and basin structure so characteristic of Africa. In the Tertiary period, with the paroxysm of the alpine orogenesis, more violent vertical movements caused great fractures in East Africa. These form long submeridian rifts framed by faults, the rift valleys. Sometimes they were coupled with volcanic outflows which provided the most prominent reliefs, such as Mount Kilimanjaro with its glacier, culminating at 6,000 meters. To the west, the fractures were smaller, but there was intense volcanic activity in the one at the bottom of the Gulf of Guinea, which resulted in the imposing Mount Cameroon, 4,070 meters. Paleoclimatic influences. Following the orogenetic movements, the African continent was affected by long phases of erosion which were apparently fairly slow in all the geological eras. The phases of stabilization were accompanied by resumed erosion, which resulted in the formation of vast flattened surfaces. In this process of evolution, the most important factor was climatic variation, and the most remarkable of such variations took place in the Quaternary. Alternating. 318. Historical geography, physical aspects. Humid and semi-arid climates resulted in phases during which rocks were weathered and erosion in linear or sheet form took place. The low-lying areas were filled in and hard rocks made to project, often forming isolated reliefs emerging abruptly from the flattened surfaces. There are a great many of these inselbergs in the regions south of the Sahara. In the Quaternary, climatic changes and variations in sea levels were coupled with considerable adjustments to the pattern produced by successive cycles of denudation and accumulation during previous periods. Paleoclimates are responsible for the Sahara, whose numerous stone artifacts and equatorial-type fossil fauna prove that in ancient times it had a humid climate favorable to human settlement. But during the Quaternary, increased or diminished rains resulted in an extension of the existing climatic zones either north or south. Thus pluvial periods considerably increased the proportion of the total surface of the continent suitable for human life. Arid periods, on the other hand, brought about an extension of desert regions beyond their existing limits and made the Sahara a climatic hiatus between the Mediterranean and tropical worlds. Nevertheless, the Sahara, which covers nearly a third of the continent, extending over some 15 degrees of latitude, has never been an absolute barrier between north and south. Inhabited by nomads, it has been crossed by caravan routes for centuries. It has not prevented communication between tropical Africa and the Mediterranean from ancient times to our own, but it has acted as a filter limiting the penetration of Mediterranean influences, especially in agriculture, architecture and crafts. So the widest desert in the world has played a vital role in geographic ally isolating a large part of Africa. Massiveness of the African continent. The vigor and definition of Africa's physical features distinguish it from all the other continents. Africa's massiveness and heavy relief are the result of a long geological history. A glance at the map shows that Africa, with its 30 million square kilometers, stretches over nearly 72 degrees of latitude, from Ras Ben Saka, 37°2 in, near Bizerta, to Cape Agulhas, 34°5 is. There are some 8,000 kilometers between these two extremities of the continent. Laterally there are 5,700 kilometers between Cape Verde and Cape Gardefeuille. The greater part of the continent, some 2/3, lies above the equator, the continent dwindles in the southern hemisphere. Africa's massive nature is underlined by its lack of the deep coastal indentations present in Europe and Central America, for instance. Moreover, islands are not a significant part of the continent, whose sculpted form is vigorously enhanced by its simple outline and weakly developed continental platform. Any lowering of the sea level would have little effect on Africa's shape, since the 1,000-meter bathymetrical contour is generally close to the coast. The continent seems even more massive because of the heavy relief, often in the form of plateaus, the edges of which rise to form coastal folds, which 319 river complexes cross with difficulty. Despite its few plicated ranges, Africa has a remarkable average altitude of 660 meters because of the orogenic pressures which in the Pliocene were characterized by vigorous fractures and upthrusts in the shelf. Beneath an apparently simple relief, however, there are considerable regional differences. The Maghreb, for instance, has a marked individuality, being related to Europe through its mountain ranges and partitioned relief. It has two major mountain areas, the Tell and Northern Rif ranges, and the Southern Atlas. These ranges form long east-west bands between Mediterranean and Sahara. There is another family of reliefs in the enormous region of Northeast Africa, West Africa, and the Zaire Basin. Here the predominant features are plains, basins, and low plateaus surrounded by mountainous folds. The largest basins in this area, the heart of the continent, are the Niger, Chad, Zaire and Bahr el Ghazal basins. Eastern and southern Africa are the continent's highland regions, with altitudes exceeding 1,500 meters in many places. The southern highlands are bounded by a marginal fold, the Great Escarpment, dominating the coast, with the rocky wall 3,000 meters high in places. But the originality of East Africa lies in its powerful reliefs caused by tertiary tectonic movements. The shelf was violently raised and deep cuts were made by faults and fractures. At the same time it was affected by a violent volcanic movement. The summit of the Abyssinian Massif, consisting of a great upwarping surmounted by over 2,000 meters of lava, rises to more than 4,000 meters. Rift valleys stretch over 4,000 kilometers from the Red Sea to Mozambique. The rift valleys, which have played a remarkable role in the movement and settlement of peoples, contain a series of lakes, including lakes Nyasa, Tanganyika, Kivu, Edward, Mabutu, former Albert, Victoria, and Turkana, Rudolph, and are bordered by gigantic volcanic mountains, the most famous of which are Mounts Kenya and Kilimanjaro. Geographical isolation. Because of its massiveness and heavy relief, Africa has been isolated until recent times. Apart from North Africa, which looks towards the Mediterranean world, the rest of the continent remained for centuries outside the major flows of trade. True, this isolation was never absolute, but it had a great deal of influence on many societies which developed in geographical isolation. Detached from the Old World when the continents drifted apart, Africa nevertheless has one point of contact with Asia in the Suez Isthmus, which was the corridor for great prehistoric migrations. The greater part of the African coastline borders two oceans which until modern times were not used to an equal degree. The Atlantic was not used before the 15th century when the great seafaring explorations began from Europe. Before that time, the techniques of navigation under sail did not allow Arab seamen, for instance, to travel beyond the Sahara coasts. 320. Historical geography, physical aspects. Their ships could not sail into the trade winds which blew southwards all the time. The Indian Ocean, however, had long helped to promote contacts between East Africa and Southern Asia. Arab and Indian sailing ships were able to sail to Africa and return to their home ports, aided by the alternating monsoon winds of the Indian Ocean. The intensive relationships established between East Africa and the world of the Indian Ocean were restricted to the coast, for the seafaring peoples of Asia wished to trade rather than to colonize the interior. The influence of the maritime civilizations of other continents did not penetrate very far into the interior of tropical Africa, most of which remained outside the Old World. Traditionally, the inhospitable character of Africa's coasts has been put forward as the reason for its isolation. The lack of indentation means that there are few harbors along the coastline, which is low-lying and sandy. Rocky coasts are few and far between in West Africa, but there are more of them in the Maghreb, in Egypt along the Red Sea, and at the southern tip of South Africa. In West Africa, the coasts from southern Senegal to Guinea and the Cameroon and Gabon coasts are characterized by rias. These are vast estuaries resulting from the submersion of ancient fluvial valleys, but most are silted up. Some of the low-lying coasts, swept by tides, have mangrove swamps, especially in the region of the Rivières du Sud reaching to Sierra Leone, in the delta of the Niger and along the coast of Gabon. Elsewhere, offshore bars border the continent, in places isolating lagoons, like those in the Gulf of Guinea. Finally, there are coral reefs along the Red Sea, the Mozambique Channel and the coast of Madagascar. The inhospitable nature of the African coast has been largely attributed to the heavy surf, breaking in powerful, regular waves, which made it hard to land in some coastal regions. But coastal inhospitability has been exaggerated. The Mediterranean coast did not prevent centuries-long trading between North Africa and the interior. The lack of natural harbors is also put forward in explanation of tropical Africa's isolation until recent times. But one need only list the sites attractive to sailors for navigation to CHOW. Rich Africa is in this respect, both on the Atlantic and on the Indian Ocean coasts. In any case, these have never been insurmountable obstacles. For Asian and, later, European influences have left a strong impression on the peoples of Africa. Their isolation was only relative. Human factors doubtless explain better why the African coastal peoples have taken so little interest in major seafaring ventures. Climatic zonality of Africa. Living conditions in Africa depend in the main on climatic factors. The symmetry and great size of the continent on either side of the equator, its massiveness and relatively uniform relief combine to give the climate a zonality unparalleled elsewhere in the world. Africa is highly unusual in its successive climatic bands parallel to the equator in both hemispheres. 321. African rainfall conditions gradually worsen towards the higher latitudes. Because Africa is widest in the intertropical zone, it is the most uniformly hot of all countries. This heat is coupled with increasingly dry conditions towards the tropics, or with a generally higher degree of humidity in the lower latitudes. Cosmic factors. In this eminently intertropical continent, climatic differences depend much more on rainfall than on temperature, which in any case is high all the year round in most regions. Rainfall and heat are in any case primarily connected with cosmic factors, namely, the latitude and the apparent movement of the Sun. The Sun reaches the zenith twice a year in all intertropical regions, but reaches the tropics of Cancer and Capricorn only once, on June 21, the date of the summer solstice, and December 21st, the date of the winter solstice in the northern hemisphere. It reaches the zenith twice a year at the equator, at the spring equinox, March 21st, and the autumn equinox, September 21st. The sun in its apparent movement never goes very low on the horizon. This is why temperatures are high all the year round in the intertropical zone. In the regions near the equator, where the sun's apparent position oscillates round the zenith, there is no hot season, for there are few seasonal variations in temperature. There are some 3 to 4 degrees of difference every year. But as we near the northern and southern tropics, there is an increasing contrast in temperature. In the Sahara there are wide variations, some 15 degrees, between the average January and July temperatures. The northern and southern tips of the continent, which belong to the temperate zones, have contrasting thermal regimes, with wide annual variations resulting from the contrast between cold winters and hot summers. Moreover, daily variations can be as high in the Mediterranean region as in the intertropical zone. Cosmic factors determine two major types of thermal regime, regular in the equatorial latitudes and increasingly varied closer to the tropics. Rainfall mechanism. The reason for the seasonal variations in the African climate is the existence of major centers of atmospheric activity which set in motion air masses of tropical or equatorial, maritime, or continental types. There are permanent tropical anticyclones, or high-pressure centers over the Atlantic, one in the northern hemisphere, Azores anticyclone, the other in the southern hemisphere, St. Helena anticyclone. There are two further anticyclone cells, one over the Sahara, the other over the Kalahari. These continental anticyclones are seasonal and play an important part only in the northern and southern winters. In summer they are weaker and are flung back to the tips of the continent. Another major atmospheric activity is the low pressure zone centered on the thermal equator, oscillating from latitude 5 degrees south in January. 322. Historical geography, physical aspects. To latitude and degree N in July. Surface winds flow out from the anticyclones towards the equatorial low pressure zone, the trade winds which sweep the intertropical area. The Azores anticyclone sends out fresh, stable winds. The northeast Atlantic trade winds, affecting only a narrow fringe of the Sahara coast as far as Cape Verde. The high anticyclone over the Sahara is the source of steady northeasterly continental winds which are dry and relatively cool, but warm up as they move further south. The easterly harmattan, burning and dry, blows with great regularity over the whole of the Sahel from Chad to Senegal. It is accompanied by sand or dust storms bringing dry mists. In the southern hemisphere during the winter, there are also relatively dry hot winds in some parts of the Zaire basin. But above all in the southern winter, corresponding to the northern summer, low continental pressures centered south of the Sahara attract maritime trade winds from the St. Helena anticyclone which bear north east after crossing the equator. This is the Guinean monsoon, which thrusts beneath the harmattan, flinging it northwards and upwards. At the point where these air masses of different direction, temperature, and humidity meet, there is a zone of intertropical convergence, or an intertropical front, which gives rise to the rainy seasons. During the northern summer, May-September, the intertropical front, running east-west, moves from latitude I0 degree to 20 degrees north, thus allowing the southerly trade winds to bring humid air masses towards the Guinea coast, thus beginning the rainy season. In winter, the convergence zone occurs in the Gulf of Guinea, touching the coast in Cameroon and cutting across the southern half of the continent to the Mozambique Channel and northwest Madagascar. North of the equator, West Africa is dominated by dry continental winds. South of the equator, the convergence of the southern continental trade winds with air masses from the maritime trade winds coming from the northern Indian Ocean brings rain. The general mechanism of the climate may be modified by geographical factors such as marine currents, relief, and coastal orientation. The constant cold currents on the Atlantic side of Africa are symmetrical on either side of the equator. In the north, the Canaries current, set in motion by winds from the Azores anticyclone, follows the coasts from Gibraltar to Dakar, bringing lowered temperatures and fog. Around latitude 15°, the Canaries current turns west. Its counterpart in the southern hemisphere is the Bengala current, set in motion by winds from the St. Helena anticyclone. This brings low temperatures and dense mists all along the coasts of southwestern Africa, before it turns west at the level of Cape Frio. This is the reason for the coastal deserts of Mauritania and Namibia. Between the two cold Atlantic coastal currents of the Atlantic facade is the equatorial Guinea countercurrent, which displaces warm water masses from west to east, increasing atmospheric humidity and instability and hence the possibility of rain along the coast from Conakry to Libreville. The circulation of marine currents on the Indian Ocean side takes a 323 different form. The equatorial waters pushed towards the continent by southeasterly winds from the anticyclone centered east of Madagascar form the warm Mozambique current flowing southwards and continuing further as the Agulhas current. This brings humidity to the southeast coast of Africa. North of the equator, the marine currents reverse with the change in wind direction. In summer, for instance, a hot northeasterly current flows along the Somali coast, in winter a cold current flows from Arabia towards the equator. The relief of Africa, despite its relative uniformity, has an influence on the climate, for it acts like a draft excluder, a veritable screen impeding access by the humid maritime air masses to the central basins, interior plateaus and rift valleys where varying degrees of aridity prevail. The lie of the coast in relation to the direction of the rain-bearing winds also affects the climate. Sectors directly exposed to the southwesterly monsoon, especially when they are mountainous, have the highest rainfall in West Africa, nearly 5,000 mm in the Republic of Guinea. In southern Africa and Madagascar, the coasts perpendicular to the direction of the maritime trade winds receive heavy rainfall. But coastal sectors parallel to the direction of the winds and without notable relief, such as those between Cotonou and Accra and in Somalia, receive less rain. In Africa, seasonal climatic patterns are in the main determined by the amount of rainfall. The amount of rainfall decreases gradually from the equator to the tropics, and the Sahara and Kalahari deserts have less than 250 mm of rainfall a year. Decreasing precipitation totals are coupled with increasingly marked contrasts in seasonal rainfall patterns as we go north. In the regions near the equator with permanently low atmospheric pressure, rain falls all the year round, but there is considerably less at the solstices. Further north and south, rainfall is concentrated in a single period, corresponding to summer in either hemisphere. A rainy season is thus contrasted with a dry season which becomes increasingly long as we approach the tropics. But the two tips of the continent, the Maghreb and the Cape Province, are unique in that they have winter rains. These regions have a middling rainfall irregularly distributed over the land. Climatic zones. The variations in total annual rainfall and seasonal distribution of rainfall. Divide Africa into major climatic zones. 1. Equatorial climates characterize the central regions on either side of the equator, which see two equinoctial passages of the intertropical front, bringing heavy rains. From southern Cameroon to the Zaire Basin there is abundant rainfall all the year round. The air is saturated with water vapor all the year round. The annual total rainfall generally exceeds 2,000 mm. In this humid atmosphere there is little monthly variation in temperature. The yearly average is 25 degrees Celsius. 324. Historical geography, physical aspects. To the east, in the equatorial regions under the climatic influence of the Indian Ocean, we find the same rainfall patterns, but with an annual total of less than 1,500 mm. The annual variations of temperature are more marked than on the Atlantic side of the equatorial zone. Diurnal temperatures are higher in the regions which, climatically speaking, belong to the Indian world. 2. Tropical climates are found in the wide areas influenced by the movements of the intertropical front north and south of the equatorial zone. Northwest Africa, between latitude 40 and the Tropic of Cancer, has a variety of climates, ranging from two equinoctial passages in the south to a single solstitial passage in the north. And the coast of the Gulf of Guinea, the climate is subequatorial or Guinean, without a dry season but with heavier rains when the sun reaches its zenith twice a year. The orographical effect of the coastal screen condenses the strong humidity borne by the south westerly monsoon. The coastal fringe from the Republic of Guinea to Liberia has over 2,000 mm of rainfall a year. The Sudan region further north displays several aspects of the intertropical climate. There is a humid variety and a dry variety associated with the proximity of the desert. At higher latitudes the two passages of the intertropical front are less and less distinguishable. This means that two seasons, wet and dry, alternate in the intertropical zone. Between the two extremes of the heavy equatorial rains and the aridity of the Tropic of Cancer, we find the following gradations. In the first subzone, with annual rainfalls between 1,500 and 2,000 mm. Rainfalls more than 6 months in the year. Annual temperature ranges are higher than those of the equatorial zone. The central subzone is drier, rainfalls only 3 to 6 months a year, totaling 600-1,500 mm. Here temperature ranges show a marked increase. The northern subzone, known as the Sahel in West Africa, has less than 600 mm of rain, falling in less than 3 months. Rainfall is increasingly irregular and there are wider variations in temperature. South of the equator there is a similar latitudinal distribution of tropical climatic variations. But the gradations are more marked because southern Africa is less massive and because of the height and size of the relief dominating the coastal plains bordering the Indian Ocean. The convergence of the equatorial maritime air from the northwest and the tropical maritime air from the east brings abundant rains to the coasts of Mozambique and eastern Madagascar. The Atlantic coast, however, is dry because of the cold Bengala current which is responsible for the Namib Desert. 3. Desert climates characterize the regions on either side of the tropics. Rainfall is less than 250 mm and highly irregular. The whole of the Sahara, the largest hot desert in the world, has less than 100 mm of rain a year. But there are gradations because of the oscillation of the Sahara anticyclone which between the solstices moves up to the Mediterranean or descends to low latitudes. In the former position it helps monsoon. 325. Infiltrations to penetrate, in the latter it brings polar air. These oscillations distinguish the northern Sahara, with its Mediterranean rains in the dry season, from the central Sahara, with practically no rain, and the southern Sahara, with tropical rains in the hot season. At the Tropic of Capricorn, the Kalahari Desert is more open than the Sahara to oceanic influences from the southwest, for here the continent is narrower and the influence of the anticyclonic cell on the climate is accordingly reduced. Thus there is greater humidity and less heat. 4. The originality of the Mediterranean climates in the Maghreb and at the southernmost tip of Africa lies in the fact that the winters are cool and rainy and the summers very hot and dry. The Mediterranean climate with temperate zone winds is characterized by the passage in winter of humidity bearing ocean cyclones. Sometimes there are invasions of polar air with intense cold, frost, and snow, notably in the mountain ranges of the Maghreb. The dryness and heat of the summer are caused by the winds blowing from the neighboring deserts, the Sahara in the northern hemisphere, the Kalahari in the southern hemisphere. African bioclimatic environments. In Africa, probably more than anywhere else, human life has been organized in natural contexts which are above all bioclimatic environments. Climate and relief combine to determine major regions, each of which has its own hydrological, soil and botanical characteristics. Outflow of continental waters. The climatic diversity is reflected in hydrography. But in Africa the flow of water to the oceans is far smaller than rainfall would suggest. More than half the continent's surface is composed of regions either with no drainage at all or only draining internally. Moreover, river systems find obstacles in their way. Their profiles consist of gently sloping stretches connected by abrupt rapids, falls and cataracts. Hence much of the water that they drain undergoes permanent infiltration and intensive evaporation through stagnation in the basins, rifts and depressions of the plateau. Organization of hydrological networks. Vast areas of the continent with little or no rainfall have no permanent water courses. But the dry Mediterranean area receives some violent rains which trickle into sheets of water and sometimes concentrate in wadis. These are finally emptied through water evaporation and infiltration. In regions with sufficient rainfall, in tropical or equatorial climates, the major rivers and their principal tributaries form organized networks which collect part of the water from the basins and empty it, often under difficult conditions. The basins in which most of Africa's river systems are formed have peripheral 326. Historical geography, physical aspects. Ridges which are not conducive to good drainage to the sea. The continental waters are evacuated through the coastal folds by deep narrow gorges, with frequent changes in gradient on the lower reaches of some of the major rivers. The Zaire has 32 rapids between Stanley Pool and the estuary. The Zambezi falls no meters at the Victoria Falls before plunging into the Kariba Gorge and passing over several basaltic cataracts. DOWN. Stream from Khartoum. The Nile passes through 6 rapids, the cataracts, before it reaches the Mediterranean. All the other large rivers, Niger, Senegal, Orange, Limpopo, have stepped profiles, notably in their lower reaches. It is easy to understand why it is so hard to navigate the rivers of Africa, which appear to be very poor channels of communication. Nevertheless, in the past they have encouraged fruitful contacts between different peoples of the continent. Between the major river systems there are jumbled networks of streams, pools and swamps, ill-organized and with no regular drainage to the outside. Sometimes these waters are stagnant or are the outcome of the seasonal Flooding of adjacent rivers, sometimes, on the other hand, they feed such rivers, which in the geological past developed in subsidence basins at the bottom of which lakes were formed and alluvium accumulated. Exterior drainage became possible as a result of tectonic movements, the hitherto enclosed lakes draining through rift valleys or faults. River captures, result from these tectonic movements or morphological change, have also doubtless contributed to the present shapes of the hydrological systems. But internal drainage can also be seen in the Chad and Okavango basins, occupied by shallow lakes and marshes which become impressively large when the seasonal streams make their contribution. There are, however, other subsidence basins with outlets to the ocean with a similar tendency towards internal drainage. These are the marshes of Messina or the inner Niger Delta, those of the Bahr el Ghazal in the Sudan and the Zaire Basin. African river regimes. All over Africa rainfall patterns regulate the hydrological regimes. Seasonal variations in the amount of water in the rivers depend on the annual rainfall. Water courses in the equatorial regions are regular, with abundant water all the year round. Nevertheless, they do have two high water periods, corresponding to the times of the equinoctial rains. In the tropical zone, a high water period corresponding to the rainy season. The summer solstice is followed by a period of sparse rains during the dry season. The regime is thus one of strong contrast. Moreover, there is a gap between the times when the rains fall and the waters rise, because the waters flow slowly down the slopes, which are mostly gentle. In the sub-arid regions, the wadis flow intermittently when rare but violent rains cause sudden spates which are, however, short-lived since the waters are lost downstream. In the Mediterranean zone, the violent downpours and the presence of mountains turn the rivers into torrents. 327. These rivers are highly irregular, in spate in winter and at a very low level in summer. Many water courses in this climatic zone are wadis with an intermittent flow. The great African rivers with networks extending over several climatic zones fall outside this simple general scheme of things. They are characterized by complex regimes, with seasonal variations in flow changing from one end of the river to the other. The major African rivers. There are a few great rivers, among the largest in the world, which drain vast basins, almost all of which are in the intertropical zone. Their regimes depend on the rainfall supply on the slopes of their basins. The Zaire is the most typical example of an equatorial river with two equinoctial maxima. The Zaire river system extends over nearly 4 million square kilometers between latitudes I2°S and O°N. Through the intermediary of the Kasai and the Lualaba, it crosses the southern regions, with maximum rain at the solstices. Its principal tributary in the northern hemisphere is supplied by rainfall at the northern solstice, and through much of its course it runs through regions with two equinoctial maxima. The combination of different intumescences gives Kinshasa a hydrological regime with two maxima, March and July. The Zaire is a full, regular river, whose annual average flow of 40,000 m3/s is exceeded only by that of the Amazon. The Nile, which, through its parent branch, the Kagera, rises in Rwanda and Burundi, receives equatorial waters which spread out into the swamps of the Bahr el Ghazal. After passing through Lake Victoria, it is reinforced by tropical affluents from the Ethiopian mountains. The Blue Nile and the Atbara, with their solstitial maximum regime, enable the Nile to cross a huge desert area before reaching the Mediterranean. Although with 6,700 kilometers, it is the longest river in Africa, the Nile is not very powerful. Its average annual flow is less than 3,000 m3/s. Nevertheless, from antiquity it has been one of the world's most useful rivers. The Niger, whose basin stretches from latitude 5 degrees north to latitude I6 degree N, has a more complex regime. It flows in a large, unusual loop. It rises in the mountain fringe of the Atlantic, flows towards the Sahara, then turns towards the Gulf of Guinea, into which it flows through a vast delta. Its upper and lower reaches cross southern regions with a humid tropical climate. The middle reach flows through an interior delta with a Sahelian climate, and with difficulty it curves inwards in the sub-desert region of Timbuktu before receiving an increasingly large volume of water. Downstream, the rainy season brings two simultaneous floods, one in the upper and one in the lower reach. But the former, visible as far as Nigeria, gradually declines because of evaporation and infiltration in the dry tropical zone. The second, which is visible from northwestern Nigeria onwards, continues downstream because of the local solstitial maximum rains. The 328. Historical geography, physical aspects. Niger receives and is swelled by the Benue, its major tributary, in its lower reaches. African soils. The geographical distribution of the soils follows a zoning influenced by climate. The various soil formations are in the main the result of the action of water and temperature on the local rocks. In the tropical regions, warm, abundant, acid rains wash the rocks, dissolving basic minerals and carrying them deep down. In the very humid, low latitudes, up to I0 degree N or S of the equator, the chemical decomposition of the rocks results in the formation of ferrolytic soils. These are generally of loose reddish clay, several meters thick. They come from transformation of the matrix into colloidal elements, including kaolin, hematite, and a proportion of silica, about 30% or of the whole. The ferrolytic soils are protected by the forest covering from erosion, and contain little organic matter or humus. In the Sudanese regions with a marked dry season there are tropical ferruginous soils, which are much shallower. These are rich in iron oxide, with a sandy surface and clay at lower levels. They are very unstable and are sensitive to water and wind erosion. Their structure deteriorates very rapidly on the surface when plant cover is lacking. These soils are frequently caked or plated in West Africa, where the process of gullying during the rainy season alternates with intense desiccation in the dry season, especially when the harmattan blows. In some regions to the north of the coastal fringe of the Gulf of Guinea, there are ancient denuded erosion surfaces, plated or with hard pan, called bourve. These are characterized by large accumulations of iron oxide and alumina, with hardening at shallow levels. But many of these ancient houses date from the Tertiary era. Their hardened surfaces broke through after the erosion of the loose upper levels. Everywhere such soils are of very limited value in farming. Similar soils are found in Madagascar on the Tompoket to the northwest of Tananarive. Further north in the northern hemisphere, brown structured soils, of great agricultural value, have formed in a climate with contrasting seasons under a herbaceous cover. Despite their sensitivity to gullying, they permitted the evolution of agrarian cultures associated with the great Sudanese empires of the pre-colonial era. South of the equator, in the countries watered by the Zambezi, lightly gullied soils resembling podzalich formations were constituted under cover of the dry forest. In the north and south, in the subarid regions near the Sahara and the Kalahari, there are brown steppe-like soils consisting of more or less fixed dune sands with clay sand formations in the depressions. Light and loose. They are good for farming, but to allow them to regenerate, long periods of bush or grass fallow are necessary. In the arid regions where mechanical forms of erosion are predominant, there are wide variations in temperature. 329. In which the rocks tend to break up and the violent action of the wind and the sparse rains cause sheet erosion. In these regions there are sterile sands, forming ergs, gravel, or regs covering vast expanses, with clay crusts in the plains. Apart from the oases, the deserts have no soil for farming. In the Mediterranean environments, the action of water and the contrasted seasons brings less chemical weathering to the rocks than in the humid tropical zone. The soils are like those of the dry tropics, with red, gray or chestnut-colored surfaces. They are generally rich in salts. Some, such as the steppe-like soils, are rich in calcium, thus heralding the temperate environments. Others, formed of calcium or gypsum crusts, are characteristic of the Mediterranean zones. Biogeographical areas. Climatic and soil factors account for the diversity of the mesological conditions in which the botanical landscapes are formed. Dense moist forests. The most imposing of the botanical landscapes is in the center of the continent, between latitude 5 degrees north and 5 degrees south. Here the characteristic vegetation is the high, dense, moist forest. This is divided into several layers, while creepers and epiphytes accentuate the obscurity caused by the superposition of evergreen leaves. There are, however, gradations, marshy thickets on wet clay soils, or the clearings which herald the change to drier conditions. The species found in the moist forest are so diverse and mixed that their exploitation is difficult. With constant heat and humidity, exuberant vegetation thrives and microorganisms, worms and insects abound. This environment is hostile to man. Despite its silence, it is inhabited by a wide variety of animals such as the hippopotamus, the elephant, the bush pig, and the leopard. But it is the tree-dwelling birds, reptiles, and mammals that can move easily and multiply despite morbidity factors such as the many parasites. Outside the equatorial zone, the great moist forest can exist on high land long exposed for much of the year to moisture-bearing winds, for example, on the eastern slopes of the high Madagascan plateau, savanna and open forests. The rainforest zone is bordered by the dry deciduous forest characteristic of regions with rainfall concentrated around the solstices. It is often open, with the trees only partly covering bush and plant undergrowth. WHEN. Overexploited by man, this landscape gives place to grassland characteristic of regions with a more marked dry season. Tropical savanna emerges as the low latitudes are left behind. This vegetation associated with areas with seasonal climates contains some elements of the more or less humid plants of the tropical climates. At the edge of the forest, in the woodland savanna, there are still large 330. Historical geography, physical aspects. Trees, but they are less frequent than bushes, and the grass cover becomes more important. Gallery forest, in strips of varying widths, borders the rivers. In the savanna parkland there are wooded spaces next to areas with less cover, which are populated mainly with tall grasses. There are grass land savannas devoid of trees, doubtless because of man's deforestation and the caking of the soil. Further away from the dense forest, the grassland savanna, composed of a continuous carpet of tall plants, gradually gives way to scrub savanna where the soil is often bare between patches of plant cover. Herbivorous wildlife finds favorable living conditions in the different kinds of savanna. Hunting is good and stock raising possible. Man finds it easy to farm in these lands, which are not hard to clear. Steppe lands. Steppe, consisting of grass tufts and prickly thorn bushes, notably acacia, is typical of regions with a long dry season. This open landscape is found in the northern parts of West and East Africa, and more sporadically in South Africa, in the Kalahari and southwestern Madagascar. Subdesert. Vegetation of poor steppe is found in regions with less than 200 mm rainfall. Mediterranean vegetation. At the tips of the African continent there are bushy or grassy steppes in the driest regions. But in the more humid zones, notably the mountain ranges of the Maghreb, there are dry forests of green oak, cork oak, pine and cedar. These trees have evergreen leaves dominating a bushy undergrowth. Conclusion. Africa is an old continent which, from very ancient times, has been occupied by a people that very early developed splendid cultures. Africa's geography, in its structural features as well as in its natural environment, displays vigorous characteristics inherited from a long geological past. Africa is more massive and continental than any other continent. Vast regions in the heart of the continent, more than 1,500 kilometers from the sea, long, remained outside the major circulatory flows, which explains the importance for human settlement, since prehistoric times, of great meridian troughs, like the Rift Valley of East Africa. This geographical isolation was strengthened near the tropics because of climatic variations in the Tertiary and Quaternary eras. For thousands of years the humid Sahara was one of the world's oldest centers of human settlement. Later, dry phases helped to form huge deserts such as the Sahara and the Kalahari. Exchanges of all kinds between the different cultures of the continent suffered but were not interrupted. Climate, then, is an essential factor for an understanding of Africa's past. Moreover, rainfall patterns and the bioclimatic environment have a real influence on the life of man today. African societies have in fact taken 331 advantage of the complementarity of climatic zones to establish between themselves long-standing and vigorous flows of trade. Finally, the history of Africa has been markedly influenced by its mineral wealth, one of its most powerful attractions for conquering peoples. The gold of Nubia and Kush was exploited by the dynasties of ancient Egypt. Later, the gold of tropical Africa, notably of the Sudanese region and Zimbabwe, became a source of prosperity for the societies of North Africa and the Near East, and the mainstay of the great African empires south of the Sahara. Iron was traded in ancient times between the forest and the tropical regions of Africa. The salt mines on the edge of the Sahara played an important role in relations between the black states of the Sudan and the Arabo-Berber peoples of North Africa. Recently, Africa's mineral wealth has been exploited on behalf of colonial powers. Today it is still mainly exported as raw material. Iron, manganese, leather, tin, cobalt, bauxite, diamonds, uranium, cobalt, E*CLUSSR, phosphates, 0 25 50 75 100%. Fig 14. Mineral resources of Africa, after Journals, /076. 332. Historical geography. Economic aspects. A.L. Mabaganye. According to Gilbert, the real function of historical geography is to reconstruct the regional geography of the past. One in a volume such as the present, such a definition would imply an attempt to present a regional geography of African prehistory with special emphasis on the economic aspects. Such an attempt clearly would involve a comprehensive review of both physical and human conditions in the distant past and is sure to overlap with many other chapters in the volume. In the circumstances, the emphasis in this chapter is to consider the natural resource base, especially in terms of how this was perceived and utilized in prehistoric Africa. Such a consideration, while emphasizing the broad spectrum of the continent's natural resources as known to us today, will seek to underline which of them were appreciated as such in the distant past, where they were found, how they were used and to what extent they aided or hindered man's control of large areas of the continent, minerals and the development of human technology. Perhaps the most significant of natural resources for the human mastery of his environments are minerals. Minerals are the material of which the world is made. In general, they are formed by processes which are extremely slow, and which may run into millions of years. In consequence, compared to the human occupancy of the Earth, which goes back barely 3 million years, the geological time scale is extremely long, covering well over 5,000 million years. Large parts of Africa are underlain by rocks, which are some of the oldest in the world. These ancient, crystalline rocks, which are referred to as base-ment complex rocks, cover at least a third of the continent. They are comprised largely of granites as well as highly metamorphosed rocks such as schists and gneisses. Some of these rocks are highly mineralized. Among the most important of such formations are those found in the copper belt of Shaba, Zaire, and Zambia, which extend for a distance of over 300 kilometers. Besides containing the largest deposits of copper in the world, this belt also has some of the most complex deposits of radium and cobalt. The Bushveld igneous complex in Transvaal, South Africa, an area of 95,000 square kilometers, as well as the Great Dyke that runs through Transvaal into Zimbabwe, a distance of 530 kilometers, forms another highly mineralized zone. The minerals here include platinum, chromite, and asbestos. The African diamond zone has no equal in the world and shows its greatest concentration in South Africa, although smaller deposits are found in Tanzania, Angola, and Zaire. Goldfields also exist in South Africa, Ghana, and Zaire, and tin is to be found in Zaire and Nigeria. There are also rich deposits of iron ore such as those in Sierra Leone, Liberia, and Guinea in West Africa. The ancient basement complex of Africa has also suffered frequent volcanic disruptions going back even to the Precambrian times. These disruptions have given rise both to granitic intrusions with which gold and tin are associated and to the intrusions of basic and ultrabasic rocks. They have also produced eruptive or effusive rocks, many of more recent age, which, apart from weathering down into good, fertile soils, have provided minerals and rocks such as the obsidian basalt in Kenya of real significance for the history of the continent. Over much of the remaining 2/3 of the continent are found old sedimentary rocks of pre-Cretaceous age. Because of their age, these rocks also contain notable mineral deposits. Along the northern rim of the continent, for instance, in an area extending from Morocco through Algeria to Tunisia is the great phosphate rock belt associated with which are iron deposits of considerable importance. Similarly, important iron ore deposits of sedimentary origin are found in the Karoo region of South Africa and in the Damaras systems of Namibia. Coal deposits are, by contrast, notable by their virtual absence in Africa except for a few isolated occurrences in the Highveld of South Africa and the Wonky Field of Zimbabwe. If to compensate for this deficiency, the younger sedimentary rocks of post-Cretaceous age in the Sahara and coastal areas of West Africa have been found to contain vast deposits of petroleum and natural gas. These sources of mineral wealth provided much of the economic underpinning for human organization and exploitation over a long period of history. It has been suggested, for instance, that the control of the trade in gold between West and North Africa across the desert was one of the major reasons for the rise and fall of empires and kingdoms in the western Sudan. During the medieval period, trade in gold and iron ore certainly attracted the Arabs to East Africa from the last millennium onward. Europeans, on the other hand, were initially distracted by the mineral wealth of Latin America, but in the last 100 years they have concentrated on Africa as a colonial reserve of mineral raw material to stoke their industrial growth. Yet in the prehistoric period, the minerals that were of fundamental importance for the gradual technological development of man were of more modest types and their distribution more diffused. The most important of these were those lithic or stone minerals which are homogeneous in structure, high rating in their quality of hardness and with good flaking properties. 2OF. These, the best are the volcanic glasses which are found, for instance, in the volcanic regions of East Africa, particularly around the Gregory Rift Valley, and which formed the basis of the Paleolithic Kenya-Capsian industry for the production of long blades and various microlithic tools. Other good quality material includes the chalcedonic forms of silica, flint, chert and jasper, silicious rocks such as quartzite, and the fine-grained silica indurated rocks such as silcrete, indurated shales, and tuffs. Chalcedony was used extensively in the Mesolithic Bambuta industry of Zimbabwe, whilst Eocene flint and chert were particularly important on the Tunisian plateau and in Egypt, where they are believed to have been imported. Quartzites are more widespread in Africa, especially as pebbles in river channels, and form the basis of the oldest Stone Age industries referred to as the Acheulean. In places such as in the middle reaches of the Orange River in South Africa, indurated shales were used for much the same purpose as quartzite. Of rather inferior lithic property are the fine-grained amphibole rocks, known as greenstone, basis, and intermediate igneous rocks like basalt, dolerite and diorite, all of which provide suitable material for the manufacture of axes and adzes. They are also useful for making weapons, such as throwing stones and stone arrowheads. Basalt is perhaps the most commonly used igneous rock for making stone vessels, although virtually all available rock types can be and were used. Other igneous rocks, granites, diorite and porphysite are also known to have been locally important. Softer rocks such as limestones were not unrepresented, and in Egypt even very soft rocks such as steatite and serpentine were used. Besides, all over Africa, clay provided the basis for a widely dispersed and highly diversified pottery industry from the Mesolithic period. The importance of minerals in the development of human technology in prehistoric times goes beyond the making of tools, weapons, and vessels. It certainly includes the construction of dwelling places, for which simple mud served as important plaster. Major public buildings or monumental masonry such as the pyramids in Egypt also required large amounts of hard granitic rocks or quartzite. Minerals provided the pigment for rock paintings, some of which, in the Sahara and in southern Africa, have been remarkably preserved until today. Such pigment was obtained from grinding various kinds of rock such as hematite, manganese, and kaolin and mixing the powder with some fatty or resinous medium. But without any doubt the mineral which had the greatest significance for development in the later part of the prehistoric period in Africa is iron ore. Although modern technology with its elaborate mechanization and huge economic investment requires the use of deposits of relatively high ore content which are very localized in their occurrence, the position was less restrictive in prehistoric times. Ferruginous laterite or ferricrete covers quite extensive areas in the grassland savannas of Africa and is typical of old upland plains over many kinds of rocks. SOME types are so rich that they formed the basis of the earliest iron-working activities on the continent. Once the technique was discovered in the continent, it spread quickly throughout it. This was in sharp contradiction from the situation with copper and tin, which were so localized in their distribution that, apart from a few prehistoric copper-using communities such as the plateau dwellers of northeastern Ethiopia and the Luba groups in the Shaba, they failed to provide Africa with a widespread bronze culture. It should be recalled, however, that a copper age flourished in Mauritania 5 centuries before our era. Vegetal resources and population growth. The vegetal resources of Africa had a very direct relationship with the capacity of the continent to support an ever-increasing density of population. As already pointed out, Africa is predominantly a grassland continent with grasses of various types occupying over 50% of its total area, followed by desert occupying some 30% and forest less than 20%. In terms of human occupancy, these varied environments have had significance related to their capacity to support game animals, provide edible fruits or roots, yield material which can be used to construct tools, clothing, and shelter, or furnish cultigens which can be domesticated into agricultural crops. The grassland zone was preeminently the rich game region of Africa, with its wide variety of antelope, gazelle, giraffe, zebra, lion, buffalo, hartebeest, elephant, rhinoceros, and hippopotamus, as well as numerous small game. It is thus no wonder that, as Clark noted, some of the earliest sites of human occupation are to be found along streams and river courses, round lakes, and on the seashore in country that is today grassland, woodland, savanna, Sahelian semi-desert, or desert proper. 3 such sites were generally absent from the forest zones, although with time, both the increase in man's number and the greater improvement of his hunting techniques encouraged him to occupy all kinds of country from the sea coasts to the high mountain plateaus and from what is now waterless desert well into the forest lands. It is, however, important to bear in mind that today's vegetal zones do not necessarily correspond with the situation during prehistoric times. A succession of periods of great climatic variation have marked the Sahara Desert, which was, during the early Quaternary, more humid, and carried savanna-type vegetation which supported animals such as the ox, the wild boar, warthog, antelope, and hippopotamus. By contrast, the equatorial forest is believed to have experienced more arid conditions at about the same period, contemporaneous with resources deriving from the wild game carrying capacity of different vegetal zones is the exploitation of these zones by man for edible fruits and roots. In this regard, the presence of gallery forests along river banks in grassland zones meant that Acheulean man had the advantage of fruits, seeds, and nuts of both forest and savanna environments. According to Clark, many of the wild savanna fruits, nuts, and plants available to the late Paleolithic Nakakufan population in northern Zambia, such as the fruits of the muabayu and musuku, are still regularly collected and eaten by the Bantu-speaking peoples today. 4WHEN. The population grew such that virtually all types of environments were occupied. The range of food gathered for human consumption must have widened considerably. It is believed, for instance, that it was the greater emphasis which came to be placed on cereal grasses by food gathering. Communities in the Nile Valley that anticipated the intentional planting of grain and ushered in the era of agricultural expansion which has had such decisive effect on the human occupancy of Africa. Apart from hunting and gathering, the vegetal resources were of tremendous importance in the provision of tools, clothing, and shelter. Wooden tools have been well preserved in the area around the Kalambo Falls at the southern end of Lake Tanganyika. Here were found several single and double-pointed wooden implements and short, obliquely truncated sticks that probably served as digging sticks, all of which date back to the early Paleolithic period. Although elsewhere such wooden tools have not survived, there are indications that they were widely used. In the equatorial forest, for instance, the Lupamban industrial complex of the Paleolithic period reflects the importance of woodworking in its bifacially trimmed core axe. Similarly, the presence of many heavy kinds of scrapers among the stone tools of the Nakakufan populations of the late Paleolithic period in the woodland savannas of Zambia and Malawi suggests extensive use of wood and its byproducts, no doubt for making game fences, game stakes and traps of various kinds. Where, as in the woodland regions, large game was not so numerous that their skins could provide clothing, the barks of trees were often used. It is probable that hafted edge-ground axes such as those found in the Mwila Rocks area of northern Zambia were used to strip and prepare bark for clothing, containers, and rope. Especially from the Mesolithic period onward, vegetal products began to be used in the construction of shelters in place of caves. Branches of trees, thatch, or matting were used, for instance, to construct the Mesolithic windbreak whose collapsed remains were found at Guisho Springs and which dated from the middle of the 3rd millennium before our era. By the Neolithic period and especially in those areas where agriculture had been discovered, shelters made of plant material or sometimes of plant and mud material were to increase in number and spread. They marked man's initial steps in putting unequivocally his cultural stamp on the landscape everywhere. But if the presence of such humble dwellings marked the beginnings of man's effective occupancy of the earth's surface, it was his ability to domesticate new plants out of the abundant wild species around him that ensured his eventual dominance. The conditions which enabled man to create new cultivable species, cultigens, from their wild varieties remain a matter of some controversy among scholars. Controversies also shroud the assessment of Africa's contribution to this great event. In the present state of knowledge, it is generally accepted that this has not been great, certainly nothing as impressive as the contribution of Asia. More recent researches, after the monumental work of Vavilov, the Russian botanist who did not consider that there was any important center of crop domestication in Africa outside the Ethiopian highlands, are starting to provide a more informed perspective on the native contribution of Africa to its stock of cultivated crops. 5. In this regard, there is no gainsaying that the savanna has been by far more important than the forest land. It was here that in the period between the 4th and the 2nd millennium before our era many of the cultivated varieties of the African indigenous crops were domesticated. Many of these cultigens were of the seed agriculture complex and were characterized by the sowing of grain as the preparation for cultivation. 6. By contrast, the few cases of domestication in the forest region belonged to the veg culture complex, involving the planting of cuttings, rhizomes, tubers or shoots as the preparation for cultivation. The most important crop domesticated in this region was the yam, Dioscorea species, various species of which are now cultivated. The other domesticated plant in this region is the oil palm, Elias guineensis. In spite of the limited number of domesticated crops, the discovery of cultivation implied a new productive relation between man and his biotope. In particular, it meant a certain receptiveness to innovations involving the diffusion of cultigens from other centers, and Africa has received a large number of such new crops, notably from Asia and South America. In terms of the natural vegetal resources, this declared preference for a limited number of plants both indigenous and foreign has meant not only that man derived sustenance from the natural environment, but also that he was now set on a path of major biotic modifications. The need to clear land for the new crops and to suppress other plants competing with them for soil nutrient has resulted in drastic changes to the character of vegetation everywhere in Africa. Perhaps the most potent agency used by man for this purpose has been fire. Evidence of the use of fire by man in Africa dates from the later part of the Lower Paleolithic and has led to the conclusion that as far back as 60,000 years ago man was regularly using fire in Africa. Initially, however, it would appear that he used it for protection, for tool making and perhaps for hunting animals through setting fire to the grass and driving them out. Once he had attained the knowledge of cultivation, it was only natural that he should use the same means to remove unwanted vegetation. This burning of vegetation for purposes of cultivation had different effects on grasses and trees. Grass, especially during the dry season in the savanna zone, burns down to ground level but is not destroyed because of its underground rootstocks. Trees, on the other hand, unless protected by thick bark, may be killed. Where they are not killed, they become twisted and gnarled. The implication of the introduction of fire to the natural environment has thus been that man in Africa over the ages has significantly molded the appearance of the landscape. As the frequent firing kills off the fire-tender tree species of the humid forest, conditions are created which favor the gradual extension of grassland. In West Africa, for instance, this process has been so vigorous as to create an extensive zone of derived savanna which is found locally as far south as 6 degrees north latitude. 7 within the savanna itself. It is notable that under the impact of the annual fires the vegetation alters in character with minor features of the landscape, changing from grassland on the open plains to a more woody cover over rocky sites. Indeed, the survival of such woody groves on rocky sites has led to the suggestion that the climax vegetation over a large part of present-day grassland must have been forest. 8. Whatever the situation, the grassland regions of Africa proved of greater resource value to early man since not only were they easier to clear for cultivation but they were also easier to traverse. This factor of easy traverse ability was decisive in the peopling of the continent. Africa is par excellence the continent of large human movements, some of which are now being delineated by archaeological, ethnographical, linguistic, and historical evidence. These large movements of people have been important for the rapidity of the spread of new ideas and especially of tools and techniques. So rapid sometimes is the rate of spread that it often creates great difficulties for researchers concerned with identifying the source region of the diffusion of various innovations. Easy traversability has also been a vital factor in the spatial organization of groups of people to form political entities. Grassland regions of Africa have thus been notable for providing conditions conducive to the emergence of states in Africa. Once such states possessed the means of coercion, it was natural to expect that they would seek to bring under their domination other groups with inferior organization or implements of war. Such groups, once their resistance was broken, had the option of either becoming assimilated or retreating into less accessible or hospitable areas. In short, the corollary of the emergence of states in the grassland areas has been the further dispersal of weaker, less well-organized groups into more difficult environments such as highly broken, mountainous areas, arid wastes or heavily forested regions. The vegetal resources of Africa can thus be seen to have played a very vital role in the historical evolution of man in Africa. Not only have they provided man with an abundant supply of fruits and roots, but they have enabled him to create crops which can be nurtured and protected to provide him with new and richer sources of sustenance. The increase in food supplies facilitated the steady growth of African population. Up to 1650, the continent, according to Carl Saunders, was only less populous than Asia, its population of 100 million representing over 20% of the world total. 9. An important factor in the growth of population was the greater security offered by the better organized socio-political entities. Because of their greater distribution within the savanna zone, it is easy to appreciate why this zone probably accounted for a large proportion of the continent's population at this time, a fact which, especially in West Africa, came to be gradually reversed with slave raiding and the eventual foreign colonization of the continent from the 16th century onwards. Animal resources and cultural diversification. Closely related to the vegetal resources is the pattern of distribution of the animal resources. Africa has attracted attention from as far back as records go as the continent with large mammalian resources. Indeed, it is claimed that, excluding bats, the African mammalians consist of as many as 38 families. The distribution of these animals over the continent has varied both in time and space. Fossil remains indicate that all regions of the continent carried at one time or the other an assortment of even the larger wildlife. The North African Mediterranean region, for instance, was the home of animals such as the lion and the elephant, many of which were believed to have been driven out in the periods of great aridity during the Pleistocene. Most of those left behind were overexploited in our era to meet, for instance, the large demands of Roman amphitheaters. Indeed, as late as the middle of the 19th century, the army of the French d'Aumale discovered great numbers of wild animals, including lions, wherever they went in Algeria, from the precipitous rocks of Constantine to the plains of Oran. The desert still preserves a remarkable range of wildlife. These include the Dorcas and Dama gazelle, the addax, the scimitar horned oryx or oryx algazel. In much earlier and wetter times, its resources are known to have been more considerable and to have included animals such as the elephant, rhinoceros, hippopotamus, giraffe, the now extinct giant buffalo, and many of the larger antelopes. But it is the grassland plains of Africa which are the true home of the majority of African game. Degree within these zones in West, East, Central and Southern Africa are found beasts of prey such as the lion, the leopard, the African tiger cat and the hyena. It is here also that we find the bugle hartebeests, the topi, the red-fronted gazelle, the warthog, the roan antelope, the zebra, the giraffe, and the ostrich. Here is the natural habitat of the elephant, the buffalo, and the black rhinoceros, as well as of the derby and Cape eland, the bush buck, water buck, and reed buck. The extent of territory covered by each of these has changed over the centuries. All of the animals have suffered great depredations at the hands of man or have lost to other species in the great competition for survival as environmental conditions changed. The absence of the white rhinoceros between the Zambezi and the Upper White Nile, for instance, is ascribed to the competitive advantage which the change in climate and vegetation during the Pleistocene gave to the more aggressive black rhinoceros. Although most of the wild game frequent the forest of tropical Africa, this region is on the whole less endowed with animal resources. Some of the more notable forest animals include the bush pig, the giant forest hog, the bongo, the great apes such as the gorilla and chimpanzee, and the okapi. Even here environmental changes have affected the extent of the territory available earlier. The intermittent presence of the bongo is due to the reduction of what must once have been a continuous forest cover across equatorial Africa. These abundant animal resources certainly served man over the long period of his existence as primarily a hunter. So inexhaustible did these resources appear that some African communities have remained in this hunting stage of development right up to the present day. A special category of animal resources is represented by fish, which have also been caught from as far back as the Mesolithic. Not only the rivers but also freshwater lakes, such as Turkana, Rudolph, Nakuru, and Edward in East Africa and the Chad in West Africa attracted early human population because of their fish resources. One of the rivers, the Nile, was obviously of special importance. Here were found waterside communities who used harpoons and fish hooks of bone and, in addition, hunted and ate the hippopotamus and the crocodile. The use of simple dugout canoes for fishing in inland waters is still pervasive throughout Africa. Only a few fishing communities, however, developed canoes large enough to attempt coastal sea fishing. Everywhere, until recently, inadequate technological development prevented the exploitation of the rich fish resources in the sea around the continent. The singular richness of variety among land animals, however, provided a tremendous reserve of potential domesticates. Domestication of animals in Africa was virtually limited to the ass, the cat, the guinea fowl, the sheep and the cow. The reason for this state of affairs is that Africa during the Neolithic was influenced by an earlier and more successful experiment in Southwest Asia. It was at this time that the continent was introduced to pastoralism. According to Clark, the first Neolithic pastoralists appear in the Sahara in the 5th millennium before our era, perhaps earlier. They drove herds of long and short-horned cattle and goats and flocks of sheep and continued there until the increasing desiccation after 2,500 years before our era forced some of them to move out. Pastoralism was, however, not diffused uniformly in all the environments of the continent. Whilst most communities came to own the smaller varieties of stock, only a few mastered the skill of tending the larger ones. Among these the Tuareg of the Sahara, the Fulani of the West African savanna, and the Maasai of the East African grassland remained overwhelmingly committed to animal husbandry, and have eschewed any attempt at combining this skill with that of plant husbandry. Constantly following their herds in search of water and pasture, these communities have maintained till today the nomadic way of life in its purest form. Some Bantu groups in East Africa, however, have managed to combine animal husbandry with cultivation to the mutual advantage of both. Perhaps one of the factors inhibiting the spread of pastoralism in Africa was the proliferation of other zoological species which had a negative impact on resource development of the continent. Prominent among these is the tsetse fly. This large, bustling brown fly is the main, but not the only, vector of trypanosomiasis, a disease which causes sleeping sickness in man and spells death for his animals. This fly is found today in a belt running across Africa between latitudes I4° N and S of the equator. The only exceptions are the highlands rising to levels above I,000 meters which are relatively cold, and the open short grass country where the dry season is too hot and desiccating for the fly to breed. Tsetse fly has been present in Africa since very remote times. Given the fact that fossil impressions of this fly have been found in the Miocene beds in North America, it would appear that the fly must have had a far wider distribution in prehistoric times. 3. Its disappearance from various areas in Africa and in parts of it may be the result of a combination of climatic changes, natural barriers, and glaciation. Indeed, within Africa, the climatic alternations of the Pleistocene must have had a tremendous influence not only on the distribution of various species of the fly but also on their infection rates. Belts of land infested by these flies have constituted effective barriers to the development of animal husbandry. Herders must have realized at an early stage that their herds would face heavy losses when traveling through infested country. As such, the penetration of cattle from North Africa to the south was subject to the existence of natural fly-free corridors as well as those created by densely settled agricultural communities. The latter, a good example is provided by the migration of cattle owners some 9 centuries ago, creating, through the merging with other peoples, the Tutsi and Hutu society of present-day Rwanda and Burundi. The history of Africa would have been very different if the continent had been free of tsetse. Instead, with the fly effectively keeping large livestock out of the reach of settled agricultural communities, the use of such animals for draft purposes never occurred, nor was opportunity created for discovering the great importance of the wheel. On the other hand, some of the larger livestock provided some peoples with riding animals whose fleetness of foot encouraged them into aggression and political domination of the sedentary peoples. 14. Among other adverse zoological factors, find the malarial mosquito and the locust. The several species of mosquito capable of transmitting malarial parasites of one kind or another. Some are more attracted to human blood than others. The most prevalent in Africa is Anopheles gambiae, which, because it also feeds on animals, is very difficult to eradicate as it can survive even if temporarily prevented from feeding on man. The mosquito usually breeds in standing water and is most numerous near swamps and rivers. Its breeding places increase with increasing rainfall, and high temperatures boost both the development of its larvae and that of the plasmodium cycle in the adult mosquito. By the same token, cooler temperatures encountered at higher altitudes curtail the incidence of the mosquito. Thus, endemic malaria tends to disappear above I,000 meters even though transmission may persist beyond this level. Long the mosquito has been part of the human environment in Africa is not known. The very high incidence of the sickle cell trait found in many African populations would seem to suggest a long-standing and intimate relation between it and the evolution of the African populations. This trait is certainly the product of age-long selection pressure favoring the survival of these populations in conditions of hyperendemic malarial infections. Malarial mosquito, to the extent that it greatly impairs the survival chances of non-adapted human groups, has also been a major factor in the history of the continent. Certainly, until the 20th century, it effectively discouraged European settlement in the hot and humid climate of West Africa and saved the region from those thorny interracial problems that have plagued the history of the more elevated regions in North, East, Central and Southern Africa, which had fallen victim to settler colonization. Locusts are amongst the traditional plagues of Africa. They are large grasshoppers living normally in single, solitary state or in small groups. They are found in areas of vegetational transition at the desert margins or near woodland and grassland savannas. Three main kinds of locust are found in Africa south of the Sahara. These are the red locust, the African migratory locust and the desert locust. All three need two kinds of habitat: bare ground for laying their eggs and vegetated country for feeding. Occasionally when, for various reasons, their feeding ground is restricted to a small area, they congregate into large swarms to invade areas far and near. Examples of such invasions are not easy to identify from the distant past, although the Old Testament does refer to the locust as one of the plagues from which Egypt suffered at the time of Moses. From about the 19th century, records of invasions become more abundant. Central Africa, for instance, suffered invasions from the red locust at different times between 1847 and 1854, 1892 and 1910, and more recently between 1930 and 1944. For settled agricultural populations, the depredations of such invasions, especially just before harvest, can make all the difference between abundant food and famine. Where, in the past, other conditions such as drought coincided with locust invasion, the stage was set for considerable social and political upheaval on the continent. Water resources and human mobility. The significance of water resources in the evolving history of Africa can hardly be overestimated. Although the continent has within it areas with some of the highest annual rainfall figures in the world, it also has areas with some of the lowest. Extensive regions of the Sahara and the Kalahari are a standing testimony to the acute aridity of large parts of Africa. But besides the deserts, the broad savanna zone has only marginally adequate rainfall, and human lives in these regions depend greatly on the fluctuating vagaries of rain-bearing winds. This fact would not be a matter of serious concern if it were possible to exploit other sources of water such as surface streams, lakes and groundwater. However, over large parts of the continent, especially in the relatively hot lowland regions, the river valleys are infested with debilitating insects and are therefore unsuitable for human settlement. River regimes also closely parallel that of the rain and thus bring little relief in periods of rain failure or prolonged dry seasons when the river beds are themselves bare of water. Traditional technology except along the lower Nile Valley had no means of storing water against rainless days. Poorly developed technology also meant that groundwater could not be tapped below certain depths even in areas such as the artesian basins where the geological structures have helped to imprison vast reserves of water. In large parts of the continent, underlain by basement complex rocks, little water storage capability is found and human settlement cannot depend on other than the annual rainfall. Water shortage resulting in serious drought conditions has thus always been a fact of life in Africa. The climatic history of the Pleistocene period shows that for different parts of the continent there may be a cyclical pattern of long periods of more or less rainfall. But whatever the situation, drought represents an environmental pressure on human groups, forcing them to 344 respond in various ways. Characteristic of virtually all of these ways is the element of movement, a search for better watered areas either on a temporary or a permanent basis. Such human migratory movements can be peaceful, but very often they tend to be aggressive, depending on their organization and their leadership. Histories of many communities in Africa record their migratory movements from one area to another, or the incursions of more powerful migrant groups who conquered and reorganized their societies. Where water is adequate, however, whether from rainfall or groundwater sources, and where the art of agriculture has been developed, a settled population grows up with the potentiality of gradual social evolution along the arduous road towards controlling nature. Rich and varied crops ripen, and the rhythm of their maturation comes to dictate the rhythm of social life. The harvesting season becomes a special occasion and rituals are developed to give appreciative sanctity to an event that is inexplicable except in terms of a benign natural force. Whether this settled population rises higher in the ladder of social evolution depends on a number of other factors, not least of which is the abundance of food resources to encourage a division of labor within the community and facilitate the emergence of groups with specialized skills. This possibility depends not only on the adequacy of water supply but also on the fertility of the soils. To a large extent, the geological characteristics of large parts of Africa determine the quality of its soils. Because of the variety of rock types within the basement complex, the character of soils developed on this parent material is highly variable and their fertility is no more than moderate. Such rocks, however, tend on the whole to have an adequate reserve of most plant mineral nutrients, although their variability means that conditions may change rather sharply within a short distance. Soils developed on sedimentary rocks tend, on the other hand, to be more uniform in character over large areas, but they do not form anything approaching the wide tracts of highly productive soil as do the Chernozems of the wheatlands of the Ukraine or the prairies of North America. The interaction between soil characteristics and climatic factors has been crucial for soil fertility and its capacity to support dense population over the long run. In humid regions, for instance, the illusion of fertility produced by the luxuriant growth of vegetation hides the fragile nature of the soils. Once the natural vegetation is cleared, the organic matter in the soil rapidly disintegrates as a result of intensive bacterial action stimulated by the generally high temperatures. In no time, the fertility drops, crop yields diminish and the human population is constrained to shift elsewhere. In the subhumid regions, on the other hand, soil fertility is much better. However, the periodic oscillation in the pattern of movement of soil 345 moisture encourages the development of extensive areas of lateritic ironstone crust which are completely unsuitable for cultivation. The presence of such crusty surfaces means that moderately fertile soils are scattered and their capacity for supporting dense human population greatly impaired. Such soil conditions are characteristic of Western Africa north of the forest zone and of the Central African plateaus at the margins of the Zaire Basin. In semi-arid lands with lower rainfall similar surfaces, known here as Duri crusts, are also to be found, although their occurrence is more scattered. The result is that the brown sandy soils of this region are more valuable and in years of good rainfall give moderately good harvests. Further north, the desert soils are shallow, have poorly developed profiles, and lack organic matter. A striking fact of the geography of Africa, therefore, is that really fertile soils are limited in extent and highly scattered in their distribution. They include the deep loamy clayey soils derived from basalts and other volcanic rocks of Pliocene and later ages which are found particularly in parts of East Africa. Under high forest, these soils are chocolate brown in color at high altitudes but red at lower levels. Of equal significance are the rich alluvial soils derived from the same type of rocks and found in the floodplains of rivers such as the Nile. The abundant yields of crops from both types of soils have facilitated the growth of dense human populations. Where, as in the Nile Valley, This concentration is combined with a high degree of social and environmental management such as was provided from the pre-dynastic Neolithic period. The stage is set for the emergence of a more highly evolved society. This later society, with its growth of an urban civilization, its class differentiation, fine craftsmanship, and monumental architecture, as well as its use of writing, was the outcome not only of increasingly regular interaction with Mesopotamia but also of the possibility of supporting a dense population composed of a variety of social groups by an agricultural surplus, which in those distant periods must have been very impressive. Such conditions were later to be reproduced in a few areas of Africa, such as the bend of the Niger at the time of the emergence of the Ghana Empire in the early medieval period. But although there are other areas of fairly good soils, wide tracts of the continent, above all the upland plains where weathering has continued for millions of years, have soils that are thin, lack adequate plant nutrients or essential minerals, and are even today still of limited value for agriculture. In such areas, from as far back as the Neolithic, man has only succeeded in depending on shifting cultivation to eke out a living. This form of economy is profligate in its use of land and thus discourages the emergence of densely settled communities. The sparsity of population over large parts of Africa, with its inhibiting effect on social evolution, must thus be seen as a critical factor in its history. It is, of course, now known that the fertility of any area is as much a function of effective soil management as it is of natural characteristics. Indeed, other areas of the world where societies have today attained a higher level of social evolution, 346, have also passed through a phase of development in which their economy depended as much on shifting cultivation. For Africa, therefore, soil management constitutes a matter of vital importance for societal evolution. It was a determining factor in the past and points to the path that will have to be taken if a serious effort is to be made to embark on a process in which progress will be decisive. Conclusion. The historical geography of Africa, especially in its economic aspects, yields a picture of a continent in which nature has been unusually kind, at least on the surface. The superficiality of natural bounteousness, so well exemplified in the fragile luxuriance of the tropical forest, has been something of a trap for the human population in Africa. Finding existence so easy to achieve, communities have sidestepped the agonizing demands of social evolution. It is true that some far-sighted individuals or groups of individuals have emerged here and there to urge their communities forward, but their impact has failed to be cumulative. No doubt external interference, particularly the long history of slave raiding, has had a pernicious effect on the general state of development on the continent. But the fact that such interference was possible is a grim reminder of the dangers for any human group of failing to engage in the continuous struggle of fashioning stronger, larger, and more cohesive social organizations to face possible challenges. The history of Africa will have availed us nothing if it does not strongly emphasize this fact. As in the prehistoric period, the geography of Africa today reveals a continent with still abundant natural resources. Its recent colonial past has, however, helped to create a situation where much of these resources are exploited largely as exportable raw materials to serve the needs of other societies. Moreover, exploitation with its high technological requirements demands the organization of the African peoples in large, integrated communities to develop these resources for genuine development. The history of a decade of political independence of African countries leaves an ambiguous impression that the importance of fashioning such communities in competition with other similar communities is still far from being grasped. The purpose of this sketch of a historical, economic geography of the continent, if it serves any purpose at all, should be to stress that nature in Africa, as elsewhere, determines neither the destiny of a people, nor the route it will take. Its role is at best permissive. Peoples, like individuals, have been and will continue to be the architects of their own fortunes. 347. The interdisciplinary methods adopted in this study. J. Zerbo. Introduction. The interdisciplinary approach to historical research is a fashionable idea. But when it comes to putting it into practice, difficulties arise. There are great differences in method of work between different disciplines, and research workers are deeply imbued with the habit of specialization, and jealous of the territorial integrity of their own subjects. The same tendency appears even in presenting the results of research. The life of a community is still dealt with under quite separate headings covering, for example, economic, social, and cultural aspects. A suggestion of interdisciplinary working is thought of in terms of takeover bids. In this struggle for territory and leadership, history is in an ambivalent position. It is essential to all disciplines, but having, unlike other subjects, no esoteric vocabulary of its own for its practitioners to take refuge behind, it runs the risk of becoming devalued, acquiring universality, as it were, at the cost of respectability. If history is an orchestra, its conductor has traditionally been the written record. But the history of Africa, particularly south of the Sahara, is characterized by a relative dearth of written sources, especially before the 16th and even more before the 7th century of our era. There is an African proverb which says, "When your mother is not there, you suck your grandmother." One failing written source material, African history must combine all other available sources in order to recreate the past. The deficiency may in the last analysis become something of an advantage. It makes possible an escape from the overriding influence of the written word, and the consequent implicit devaluation of other sources. Historical and anthropological research in Africa has long suffered from two contradictory evils. One is the weakness of historians for regarding the process of social change as a mere string of dates. Hence the obsessional urge to construct a chronology that will make human development intelligible. 2. The neglect of everything else, economics, social structure, and culture. Hence the linear approach aimed at producing a genealogy or a succession of events, the bare bones of history, in short, without the flesh and blood. The other even more pernicious aberration may come partly from applying to the real African preconceived ideas of the primitive condition drawn from sketchy concepts of evolution. It analyzes structures as though they were timeless, disregarding the historical depth which alone gives them meaning, subjective or objective. Again, some scholars are taken with the notion of the self-sufficiency of their own subjects. There are linguists allergic to any suggestion of cultural interaction, and functionalist anthropologists who reject the idea of historical depth. Happily, watertight compartments of this sort are being progressively broken down. The realization, writes J. Desmond Clark, that archaeologists, linguists, and cultural anthropologists or ethnographers are faced with many of the same problems, and that the best way of solving them is by interdisciplinary teamwork, is one of the most encouraging and exciting factors in African studies today too. The pseudo-history characterized by an exclusive preoccupation with chronology, and the delusion of a purely static, formal structural analysis, are on the wane. This is demonstrated by those schools of thought which are introducing diachrony and conflict into their methods of work. Either integrating cultural data with linguistic data, for example, Calamy, Griel and Haueris, or abandoning the sociologist's static approach for a dynamic one that takes movement and comparison as its tools, Ballandier. Contradiction is, after all, an integral part of reality. What is certain is that no single discipline can tackle alone the dense jungle of the reality of Africa. The Gordian knot is not to be sliced through with a cutlass. Some workers claim to have found the essential explanation of a particular African society in a single factor, for example, in a structural analysis of kinship, or in the complex of representations, beliefs, myths and symbols considered as a logical entity in itself, independent, for instance, of productive relations. 3. In fact, a study of kinship shows us systems less pure and more complex in Africa than, say, in Australia, with structures which Levi-Strauss admits are conditioned by economic and political factors as well as the mere mechanism of kinship rules. African history is less well equipped than any other subject to thrive in a vacuum, even, indeed, especially, when it comes to what might be regarded as history's special preserve, establishing the chronology. Correct solution to a problem of chronology often calls for the use of 4 different sources: written records, archaeology, linguistics and oral tradition. Thus, the historian following time backwards is like a motorist with several instruments at his disposal for measuring the watch, the milestones and, conceivably, information from a local inhabitant. This essential cooperation helps to ensure that the picture of the past is created with a clarity and completeness that no one source alone could give. The description of Koumbi Sale given by Alban would still be sadly incomplete were it not for the mass of supplementary information furnished by archaeological excavation. Even oral tradition made its contribution here, leading as it did to the discovery of the site of Koumbi Sale. Hence it seems inappropriate to classify sources in order of importance, with written records at the top and oral tradition at the bottom. The value of a source is not absolute, but varies according to the subject of research. In any given case, the mass of available data will include a master source, which will vary according to the topic. For African prehistory or for pygmy societies, written records are obviously not the best source, there are none. For different periods and areas, the range of historical evidence is dominated by different master sources, the others playing subsidiary roles. The master source is not the same for an obscure Gaechalian tribe, Jugurtha's kingdom, the Kurdi of northern Cameroon, the Asante of Ghana, the Kabar of northern Togo and the Gao Empire described in the Tarjkh al-Fatish. Moreover, it may well be that the master source will be identified only after the research is complete, for though the source conditions the results, it is the results that vindicate the source. So it is safe to say that in the field of African history the interdisciplinary approach, far from being a luxury, is one of the essential factors. There is in fact no alternative to it. HOW sources complement one another. The sources of African history are manifestly complementary. Any single one on its own will be defective and give a blurred image of reality which can only be brought into sharp focus by means of other sources. Archaeology by itself may yield little more than a dry-as-dust description, or a sterile conclusion incautiously arrived at on the basis of a small number of samples, and if waiting for further excavations were the only way of confirming or exploding hypotheses, the pace of progress would become intolerably slow. But replaced in the many-faceted living context which it is Its purpose to explore, archaeology does much for other disciplines and receives much from them in return. Finds are often explained from outside. Archaeology, as at Zimbabwe, where it is the gold mines and their defense. Plus religion, that makes sense of most of the structures above and below. Ground level. Grave goods, and the positioning of bodies in tombs, can be explained only in terms of a people's beliefs and its ideas of the hereafter. Conversely, when excavation in northern Ghana brings to light architectural features identical with those of the Sudanic Sahel, archaeology sets or solves an interesting problem of cultural influence. African art, again, can only illuminate history if it is illuminated by it. Art. 350. And particularly prehistoric art, is conditioned by a multiplicity of factors. From geology through social and political structure and kingly ambition to religion, mythology, and cosmogony. Aesthetics is closely governed by ethics, while at the same time serving it. Moreover, by recording ritual, scarifications, hairstyles, costumes, and scenarios, art often acts as a museum of social, and even physical, anthropology. Art defined as craft plus inspiration cannot be understood without history. Social organization often explains points of style, for instance, at Benin the same artists, Igbosinvan, carve wood and ivory, while others work in pottery and bronze. The manufacture of ivory and bronze objects is in large part explained by a switch from one material to the other, just as the outline and external decoration of pots from prehistoric periods is only to be explained by their descent from plated straw baskets. Then there are masks, on the making of which Africans have lavished such boundless imagination. Bobo masks, for instance, especially the three main types, Kale, ancestor mask, Kimi, head of marabout crane, and Type, buffalo skull, are real personalities, familiar in the village. They are not only evidence of history, but contribute actively to the making of it. 4. The cowries described by Ibn Battuta in 1352 at the court of Mali were originally intended for use as coinage, but they also served as adornments. Artistically strung together, and were specially important on social occasions and at religious ceremonies. Here art is an integral part of a whole complex pattern which gives it meaning and which at the same time it endows with life. To embark on the history of certain African societies without a knowledge of the rich language of cowries and masks would be like going into a library without being able to read. It would inevitably produce a defective version of their evolution. The same is true of oral tradition, which is discussed at length elsewhere. Oral tradition is history from life and transmitted by the collective memory, with all the garbling and lack of sophistication that this entails, but also all the freshness and vigor. Certainly it has its flaws. For example, it is often silent about economic and social factors. But even with its flaws it can point us to other sources which are often more relevant, such as manuscripts or archaeological sites. Indeed, before embarking on any program of excavations it is wise to set to work to collect oral traditions. It is also a help in correcting errors of interpretation that may arise from a purely external approach, and it makes it possible to limit the number of hypotheses, to narrow the spectrum of alternatives. 5. Where there are several versions of the same tradition, some other source, example reference to a map showing the areas affected by an eclipse, will make it possible to decide between them. Drums, which have their roots in tradition, are one of Africa's great living books. Some drums are oracles, others are broadcasting stations, war cries, inciting to heroism, or chroniclers recording landmarks in the life of the community. Their language is essentially a message replete with history. In this connection, some divide ethnomusicology into internal, technical musicology and external musicology, which is part of the social and cultural fabric. 6. The greatest epics and chronicles are often sung by groups organized for the purpose, and in a manner peculiar to Africa, in which the whole audience join, for music is never passively listened to, but it is performed by everyone. Who is present. What is happening is a collective celebration. The song, dance, and music become a synthesis to which linguistics, history, botany, psychology, social psychology, physiology, psychoanalysis, religion, etc., may all contribute. Without exaggerating the importance of musico-chronology, the comparative study of music and musical instruments by arithmetical means and statistical analysis can provide clinching evidence on the question of the spread and development of cultures. The world of African music is giving ground in the face of an invasion by other types of music, often less rich even if introduced by richer economic systems. Is the drum that has made history destined to end up in the near future itself as a museum exhibit. Linguistics is becoming more and more the partner of history, and a young, reliable, productive partner it is. For languages are a living museum in which tradition is preserved, and to extract the real essence of them it is necessary to possess the science of language. Every language is both a psychological entity and a social phenomenon. Its vocabulary, for instance, reflects the impact of history on a people. But conversely, it is the language, the word, that instills a system of concepts and behavioral rules into a people's mentality and motivations. Some concepts are difficult to express properly in a language geared to a different overall context, as for instance, that of Sanakia, in Mande, or Rakhire, in Mole, roughly translatable as joking relationship, which plays such an important historical role in the Sudan and Sahel, or that Oediadagui, in Mande, which by no means coincides with the simple notion of landlord, or Oitengsoba, rendered literally master of the land or earth priest, though these do not convey the meaning. The historian will be continually using linguistic evidence along with other source material. Thus, for instance, the date and origin of the circular ruins in the Lobi area were determined by the conjunction of several pieces of mutually conflicting and supporting evidence. A hypothetical Portuguese origin, based on a text by de Barros, was ruled out by the line of the road supposedly used and by examination of the pebble coating, which turned out to be too fresh to justify an early dating. Then the Wiili and Birifor name for these ruins, Kol Nawo or stables for foreigners' cows, was noted. The foreigners were identified as the Kaulango on the strength of the style of pottery found in the ruins, and finally an estimate of date was made taking into account the migration traditions of the peoples of the area. This is a practical demonstration of the decisive role of linguistics in interpreting a particular historical fact. 7. It would be a great mistake to confuse the phenomenon of language, which is cultural, with tribalism or the biological factor of race. The language of the Dagomba horsemen who invaded the Volta basin in the 14th century is probably lost, having been supplanted by that of the local Kusais women whom they took as their wives and who became the mothers of their children. Here we see an example of linguistic contamination at the expense, as sometimes happens, of the political ruling class. Ethnohistory, in the shape of the quasi-static ethnographic present of the functionalist anthropologists, is not real history. It has nothing to contribute View to our team of sources, each of which is not static but a variable carried along by the tide of history. Besides, functionalist ethno-history too often ignores material cultures and that general movement of produce which Leroy Gourhan described as the matrix of civilization. Barter trade across the Sahara, on the basis of salt for gold from the Sudan, superseded some centuries later by that of slaves for guns, may well have been the main factor underlying the rise of the kingdoms and empires of West Africa. Thus we see that a dynamic sociology must also form one of the principal strands in African historical research. It is not a matter of blindly shifting one's effort from one socio-political work phase to another, either in time or space, that would create more problems than it solved. For instance, to calculate the average length of reign it will not do simply to extrapolate backwards from an average length established for a known contemporary period. The political and social stability or instability are not necessarily the same. Again, the preferential collateral succession, from brother to brother, in the Mossi kingdom of Yatenga would not produce the same average values as in the kingdom of Ouagadougou, where succession was preferentially in the direct line from father to son. In the case of Ouagadougou the average length of reign would tend to be longer and the number of generations greater. There are also religious factors to be taken into account. For the dynasties of the Gan kings, Genmassa, who were regularly chosen from among the youngest full-grown men, the average length of reign would be greater again. In other words, the chronological horizon cannot be determined independently of data from the political sociology of a given country. But even the concept of stability itself is not an invariant ready-made model for all periods and countries. Stability may be merely apparent, or be bought at a high social cost. In Ethiopia and the Kingdom of Ouagadougou the elimination or deportation of unsuccessful candidates and of collaterals produced a certain stability, but at a high price in human resources which must be accounted for in terms of instability if a true historical account is to be given of the development of these countries. The natural sciences will also be brought into play to help crystallize the picture of Africa's past and bring it into focus. We have computers for processing certain numerical data. There are technological, physical, chemical and biochemical methods of dating, of analyzing metals, plants and foodstuffs and of investigating livestock and its heredity, and there is epidemiology and the study of natural disasters, a branch of climatology. It is no accident that famines occupy an important place in African tradition, serving as historical landmarks in the same way as wars. Violence has no doubt played the same sort of part in the historical development of Africa as in that of other continents, but there are differences. On the one hand, the low level of technological development has lessened its absolute impact, whilst on the other its relative impact has been greater because even a slight lead by one people over another in this field had heightened significance. Disparity in armament was probably the deciding factor in enabling the Assyrians in Egypt, the early kings of ancient Ghana and Shaka the Zulu to establish their hegemonies. Statistics also has a major contribution to make, if only in helping to quantify facts that would otherwise be subject to qualitative distortion, for there is a threshold beyond which a qualitative change in social phenomena may be said to take place. A population of 10,000 will not have the same sort of structure as one of 10 million. When we speak of invasions by 14th century African armies, the anachronistic pitfall is to think of these forces in 20th century terms. Recourse to statistical data, even if only in the form of rough estimates, will help to show events more nearly on the scale on which they really happened. The study of African wars, moreover, is only of use to African history if taken together with that of religion, with which they are intimately bound up, for the art of war was partly an exercise in magic. To be convinced of this, one has only to look at Albori Ndi's fighting dress, covered in amulets. This custom continued down to the African riflemen of the First and Second World Wars. Physical anthropology too can help in the compilation of true history. This field has long been bedeviled with racialist myths based on outward appearances, such as the Hamitic theory. The only cure is the interdisciplinary approach, which brings together different types of evidence in the search for the truth. Clues to certain identification are furnished by prehistoric rock paintings, though it is important not to confuse lifestyle as portrayed on a rock face with race. We must not forget that certain types of skeletal deformation, such as the lengthening of the skull practiced by the Mangbetu, are related to culture and lifestyle. Hematology can help to clear up some misconceptions. It indicates, however, that even blood groups adapt to environment, thus demonstrating the decisive effect of habitat on race. Race can be understood only by regarding it, like most of history, as compounded of nature and culture, with biology as the link. African nature has indeed left its mark on history, and consequently, while we must avoid mere mechanistic determinism, we should never lose sight of environmental factors. The specificity of the cultures and prehistoric development of Central Africa, as de Belde Hermans has pointed out, is understandable only if we bear in mind the lack of daylight in the jungle, a reminder to us of the influence of space on time. 9. Nor can we usefully consider the earliest inhabitants of the Nile Valley without reference to geomorphology and paleoclimatology. Degree. Method. Thus the historian of Africa must take account of a wide range of interlinked and overlapping disciplines. How is he to organize this united front of heterogeneous allies in the battle for the face of Africa that was? It is possible to envisage a loose association, amounting to no more than agreeing to COMMON objectives, each member of the group then being left to work according to the techniques of his own discipline, with a meeting at the end to collate results. This does not seem a satisfactory method. It leaves intact all the drawbacks of individual disciplines without taking advantage, if not of all their virtues, at least of the beneficial effect of their close association one with another. A better way is the interdisciplinary method, under which different disciplines, instead of merely working alongside, are grafted onto one another. Not only the overall research strategy but also the tactical details must be settled jointly. First, the essential questions are agreed in rough list form, then they are split into groups according to the disciplines likely to be involved. Checks or collation of results must be carried out at regular intervals, or even when necessary at the request of one of the parties involved in the work. The problems are then restated in revised form in the light of the overall progress to date. Snags or bottlenecks that come to light as a result of the checks are dealt with by crash programs or concentration of effort. This sort of continuous association or teamwork needs a director for the whole project or program, but separate leaders may be designated in advance for the various stages of the investigation, one of which will call for a linguist, another for a sociologist, and so on. This sort of interdisciplinary working may well result in improving each discipline's techniques and making its attack on the joint research topic more effective. Journeying down blind alleys can be quickly stopped, and the maximum of useful routes and shortcuts can be opened up. TEAM. Research of this kind, in which archaeologists took historians, social anthropologists, art specialists, and botanists with them to their sites, would act like a gigantic trawl net, dipping both wide and deep into world history. This presupposes, of course, that institutes of African studies, of which a considerable number already exists, can adapt their structure to this way of working, and it presupposes above all a new attitude of mind on the part of the research workers themselves. What, then, is the object of the exercise? It is to give back to Africans a conspectus and an awareness of their past. This cannot be a photocopy of the original, but, in somewhat the same way as in Plato's allegory of the cave, it must convey an impression of scenes that were real in days gone by. NOW life is essentially integration and coherence, the grouping of differing forces for a common purpose. Death, by definition, is disintegration and non-coherence. Life, whether individual or collective, is neither linear nor one-dimensional, it is dense, compact tissue. Creation of the past, a feat rarely achieved by historians, is occasionally attempted with success, admittedly under easier conditions, by historical novelists. Teachers of history, economics, sociology, and so forth would find a fruitful subject for joint study in such slices of life as John Steinbeck's The Grapes of Wrath, André Malraux's La Condition Humaine and Thomas Mafalo's Chaka. Without turning to the writing of novels, we must aim at reconstructions of this order of density, for real life was even more action-packed than novels. Truth is stranger than fiction. Every historical process partakes at one and the same time of all aspects of social reality, and any reconstruction that fails to take them all into account will be, if not non-history, at any rate a different history, incomplete and therefore one-sided. We can, of course, concentrate on a single dot on the surface of the historical picture and make an enlargement from it, always provided that we remember that it is part of the picture, without which it cannot be completely understood, even as a dot. This is even truer of the picture as a whole. Major historical facts, like the Mande expansion in West Africa, are the result of a conjunction of 356 factors, including technology, material equipment, trade, linguistic advantages, appropriate political organization and religious fervor. Seek, as is often done, to give undue prominence to a single prime cause, before endeavoring to portray in all their teeming profusion the parts played by all the factors, is to set up a conceptual structure instead of trying to recreate the past in one's mind. This view of history in the round is even more essential in the case of simple and relatively unified societies than in countries divided on class lines. A distinction, perhaps somewhat facile, has been drawn in Africa between societies with a state structure and those without, the latter, of course, being defined according to the rules of one's own collective experience. 11. This is perhaps to overlook the case of an empire such as Mali. It had no metalled roads and no bureaucracy, and its rulers deliberately opted for the decentralization that the facts dictated, and the result of all this was that the real life of the majority of the population went on outside the state. It went on, that is, in the villages, which had been independent for centuries and were connected with the center neither by the juridical link of a feudal fief, the physical link of railways and motorways, nor the functional link of income tax returns and central or local government regulations. To ignore this is to condemn oneself to a simplistic approach based on lists of kings and princes, many of WHOM may be known only for 1 or 2 high points in a reign of 10 or 20 years, and who are set up as arbitrary landmarks in the real life of the people. The overwhelming majority of African peoples lived as unitary, if not totalitarian societies, in which everything was of a piece, from tool making to fertility rites, including the ceremonies of love and death on the way. In this sense, a society ruled by animism is as highly integrated as one governed by Islam. In many respects this was not a secular society, and to think of it as such is to jettison a large part of the facts. It is quite true that centralization also exists in such countries, but it is not the type found in the modern state, 12, where it is as it were the price paid, and the antidote, for pushing the division of labor to extremes. For instance, among the Sanyafo, where the men's secret society is the Poro, the Lobi, who have the Diaro, and the Diola of Senegal, initiation often played a key role, the whole life of the community being organized around it. Again, whole federations of villages may be built round a common altar or cult, as in the Samo area of Upper Volta and in the Igbo country. While productivity in Africa has remained relatively low, there has, on the contrary, been a tremendous flowering of folk art. For people almost totally dependent on nature, any clothing was finery. The meanest tool or pot was covered with decoration. Again, bodily scarification to produce sunken or raised designs fulfills the dual function of denoting ethnic identity and satisfying an aesthetic urge. Similarly with the iron coins, guins, used by the Loma, Toma, Kissi, Koniank, Mende and Kuranko in Guinea, Sierra Leone, and Liberia, they were at the same time coins, protectors of houses and land, and the resting places of the spirits of the departed and the ancestors, and it would be a mistake to see them as limited to any one of these functions. To portray unitary societies of this type clearly calls for a correspondingly all-embracing history, the kind of interdisciplinary teamwork exemplified in the study of the KONKOMBA, carried out jointly by the anthropologist David Tate and the historian J. D. Fage. A similar synthetic approach was adopted by J. Burke for his work on the social history of an Egyptian village. 13. The global approach means taking into account all external factors as well as purely local ones. It means looking beyond the frontiers of Africa and integrating contributors from Europe, Asia, America, and Indonesia into the fabric of Africa's personality. A perfunctory diffusionism is not, of course, enough. Even when there is outside influence, it is modified by internal forces. As the Schoolman's adage has it, quid recipitur, ad magem. Recipientis recipitur, whatever is received in the light of and according to the form of the recipient. Thus Asiatic rice was domesticated in areas where the indigenous African strain already existed, and similarly, manioc where the yam already grew. African culture is a subtle blend of factors. It cannot be reduced to the arithmetical total of these factors, since they are not packets of groceries to be lined up and counted. African culture subsumes and sublates its constituent parts, and the object of African history must be to give full weight to all the parts and so portray the dynamic development of the whole. In other words, the interdisciplinary method should eventually lead to a transdisciplinary approach, one in which all disciplines are represented with equal right. 13. J. Burke, 1957. 358. Chronological framework. African pluvial and glacial epochs. Part IR said. Our purpose here is to give a general account of some of the changes in the physical aspects of the African continent during the Pleistocene and early Holocene or recent epoch. During this approximately 2 million years the climates and environments of the world fluctuated considerably. The series of momentous climatic events which occurred during this epoch subjected the northern latitudes of the globe on 4 successive occasions to the advances and retreats of ice sheets, known as Geans, Mindel, Riss, and Wurm. In the Alps, river valleys and terraces were formed, the present coastlines were established, and great changes were induced in the fauna and flora of the globe. The earliest proto-human forms had diverged from the ancestral primate stock by the beginning of the Pleistocene, and the oldest recognizable tools are found in horizons of lower Pleistocene age. In large measure, the development of culture since man's appearance as a tool using MAMMAL seems to have been profoundly influenced by the environmental factors that characterized the successive stages of the Pleistocene epoch. The idea that during several episodes of the Pleistocene epoch the glaciers were formerly far more extensive than at present had become well established in Europe, and it soon became obvious that if these European episodes of climatic deterioration were of more than local character. Work in Africa, for example, has shown that the continent underwent during the Pleistocene climatic changes of far-reaching dimensions and, although these have not yet been correlated conclusively with the events occurring in the northern part of the globe, they are to a large measure tied to these events in a manner which has yet to be deciphered. The prospects for the establishment of a time scale for the late Caenozoic and Pleistocene have greatly improved during the last decade. Deep sea drilling programs have given extremely valuable information on a more or less continuous sedimentary record of the events of the latter part of the Earth's history. The detailed and multidisciplinary studies carried out on the cores raised from these programs, the advances in geophysical and particularly paleomagnetic studies, and the perfection of the techniques of radiometric measurements, have all contributed to a reasonably well established time scale for this latter part of the Earth's history. Much remains to be done in this field as the events of any one area have not yet been finally correlated with events in other areas. However, the chronology of the later part of the Earth's history is better established than that of many other parts, and even though authors still differ in drawing the limits of the Pleistocene epoch, due to the great confusion arising from placing the classical stratotypes of the Pliocene and Pleistocene epochs within the sequence established from the seabed, the following is the classification used in this chapter. The geomagnetic time scale of the last 5 million years shows that the Earth's magnetic field has been alternately changing from normal to reversed. These epochs were interrupted by minor events in which a reversal of the general pattern of that particular epoch took place. Epochs are, from the youngest to the oldest, Brunhes, 069 million years to present, Matuyama, 2-43-0-69 million years, Gauss, 32-2-43 million years, and Gilbert, 5-4-332 million years. The Gilbert-Gauss magnetic interval was characterized by a great deterioration of the climate noticeable in many areas of the world. See for a review on this subject HACIAL, 1969. This cool episode corresponds with the base of the continental Nebraskan glaciation, as recorded in the Gulf of Mexico, the onset of ice-drafted detritus in the northern Atlantic, and the middle Villafrancian continental fauna. According to several authors, WHO would determine the Pliocene/Pleistocene boundary at the first onset of climatic deterioration. This episode marks the advent of the Pleistocene. However, the adoption of Such a boundary would be inconsistent with the boundary as defined at the International Association for Quaternary Research, INQUA, Congress in 1955, as it would imply that the faunal assemblages of the classical section of Castellarqueto, Italy, should be excluded from the Pliocene. Since this section has had worldwide use in biostratigraphic correlations, the consensus is to keep it in the Pliocene. The boundary is rather fixed at 1 to 85 million years BP, corresponding with the base of the Calabrian and the Olduvai magnetic event of the Matuyama epoch. Recent work has shown that this was a period of warming rather than cooling. The first great Pleistocene glaciations in temperate latitudes occurred c. 700,000 years BP at the Brunhes-Matuyama boundary. This glaciation may correspond to the Alpine Guns. The Pleistocene, therefore, can be divided roughly into two parts, the later representing the glacial era and the earlier a preglacial Pleistocene. The Alpine Riss occurred around 120 to 130,000 years BP, while the WURM started at 80,000 BP. The latter glacial is perhaps the best dated and studied. It lasted up to the Holocene, fixed at around 10,000 years BP. As stated earlier, this chapter attempts to review the most salient physical changes that set over the African continent in response to the climatic changes of the Pleistocene. A continent of the size of Africa includes a number of distinct environments, none of which need have responded in similar fashion or degree to the great paleoclimatic changes of the 360 Pleistocene. The approach, therefore, is to review these changes within the framework of the present-day major climatic regions of the continent. These regions may be classified under two headings: equatorial and subequatorial belts, and the tropical and subtropical belts. Equatorial and subequatorial belts. The equatorial belt covers today the hot and humid Zaire basin of western Africa, characterized by slight fluctuating winds, slight seasonal fluctuations of temperatures and humidity, and frequent cloudbursts and thunder storms. This belt is covered today by typical rainforests. The subequatorial belt covers most of the middle parts of Africa. It is characterized by the prevalence of equatorial type air masses in summer, and tropical type air masses in winter. Winter is dry and only slightly cooler than summer. Most of this belt includes areas with abundant moisture to support a tropical savanna vegetation. The northern and eastern fringes, however, today support a tropical steppe vegetation. As a result of the fluctuations in rainfall in these belts during the Pleistocene, this epoch may be subdivided on the basis of a succession of pluvial and interpluvial stages. The pluvials known as Kagerian, Comitian, Kengerian and Gamblian are believed to represent the subequatorial equivalents of the four major glacial stages of the northern hemisphere, but this has not yet been proved. TWO subpluvial phases, the Mauchalian and Nicarian, have been recognized in the Holocene. The effect of the pluvials can be seen in bigger wadi alluviation and in the higher lake sediments or shorelines left behind in several closed basins as a result of the expansion of the existing lakes. The interpluvial stages are characterized by the expansion of aeolian activity when windborne sands were deposited or redistributed well to the south of the present-day southern limit of mobile dunes, and when radical changes in vegetation took place. Several volcanic peaks in these belts show glacial features at lower elevations than the present snow line, indicating cooler climates in past episodes. In the following paragraphs, examples are given of these changes in some selected areas in equatorial and subequatorial Africa. Lake basins of East Africa. East Africa, and in particular its lake basins, provides the type area of the pluvials and interpluvials proposed for sub-equatorial Africa. The lakes of East Africa lie within the African Rift System. Those which fill the lows of the eastern branch of this rift, with the exception of Lake Victoria, lack surface outlets and are situated in much drier climates. In contrast, the major lakes of the western branch of the Rift Valley are filled to their overflow levels. It must be obvious from the outset that evidence of higher lake levels in a 361 highly seismoactive zone like East Africa must be considered as suggestive, rather than conclusive, possibilities of tectonic displacement of shorelines. Modification of lake overflow levels and tilting of lake basins must be taken into consideration in this extremely unstable area. For this reason the concept of early to middle Pleistocene pluvials has fallen into disuse. Cook, 1958, Flint, 1959a, Zeuner, 1950. Recent studies on East African lake basins have limited the use of this climatostratigraphic evidence to the Gamblian pluvial, where in places tectonically underformed sediments are recorded. However, abundant geological evidence proves beyond doubt that the boundaries of the main rainforests have fluctuated considerably in the past. The great forests of the western drainage basins have been a major factor in conditioning human life throughout the archaeological record. The famous stratified site of Olduvai Gorge in northern Tanzania includes at its base a magnificently preserved vertebrate fauna of undoubted lower Pleistocene age. The climatic associations indicate a period of markedly high rainfall. Kageran or Olduvai. Above these are two formations, indicating respectively a drier interval followed by relatively high rainfall, Olduvai. 2-4. In this particular locality a stratigraphical succession is known, which carries the most complete evolutionary series for the hand axe, from the earliest primitive forms to all the main specialized variants of this tool type of the Lower Paleolithic as known in Europe and Western Asia. The pluvial evidence for the Gamblian in East Africa is primarily based on high strand lines and fossil lacustrine deposits of three formerly contiguous lakes lying to the northwest of Nairobi, Nakuru, Elmancyta, and Naivasha. Naivasha has one high beach level of slightly pre-Upper Paleolithic age, which indicates that the lake had a maximum depth of 200 meters and probably overflowed across a nearby watershed. Since the catchment area of the lake is small and the modern lakes do not exceed 10 meters in depth, this surface is taken as an indication of past wetter climates in East Africa. In a rock shelter overlooking the modern Nakuru and Elmancyta lakes, a well-stratified site with a true large-scale blade industry was found by Leakey in Gamble's Cave in Kenya. The lowest deposit is described as a lake beach shingle resting on the rock floor of the shelter at a height of about 200 meters above the present lake level. The implementiferous deposits lie unconformably upon this shingle, and consist of a loose deposit of ash, dust, bone and obsidian. The associated fauna is obviously of modern type. According to Leakey, the implementiferous levels belong to the end of a period of high rainfall, which he calls the Gamblian after the site in question, the first to follow that of the latest levels at Olduvai, which contained Acheulean implements and a highly distinctive extinct fauna. The classic work of Nilsson, 1931, 1940, on the East African lake basins, presents one of the best documented studies of the past fluctuations of their levels. This author describes high shorelines from Lake Tana, surface level 1,830 meters, the source of the Blue Nile, and records 5 major shorelines to 362 plus 125 meters with a less distinct level at plus 148 meters. Nilsson also shows that 4 lakes of the Rift Valley, Zwei, Abiata, Longana, and Shala, were linked up and temporarily overflowed northward into the Awash River. Paleoclimatological records of Lake Victoria show that the lake was low and without an outlet for a period of undetermined length prior to 14500 BP, at which time open savanna vegetation prevailed. The lake began to rise 12,000 years BP, at which time forest vegetation first appeared around the northern lake margins, but for a short time around 10,000 years BP the level may have fallen to 12 meters below the present level. Lake Victoria was full between 9,500 and 6,500 years BP with an evergreen forest near its shores. The level of Lake Victoria has, in part, been affected by incision of its outlet, but the former low lake levels as well as the pollen sequence were certainly independent of this factor. Butzer and others, 1972, carried out a detailed study of the East African lake basins and gave the radiocarbon dates of some of the sediments of their former beaches. The events and dates of the late Quaternary of Lakes Turkana, Rudolph, Nakuru, Naivasha, and Magadi coincide to a large extent. Lake Turkana, with a contemporary surface area of 7,500 square kilometers, is the largest non-outlet lake in East Africa. Situated in a downwarp zone adjacent to the East African Rift, the lake is fed primarily by the Omo River, which takes its source from the western Ethiopian highlands. Butzer's work shows that the littoral, deltaic, and fluvial beds associated with this lake had a level of about 60 meters higher than the present level at a period about 130,000 years BP, and again 60 to 70 meters higher than the present level about 13,000 years BP. Between this latter time and 9,500 years BP the lake became smaller than at present, and the climate more arid. Starting from this latter date, the lake rose again and fluctuated between 60 and 80 meters above the present level, until 7,500 years BP, when Lake Rudolph shrank to smaller dimensions. This was followed by further higher levels at 6,000 BP. Starting from about 3,000 BP the lake fell to its present dimensions. The evidence from other East African lakes as studied by Butzer and others, 1972, shows a similar late Quaternary history. The Chad Basin deserves special attention because of its location on the southern edge of the Sahara and the great surface area of the inland sea that filled the entire basin during the Pleistocene. The present-day Lake Chad is a relic of this old inland sea. See Mono, 1963, and Butzer, 1964. References. The basin derives its waters from Central African savannas. The present lake surface stands at 280 meters with an area fluctuating between 10,000 and 25,000 square kilometers, a mean depth varying between 3 and 7 meters, and a maximum depth of 11 meters. The lake is separated from 2 large depressions, the Bodal and Kajurub, by a low 363 divide, breached by the dry valley of the Bahr el Ghazal. The lowest strand line of the present Lake Chad, at 4 to 6 meters, would permit water to overflow into the 500 kilometers distant Bodal Depression. At its highest stand at 332 meters, the Pleistocene lake ancestral to Chad formed conspicuous shore lines at 40 to 50 meters and so occupied an area of 400,000 square kilometers. Intermediate, less continuous shorelines are also recorded. Grove and Pulian, 1963, show that the great loss of the present lake by evaporation is largely balanced by the inflow of the Lagan and Sherry from the south. These authors estimate that evaporation from the Pleistocene lake may have been 16 times greater, so that it must have received annually a volume of water equal to one-third the annual discharge of the Zaire. Butzer, 1964, states rightly that the ancient Chad Sea represents, therefore, an excellent piece of evidence in favor of greater precipitation in subhumid tropical latitudes. Unfortunately, the shorelines of the different parts of the basin have not been correlated. The 600 meters thick Pleistocene section which underlies parts of the basin shows the complexity and long history of this inland sea. In the case of Nigeria, Grove and Pulian, 1963, suggests that a 52-meter lake stage during the upper Pleistocene was followed by a dry climate, with extensive dune formation on the former lake plain. Re-establishment of a stream network at a later date was followed by another wetter period with a rise of lake level at least 12 meters during the Holocene. It can thus be stated that two poorly resolved positive lake movements appear to have occurred prior to 21,000 years BP. They were followed by a long interval of desiccation and Aeolian activity until shortly before 12,000 years BP, when the lake began to expand again. The lake reached a maximum level with at least intermittent overflows at around 10,000 years ago. This high level lasted until about 4,000 years BP. The Upper Pleistocene Holocene history of this internal sea, therefore, seems to coincide almost in detail with those of the East African basins. The Sud of southern Sudan represents, in the opinion of the present author, another great internal sea which probably had a similar history to the Chad Basin. The Sud is a defunct lake which is assumed to have covered the Sud region of the upper reaches of the Nile and to have extended beyond to the White Nile, parts of the Blue Nile and Bahr el Ghazal. The idea of the existence of this former lake stemmed from the irrigation engineers working in Egypt, Lombardini, Garstin, and Wilcox, and was elaborated by Lawson, 1927, and Ball, 1939. All were impressed with the flatness of the plains of central and southern Sudan and recognized that a small increase in the levels of the Niles would flood extensive areas. Sud Lake was estimated by Ball to have occupied an area of 230,000 square kilometers, the area within the 400-meter contour, the elevation of Shambay where the present Sud growth of the Bahr el Ghebel begins to spread widely over the alluvial plains. This area is covered by the Ern Ruwaba formation, which has been recently mapped and which is made up of a long series of fluviatile, deltaic, and lacustrine deposits. The highest point in this 364 formation exceeds 500 meters in elevation, and this far exceeds the lowest overflow point of the Sabaluka Ridge to the north of Khartoum, 434 meters, which is supposed to have formed the northern boundary of the lake. As has been pointed out by said Ms., this ridge lies in one of the major fault lines, which bounds the southern edge of the highly seismic Nubian Massif. This elevation, for this reason and for reasons pertaining to incision of Sabaluka gorge by later erosion, cannot be taken as representing the height of the ridge during the filling of the lake. Further complications arise from the fact that during high floods the Blue Nile waters rush into the Nile, causing a damming effect on the waters of the White Nile. Even though the history of Lake Sud is not known in detail, evidence of its extensive reach is obvious from the 382-meter beach skirting large areas of the White Nile. Like the Chad Basin, it seems to have been very extensive between 12,000 and 8,000 years BP. To the north it must have been 50 kilometers wide, Williams. 1966. The lake thereafter shrank, and at about 6,000 years BP annual rainfall had diminished to about 600 millimeters near Khartoum, and the level of the White Nile had fallen to 0-5-1 meter above its present mean. High level glacial phenomena. The former glaciation of Africa is closely related to the glaciers of the present day, which, in turn, are dependent chiefly on the distribution of very high land. With one exception, the Atlas Mountains, all known glaciated highlands, lie in East Africa within a few degrees of the equator. Altitudes range from nearly 3,900 meters to 6,100 meters. Flint, 1947, 1959a, gives a summary of the significant data of these glaciated areas and states that the snowfall that nourished the glaciers was probably the orographic precipitation of moisture brought by maritime air masses moving eastward from the South Atlantic and, to a lesser extent, moving westwards from the Indian Ocean. The altitude of Mount Kenya, lat. 0° Ios, long 37° I8e, is 5,199 meters. And the present snow line is at 4,600 meters, the maximal Pleistocene snow line is estimated at 900 meters, Flint, 1959a. Mount Kilimanjaro. In Tanzania, lat. 3° 05, long 37° 22 minutes east, has an altitude of 5,895 meters and seems to lie at present just above the climatic snow line. The lowest Pleistocene snow line was above 1,300 meters, Flint, 1959a. Mount Elgon. Uganda, lat. 1° 08 n, long 34° 33 minutes east, has an altitude of 4,321 meters and lies at present well below the climatic snow line. During the Pleistocene it was glaciated. Mount Rwenzori, lat. 0° 24 n, long 29° 54 minutes east, has an altitude of 5,109 meters and its modern snow line lies at 4,750 meters on the western Congo side and 4,575 meters on the eastern Uganda side. Pleistocene glaciers extended down to 2,900 meters on the western side and to about 2,000 meters on the eastern side. The Ethiopian highlands are not glaciated today, but the semi-N 365 mountains, lat. I 3° I4 n, long 28° 25 minutes east, seem to have been glaciated during the Pleistocene. Nilsson, 1940, demonstrates two former glaciations in some of the peaks of this range, altitude c 4,500 meters, with climatic snow lines at 3,600 to 4,100 meters and 4,200 meters. A glacial retreat correlated with the late Pleistocene corresponds to a snow line at 4,400 meters. Nilsson, 1940, also describes a late Pleistocene glaciation at Mount Kaka, lat. 7° 50 n, long 39° 24 minutes east, with a snow line elevation estimated at 3,700 meters. Glaciations from other volcanic peaks in Ethiopia which at present lie well below the snow line have also been reported. Mount Gunna, lat. U° 43 n, long 38° I7e, AMBA for it, lat. I0° 53 n, long 38° 50e, and Mount Chiolalo, lat. 7° 50 n, long 39° IOE. The evidence is convincing that the equatorial and subequatorial belts of Africa were glaciated at least twice and that they were considerably cooler during the WURM. In addition to the glacial phenomena of some of the peaks of this belt, solifluction and soil frost activity have been found in Ethiopia. 4,200 to 9,300 meters. According to Budel, 1958, the lower limit of solifluction during the WURM reached 2,700 meters. Glaciofluvial deposits have also been recorded in many areas of equatorial Africa. The deposits of Mount Rwenzori have been studied by de Heinz Ellen, 1963, and were found to grade into the Gamblian terraces of the Semliki River. The Semliki, joining Lakes Edward and Albert on the Zaire-Uganda border, possesses massive beds of cobbles, gravel, sands and red soil sediments which were alluviated together by colluvial deposits. De Heinz Ellen shows that the Sango and Lupamban terraces are contemporary with the glaciofluvial deposits of Mount Rwenzori. Tropical and subtropical zones. The modern tropical zone of Africa has easterly prevailing winds and noticeable seasonal fluctuations of air temperature. The western part of this belt, which lies on the Atlantic coast, has stable trade winds, relatively cool temperature, high air humidity and is almost rainless. The remainder of this belt covers the great deserts of the north and south of the continent. These are hot arid regions with a great daily range of temperature and absolute maximum air temperature. The subtropical zone covers the northern and southern fringes of the continent and is characterized by having tropical air masses prevailing in summer and moderate type of air masses prevailing in winter. The seasonal temperature and rainfall differ considerably. Those regions with Mediterranean climate possess clear calm weather in summer and are rainy in winter. The Sahara. The Sahara represents perhaps the most salient fact of this zone. Stretching 366 for more than 5,500 kilometers from the Red Sea to the Atlantic and having an average width from north to south of more than 1,700 kilometers, it covers almost 1/4 of the area of the entire African continent. Across the whole of this area, the rainfall, though very unevenly distributed, is in places over 100 mm/annum, and on an average very much less. As a result, no perennial streams are known in the Sahara with the exception of the Nile, which derives its waters from sources far beyond the desert. Such ephemeral and permanent pools as do result from surface drainage are of no more consequence to present-day human life than are the wells and springs deriving their water from subterranean sources. The Sahara consists of a rigid nucleus of Precambrian rocks overlapped by Paleozoic to Cenozoic sediments which remain stable for most of the Phanerozoic. It is only in the Atlas Range from the Gulf of Gabes to Morocco, and in the Red Sea hills east of the Nile that a certain degree of crustal warping and folding took place. A similar crustal disturbance is also noted in Cyrenaica and in the subsurface of coastal North Africa. These folding movements belong to the alpine system of mountain building of late Cenozoic and Quaternary age. The Red Sea Range, on the other hand, is connected with the crustal movements and the spreading of the Great African Rift Valley. The greatest area of relief is that of the Atlas Massif, which has the highest rainfall. Minor elevations exist in Cyrenaica and in the Ahaggar and Tibesti Massifs of the Central Sahara. These latter form two regions of mountainous topography joined by the low saddleback ridge of Tummo. The area has an average elevation of 2,000 meters, although peaks as high as 3,600 meters are known. Most of the peaks are made up of volcanic rocks which formed during a long and protracted period of volcanic activity, extending well into the Pleistocene. Smaller areas of volcanic rocks are seen in the massifs of air, southwest of the Ahaggar, the Oenid which rises abruptly halfway between Tibesti and the Nile, Mount Ader, and others. At the present time these high massifs have an insignificant effect on the climate, but there is abundant geological evidence that the Sahara region was far less arid during several episodes of the Pleistocene than at present. the greatest force of erosion in the desert today, as it always has been. During the long periods of aridity, is wind erosion, which is responsible for the formation of the Great Petty Plain of the Sahara. The windborne coarse sands resulting from this erosion accumulate in fields which are known as erg or reg, while the finer materials are carried high up in the air, where they remain in partial suspension for long periods of time. The bare rock surfaces, which result from the processes of desert erosion, are known as the hamada. Basins and depressions occur on these surfaces. These range from small shallow basins to enormous depressions reaching in places as low as 134 meters below sea level, Catara Depression. These depressions became, in times of pluvials, the site of alluviation, and when they were lowered down to the groundwater level, the sites of spring activity. 367. And lacustrine sedimentation. The large depressions lie mostly on the edge of escarpments, but are seldom encircled by scarps on all sides. Because they form internal basins with no outlet, they were certainly formed by wind action. Views differ as to the geological history of the Sahara. Certain authors claim that it was a desert for as long a period as the entire Phanerozoic, wet periods representing abnormal fluctuations in an otherwise continuous history of aridity. Others claim that the desertification is a recent phenomenon pertaining to the present-day pattern of distribution of air masses. Evidence that the desert in the recent past enjoyed wetter climates is overwhelming. Evidence ranges from the pattern of distribution of animals to sedimentary features that cannot be explained except by assuming a wetter climate in the past. Certain indigenous Central African animals are known to have lived in the desert, and these could not have migrated there except via corridors of vegetation or water. Central African crocodile species have been found in waterholes in deep ravines of the Ahaggar and Tibesti massifs. The African mudfish has been recorded as far north as the oasis of Biskra in southern Tunisia. The drainage features of the desert indicate previous greater rainfall. West of the Ahaggar, a huge plain extends to a few hundred kilometers from the Atlantic, sloping gently from the margins of the El Jub Depression. In the past, this clearly formed the evaporation basin of an extensive system of streams. Lines of drainage leading from the southern slopes of the Atlas southward, of which Wadi Saoura has been traced for more than 500 kilometers, are significant. Here is a valley which in the past carried sufficient volume of water to remove the Aeolian sands that today choke its middle reaches. From the Red Sea hills some wadis are as much as 300 kilometers long and they drain areas close to 50,000 square kilometers. One of these, Wadi Karat Debouching in the Komombo plain to the north of Aswan, is fringed by alluvial thinly bedded fine-grained silts of more than 100 meters in depth. These must have certainly been deposited by an active perennial river of considerable volume. Extensive work on the climato-stratigraphic divisions of the Sahara is reviewed by MONOD, 1963. He cites the work of Alaman, Chavalan and Margit, 1965, on the classic basin of the Saoura, for which the following periods have been suggested, from the oldest to the most recent. 1. Villafrancian pluvial, equals Adian sand, gravel, conglomerate. Deposits of red-pink color resting upon older rocks. 2. Arid post-Villafrancian, talus breccias, sandy loess, etc., topped by a red-brown paleosoil. Crudely worked pebble tools have been reported from one site in Algeria. 3. First Masurian pluvial, Q_/A conglomerates and sands. 4. Arid post-Masurian, sandy clay deposits, Aeolian sands, scree. 368. 5. Second Diluvian, or Ugarian I, pluvial, Q/B conglom. Erats, very evolved pebble culture possibly of the Middle Acheulean. 6. Arid post-Diluvian, erosion. 7. Third pluvial, or Ugarian II varicolored pebbles and sands. Or a red-brown paleosoil. 8. Arid post-Diluvian, erosion. 9. Fourth Saurian pluvial, OJ gray-green sands, rubble, black. Fossil soils, Neolithic. 10. Post-Saurian pluvial, sandstone crust, Neolithic. 11. Girian wet episode, Neolithic. According to Arambarg, 1962, the four main pluvials, the Masurian, Ugarian I, Ugarian II and Saurian, of the Northwest Sahara may correspond to the East African pluvials, the Kagerian, Olduvai, the Comitian, the Kangerian and the Gamblian. The Girian of Northwest Africa may correspond to the post-Gamblian humid stages. The Nile. The Nile has attracted the attention of scholars for a long time, and the literature dealing with its various aspects is enormous. The prehistory and the geological evolution of this river have been recently subjected to intensive study by Vendorf, 1968, Butzer and Hansen, 1968, de Heinz Ellen, 1968, Vendorf and Schild, Ms., Jijengak, 1968, and said. In press. The following notes are the result of a study by the last author. Based on field mapping of the fluviatile and associated sediments of the Nile Valley and the examination of a large number of boreholes, both deep and shallow, which were drilled in the search for water or oil. It is possible to conceive of the Nile as having passed through 5 main episodes since it cut its channel in the Upper Miocene. Each of these episodes was characterized by a river which drew the larger part of its waters from sources outside Egypt. Towards the end of the first 4 episodes, the last is still current, the river seems to have declined or ceased entirely to flow into Egypt. These major recessional phases were accompanied by important physical, climatic, and hydrological changes. In the first of these recessions, the sea seems to have advanced inland, forming a gulf which occupied the excavated valley as far as to the south of Aswan. During the second recessional phase, which started with the advent of the Pleistocene and continued for more than 100,000 years, a hyper-arid climate developed over Egypt which was converted into a veritable desert. During this episode wind action was most effective, the great depressions of the desert started forming and the carpet of vegetation which covered Egypt for almost all the Pliocene was destroyed. There is evidence that during the early part of this episode there occurred for a relatively brief period an intensive pluvial phase. During this pluvial there occurred ephemeral torrential rivers which drew their 369 waters solely from Egypt. The 5 rivers which occupied the valley of the Nile since its excavation in Upper Miocene times are termed the Eo-Nile, Tmua, Paleo-Nile, T-Plug, Proto-Nile, Q_, Pre-Nile, Q_2, and Neo-Nile, Q_3. The climatic fluctuations thus recorded in Egypt may be summarized in the following table from the most ancient to the most recent. I. Pliocene pluvial, T-Plug, 3 to 32 to 185 million years BP. The seti. Ments of the Paleo-Nile are mostly in the form of fine-grained, thinly bedded elastics and clays, known in the subsurface in the valley and also in outcrop along the wadi fringes. The sources of the Paleo-Nile were in Egypt as well as in equatorial and subequatorial Africa. There was an important carpet of vegetation, intensive chemical disintegration and a reduced runoff. Rainfall was probably evenly distributed over the year. 2. Lower Pleistocene hyperarid phase, T+/Q_I interval, 1 to 85 to 070 million years BP. Egypt became desert, the Nile Valley became seismically active and wind action was at its maximum. It was interrupted by a short pluvial, Armont, resulting in the formation of gravel beds alternating with graded sand or marl. Beds embedded in a yellow-red matrix and topped by a cemented red breccia. NO tools are found in these deposits. 3. Idfopluvial, Q.I, 700,000 to 600,000 years BP. The climate of the Paleo-Nile returned, the Proto-Nile, with recurrence of Paleo-Nile climatic conditions, the Proto-Nile with similar sources to that of its predecessor broke into Egypt and cut its course on bedrock in a westerly and parallel direction to that of the modern Nile. River sediments took the form of gravel beds made up of quartz and quartzite pebbles embedded in a matrix of red brick soil. Sediments were derived from a deeply disintegrated and highly leached terrain. In the deserts, comparable sediments of wadi conglomerates are known in the form of inverted channels. Rolled implements, of possibly Chellean tradition, are recorded from these deposits. 4. Pre-Nile arid phase, Q_2. 600,000 to 125,000 years BP. An effective new river broke into Egypt deriving its waters from the Ethiopian highlands. The mineral composition of the sediments of the pre-Nile shows the presence of the mineral augite, characteristic of modern Nile sediments derived from the Ethiopian highlands, as well as abundance of the mineral epidote, which distinguishes these deposits from those of the succeeding Neo-Nile and modern Nile. There were conditions of minor pluvial in the early phases of this interval. 5. Abbasia pluvial, 125,000 to 80,000 years BP. The pre-Nile stopped flowing into Egypt, the sources of the river being cut by the 370 elevation of the Nubian Massif. This pluvial is characterized by polygenetic gravels derived from Egyptian Red Sea hills whose surface was deeply disintegrated but little leached. Abundant late Acheulean tools are found in these gravels. 6. Abbasia/Macadma arid phase, 80,000 to 40,000 years BP. Erosion. 7. Macadma subpluvial, 40,000 to 27,000 years BP. Sheet wash. With implements of Sangoan Lupamban tradition are known on several slopes of the eroded bed of the pre-Nile. In the deserts, implements of Mousterian and later of Aterian tradition are ubiquitous. 8. Neo-Nile arid phase, Q_3, 27,000 to present. A river, Neo-Nile, with similar sources and regimen to the modern Nile broke into Egypt. The Neo-Nile passed through recessional phases which formed subpluvial maxima, Deir el-Fakuri subpluvial, 15,000 to 12,000 BP, Dishna subpluvial, 10,000 to 9,200 BH, and Neolithic, 7,000 to 6,000 BP. It can thus be stated that the sediments of the Nile Valley are not very different from those recorded from the Sahara. It is possible, in fact, to generalize and state that the Egyptian Armont pluvial may correspond to the northwest Saharan Villafrancian pluvial, the Idfa to the Masurian, the Abbasia to the Ugarshan, the Makhadma to the Saourian and the Deir el-Fakuri, Dishna and Neolithic to the Girian. It must be noted, in conclusion, that the African pluvials must have been due to world climatic fluctuations that, in theory, should correspond to the glacials of Europe and North America. Even though this has not been proven, it is possible to state that, in general, the Ugarshan, of Northwest Africa, the Abbasia, of Northeast Africa, and the Kangaran, Old of A4, of East Africa can be correlated with the Alpine Riss. Further work, particularly in the fields of paleomagnetic and radiometric measurements, is needed before any definite conclusion can be drawn. Part 2H 4. Introduction. The last few million years of the past of our globe have been marked by a repetitive pattern of extreme climatic changes. The most outstanding phenomenon, one which has been well known for more than a century, is undoubtedly the extraordinary advance and recession of the glaciers at high latitudes and altitudes. This phenomenon reflects the considerable glaciations which had a profound influence on the environment and life of hominids. In Africa, the most spectacular aspect of the quaternary climatic variations was the extension of lacustrine areas in zones which 371 are now arid, and the development of great stretches of dunes in regions which now have a more humid climate. Over the past decade, considerable progress has been made in the dating of climatic events occurring during the last 30,000 years, thanks to the systematic use of carbon-14. In regard to those occurring during the last few million years, the dating of magnetic reversals, based on radiometric measurements by the potassium-argon method, allows of correlation with other regions at a distance where such methods are also used, particularly ocean regions. Before these methods of chronological correlation came into use, quaternary stratigraphy was based mainly on the succession of climatic events, regarded as a chronological framework. Correlations from one region to another were established by paralleling successive epochs, characterized by similar climates. For instance, a rather arbitrary correspondence had been suggested between the European glacial periods and the African pluvial epochs. This suggestion was opposed by several authors, among others, Tricart, 1956, Belaut, 1952a. The answer to this question of correlation has proved to be much more complex in reality, and it is only beginning to be glimpsed now that the mechanisms of global climatology are better known and a detailed climatic chronology has been established for the last few thousand years. Magnetostratigraphy and radiometric dating. In addition to the comments made above by Rushdie said, lithostratigraphic, biostratigraphic and chronostratigraphic units have frequently been confused, with the result that the lack of precision in definitions has produced a nomenclature which is often difficult to use in a more exact chronological framework. Then again, certain features of the magnetic field, such as slope or intensity, seem to be very closely related to climatic features, Fig 16.1 and 16.2, from Volin et al., 1974. Quaternary glaciations and dating. It is likely that at least 12 considerable cold changes have been recorded in the continuous deposits accumulated at the bottom of the oceans during the Quaternary, see Fig 16.2. Only about 8 have been recognized in the continental deposits of northern Europe. Fluvial terraces and glacial deposits of the Alpine region are related to 4, or 6, generally accepted glaciations, Gunz, Mindel, Riss, Wurm, and Donau, Biber, each of which may comprise a number of stages. The discontinuous nature of the continental evidence makes it difficult, and often illusory, to correlate glacial periods in distant regions when they are not situated with certainty on a magnetochronological or radiometric scale. In point of fact, the accepted chronology for the alpine glaciations is vague. The terms Guns, Mindel, Riss, Wurm and Biber have been used in various regions to denote formations which are not synchronous. Thus, according to the potassium-argon dating of the volcanic rocks intercalated in the Rhine terraces, the formations known as Mindel I and II appear to be 300,000 and 260,000 years old, and the terraces known as Guns I and II 420,000 and 340,000 years old. But the same term Guns is sometimes applied to the cold period preceding the Cromerian, which would therefore be from 900,000 to 1300,000 years old, coinciding with the cold period preceding the Jaramillo event in the undersea cores. According to the latter interpretation, the Donau, the preceding cold period, should include the Gilsa event and be the equivalent of the Eburonian. It will be understood from this example how dangerous it is to transfer from one region to another a chronology based on continental climatic successions, if one retraces the number of cold occurrences identified and reviews the arbitrary nomenclature attributed to them. The divergences render precarious any correlation of evidence of alpine glaciations with the successive cold changes measured in ocean cores. Complete and continuous recording of all climatic phenomena, on the one hand, and of magnetostratigraphic and radiometric references, on the other, is essential if a stratigraphy scale is to be worked out even approximately, and if valid comparisons between two regions are to be made possible. Matthew Brunhe's magnetic reversal, 690,000 years, was identified in the Cromerian stage by means of palynology, and the Gilsa occurrence 790,000 years, in the Eburonian stage, Van Mont Franz, 1971. Quaternary transgressions and dating. Each glaciation brings about a glacioliostatic regression of the sea, which may amount to 100 meters or so. Marine regressions brought about by the melting of ice therefore make it possible in littoral zones to link climatostratigraphic chronology with the chronology of marine cycles. In regions where the marine formations are Coral Line, Barbados, Bermudas, New Guinea, the Red Sea, dating by methods based on the disequilibrium of uranium applied to the aragonite of corals has made it possible to ascertain the age of marine transgressions from the last interglacials, 200,000, 120,000, 105,000, 85,000 years BP approximately. Within the margin of physical error of the various radiometric dating methods, it is observed that these high sea levels correspond fairly well with the higher temperature phases indicated by the marine microfauna, pollens, and oxygen isotopes. 375. Mechanisms of global climatology. Climate does not constitute a simple means of chronological correlation. Owing to the complexity of the factors entering into it at any given moment, or over a period lasting centuries or millennia, there can be no question of using data which have not been properly dated as stratigraphy or chronological criteria. Facts leading to these observations are of two kinds. A knowledge of the global evolution of climate over a few decades or a few centuries, on the basis of historical data, shows how complex the problem is on a global scale. One has to know the evolution of all factors, the solar constant, ocean circulation, the situation of polar fronts, distribution of temperatures, rainfalls, not only their averages but their variability. 2. A knowledge of the variations of certain climatic factors over the past 25,000 years or so, and of the Pleistocene and Holocene. Obtained by means of radiometric measurements, shows us, on the one hand, the rapidity of the changes concerning which reliable evidence exists, and, on the other hand, the complexity of correlations on a global scale. The time scale taken into consideration then plays a major role. The climatic system, as defined by the National Academy of Sciences, Washington, 1975, is made up of the properties and processes which are responsible for the climate and its variations, thermal properties, temperature of air, water, ice, soils, kinematic properties, wind, ocean currents, ice movements, etc., aqueous properties, humidity of the air, clouds, surface water or groundwater, ice, etc., static properties, pressure, density of the oceans, salinity, etc., as also the geometric limits and constants of the system. All the variables in the system are interconnected by the physical processes which occur in it: precipitation, evaporation, radiation, transfer, convection, turbulence. The physical components of the climatic system are atmosphere, hydrosphere, cryosphere, lithosphere, biosphere. The physical processes responsible for climate may be expressed quantitatively by dynamic equations of movement, the equation of thermodynamic energy and the equation of continuity of mass and water. Climatic variations will be complex in as much as there may be considerable interaction between the elements in the climatic system. So the causes of climatic changes are many and varied, particularly having regard to the time scale involved and the interaction mechanisms, feedback. Oceans play a considerable part in climatic changes through the processes at the air-water interface, which govern exchanges of heat, humidity and energy. These preliminary considerations go to show that the climatostratigraphy 376 of the Quaternary has been a stage, a necessary approximation, but that it is gradually making way for an attempt to understand the mechanisms involved in particular situations over different periods of time. For this reason, several examples of recent results bearing on the present era, the Holocene, the Pleistocene and the Pliopleistocene, will be examined. Climatology in Africa today and in the recent past. In Africa, the annual rhythm of alternation of a dry season and a rainy season in the intertropical zone is bound up with the displacement of the intertropical convergence zone, ITCZ. As summed up recently by J. Maley, 1973, and L. Dorias, 1974, the ITCZ represents the place where the monsoon, humid air coming from the equatorial regions or the maritime trade wind from the southern hemisphere, and the harmattan, dry air from the Sahara, meet. The ITCZ, which lies approximately west-east, moves from the south to the north during the spring and the first 2 months of summer, then from north to south. This seasonal oscillation occurs between 4 degrees north and 2023 degree N. The surface of discontinuity between the humid air and the dry air slowly rises north to south. The humid bank of the monsoon is only a very thin cold corner towards the north in summer, not giving much precipitation. The humid air has to be from 1200 to 1500 meters thick for precipitations of any importance to occur. These conditions are found only from 200 to 300 kilometers south of the ITCZ, L. Dorias, 1974. The position of the ITCZ varies considerably, not only from one season to another, but also from day to day, as a result of the field of pressure of the whole of Africa and the Atlantic Ocean. As shown by P.P.D. Laborde, 1970, the original thrust from the southern Atlantic, combined with the activity of the South Polar Front, represents the essential Motive force pushing the convergence zone northwards. The southward. Withdrawal of the ITCZ, in September, would then be due to the weakening of the South Atlantic anticyclone and the influence of the northern hemisphere. The occasional intervention of northern air dried after its transit over the Sahara gives only a little rain on the Sahara mountain ranges. Conversely, the southerly air, after crossing the ocean, brings potential humidity. The present climatic crisis in the Sahel zone is due to the fact that the ITCZ has remained from 30 to 40 farther south than its average position. During the wet decade of 1950 to 9, on the other hand, the Sahara shrank. As J. Maley has shown, 1973, the humid phase coincided with a drop in the maximum temperatures on its southern borders. NOW, the colder the polar air, the stronger the polar fronts and the farther they extend towards the equator. In this connection, Maley, 1973, distinguished two mechanisms, namely, that of the glacial periods and the one made evident in our own time. In the former case, the area of the ice sheets in the northern hemisphere increased considerably, while the 377 Antarctic ice sheet would appear to have varied little. The North Polar Front then had a preponderant influence, driving the monsoon far south in summer. Aridification then went hand in hand with glacial expansion. With the warmer temperatures of the Holocene period before 5000 to 4000 BP, the center of polar action weakened. During the northern summer, the regression of the North Polar Front favored the extension of the monsoon north of the equator, while the South Polar Front drove the subtropical anticyclones towards the equator. During the northern winter, the polar front could again extend its action over the Sahara and bring rain. The occurrence of rain both in summer and in winter would explain the humid climate which prevailed in the southern Sahara and the receding of the desert during the first half of the Holocene. Over the past 5,000 years, the regression of the Arctic ice sheet has reduced the strength of the North Polar Front, while the center of action in the Antarctic has also diminished in strength. The thrust of the monsoon and the diminishing effects of the northern polar air on the Sahara at the same time would thus explain the gradual aridification of the Sahara. These meteorological mechanisms may help us to understand the climatic changes which occurred in Africa during the Quaternary dating and climates over the past 25,000 years. The last 25,000 years of the Quaternary, and of the Pleistocene and Holocene, afford a recent and now well-documented example of a vast glacial advance and of the ensuing recession up to the present interglacial. During the same period, the intertropical regions underwent extreme aridity, followed by a humid phase, then aridification again. This is the only climatic fluctuation which can be studied over a period of several centuries or several millennia, permitting comparison of the elements of the climatic system and its variations in many regions of the globe situated at nearly all latitudes. In addition, for this period, the indications supplied by pollen diatoms and fauna identical to the modern species allow of quantifying the magnitude of the variations of the geographical environment with precision. Besides, the average sea level is well enough known for us always to be able to have some idea of the general volume of the ice and the isotopic relationships of the oxygen in the principal reservoirs, oceans, ice, sea. Morner, 1975. As regards the African Sahara, since the first comprehensive surveys based on radiocarbon dating, Butzer, 1961, Mono, 1963, 4, 1967 and 1969, the most recent studies which can serve as a basis for a detailed chronology of climatic variations are those of M. Servant and S-servant. In the Chad and Niger, F-gas, in Afar, and of the teams of Van Zinderan, Backer and Livingstone, of Richardson, of Williams, of Wickens, and so on in East Africa. Their findings are comparable with those of many surveys. In regions in high latitudes, in particular those of Velichko, Draimanes, 378, and so on. The Atlantic Ocean region is known as a whole through the work of the CLIMAP1 group and McElntyre, while the Southern Hemisphere is known through the publications of van der Hammen, Williams, Bowler, and others. To situate the evolution of the climate of Africa over the past 25,000 years. In a global perspective, several chronological stages may be distinguished. 25,000 to 18,000 years BP. High latitudes. The period of time covered by the years 25,000 to 18,000 BP corresponds to the end of the maximum extension of the ice sheets in the northern hemisphere. This last extension of the WURM glaciation, Wisconsin, Weichsel-Waldi, covered with ice an area representing from 90 to 95% of that covered during all the previous quaternary glaciations. Flint, 1971. It is thus a very representative model of a glaciation. In periglacial zones the permafrost, soil permanently frozen all the year round, seems to have been more extensive than it was during other glaciations, Velichko, 1973 and 1975. The presence of this extensive permafrost on the continents would appear to have been associated with sea ice, also very extensive in the Arctic oceans, which was a factor in reducing evaporation at the air-sea interface oceans. Combined with the reduction of free surface due to sea ice, the lowering of mean sea level, going down from about 50 to about 100 meters, contributed to reducing the area of the oceans by a further 10% or so. At the end of the period under consideration, nearly all the continental shelves had emerged. Research workers in the CLIMAP group, McElntyre et al., 1974 and 1976. Hayes, in CLIMAP, and so on, have been able to construct charts of the temperatures of the surface waters of the Atlantic Ocean for the time of the glacial maximum, 18,000 BP. Fig 16.3. In comparison with charts for existing situations, which are those of an interglacial, these charts show a general average of temperature differences which is only 2 to 5 degrees between the glacial maximum and the present interglacial. However, the distribution of temperature differences shows a maximum at medium latitudes, differences of from 6 degrees to io degree, and much smaller differences, less than 30, at intertropical latitudes, Fig 16.4 and 16.5. For instance, at the point 50 degrees north 30 degrees west, the surface temperature was from 7 to 3 degrees to 12 to 7 degrees lower in winter 18,000, or 17,000, years ago than it is at present. In summer the difference dropped from 1 to 2 to 6 to 6 degrees, CLIMAP, 1974. In both hemispheres the migration of polar waters was the dominant factor in this glacial epoch. In the northern Atlantic, the polar waters came down as far as the 42nd parallel, from a position near the present one, about 60° N, giving rise to a rapid temperature gradient south of the 42nd parallel, which was therefore the probable axis of the westerlies in the glacial epoch. South of this limit the pattern was much the same as it is now, but it is observed that the isotherms, running parallel to the coasts of Africa, reveal the existence there, particularly in winter, of relatively cool waters due to an increased upwelling. Gardner and Hayes, 1975. The polar fronts and the axis of the westerlies moved more than 2,000 kilometers towards the equator in the North Atlantic and only 600 kilometers in the South Atlantic. In the Pacific Ocean the polar fronts seem to have moved very little in glacial periods. This would explain the diminished penetration of the monsoon over the Sahara. See Maley, 1973, pages 7-8, and the arid state of the Sahel zone at the end of the glacial period. In the southern Sahara and the Sahel regions the general evolution of the climate over the past 25,000 years shows a fairly similar trend from the Atlantic coasts to the Red Sea. This period of time comprises the end of a humid epoch of the Upper Pleistocene, which lasted from about 30,000 to 20,000 years BP, and the beginning of an arid epoch, which ended around 12,000 BP. The study of lacustrine deposits in the Chad Basin has shown that the relationship between precipitation and evaporation, P/E, was sufficient to enable quite extensive lakes to remain in existence from 40,000 years BP to about 20,000 years, M. Servant, 1973. During the ensuing 8 millennia, the arid zone extended, spreading more than 400 kilometers farther south than its present limits. This transition from a lacustrine episode to a very arid epoch is also observable in the deposits of the Afar Lakes, where F. gas showed the existence of 3 lacustrine epochs in the Upper Pleistocene. Between 20,000 and 17,000 years BP the lacustrine environment deteriorated and the dried-up bed of Lake Abaí was occupied by gramineae, gas, 1975. Reviewing the most recent literature, M. Servant, 1973, and F. gas, 1975, note a quite comparable evolution in the case of other East African lakes at various altitudes and latitudes, the work of Richardson, Kendall, Butzer and others, Grove and others, Livingstone, on Lakes Turkana, Nakuru, Naivasha, Megadi, Albert, etc. This comparison is summed up in Fig 16.6, which shows a fairly parallel evolution for 12 African lakes. 18,000 to 12,000 years BP. High latitudes. In regions at high latitudes this period corresponds to the end of the glacial maximum and to the deglaciation. The ice caps which covered eastern North America and Scandinavia and which reached their greatest extent between 22,000 and 18,000 years BP began to melt immediately after that time. That of the North American Cordillera reached its maximum only 14,000 years BP and disappeared around 10,000 years BP. The general deglaciation began, therefore, around 14,000 years BP. In the southern hemisphere, on the other hand, the continental ice cap in the eastern Antarctic seems to have varied little, while the one in the western Antarctic, with its base below sea level, seems to have dwindled quite considerably. National Academy of Sciences, Washington, 1975. Oceans. The huge surfaces covered with sea ice certainly disappeared with the very rapid rise of the sea level following deglaciation. This rise attained 1 to 5 meters per century on the average between 15,000 and 12,000 years BP, by which time half, if not two-thirds, of the rise had occurred. At the same time, the polar waters of the Atlantic returned to more northerly latitudes. Africa. The great aridity of the period comprised between 18,000 and 12,000 years BP, which extended over a large part of Africa, is the best documented phenomenon. It is well evidenced by the graphs showing the evolution of lake levels in Niger and Chad, Servant, 1973, in Afar, Gas, 1975, in Sudan, Williams, 1975, Wickens, 1975, and so on. The disappearance of vegetation enabled the winds to drive the dunes forward from 400 to 800 kilometers in the direction of the equator and on the emerged continental shelves. There is no doubt that over several millennia, the Sahara, thus extended, constituted a more formidable barrier to man than does the Sahara of today. This aridification seems to have been extremely general, and there are many indications that the intertropical zones as a whole dried up to some extent in Africa, Diploe, Van Zinderen, Bakker, etc. in Williams, 1975, and in Asia, particularly India, Singh, 1973. Williams, 1975, recently reviewed the literature concerning this arid epoch and showed its exceptional and approximately synchronous extension. Mediterranean Basin. Although the evolution of the climate during the last glaciation, some 100,000 years ago, seems fairly complicated in the Mediterranean Basin, c. p. 392 below, palynological findings, Bonatti, 1966, and pedological findings, Rodenberg, 1970, indicate that at the glacial maximum the climate was dry and cool. The Mediterranean zone was occupied by a very dry steppe between 16,000 and 13,000 years BP, and calcareous crusts developed on the soil's Solheim hemisphere. In Australia, the study of pollens indicates that there was a gradual drop in temperatures until about 18,000 or 17,000 years BP, while drought conditions became established and dunes extended over the emerged continental shelf. Bowler et al., 1975. The glaciation occupied Tasmania and the Snowy Mountains, while the South Australian lakes dried up around 16,000 years BP. Warmer conditions, indicated by a rise in altitude of the treeline, set in around 15,000 years BP, but the South Australian lakes only began to fill up again after 11,000 years BP. Bowler et al., 1975. Vander Hammen, 1974, and Williams, 1975, have drawn attention to the analogies which characterize the climates of both hemispheres during the last glacial maximum around 18,000 years BP. A general aridity persisted during several millennia in all regions of the globe lying at low latitudes, with the exception of the southwest of the United States. 385. 12,000 years BP to the present. High latitudes. This period is characterized by the end of the glaciation and a distinct rise in temperatures culminating between 7,500 and 4,500 years BP. The climatic optimum, still referred to in Europe as the Atlantic period. The ice cap on the Cordillera melted very rapidly and disappeared around 10,000 years BP. The one in Scandinavia disappeared shortly afterwards, 9,000 years BP. Distinct rapid fluctuations at intervals of about 2,500 years, as, for instance, the cooler conditions of the New Dryas between 10,800 and 10,100 years BP, have been noted. The situation in respect of glaciation began to be comparable with that prevailing at present around 8,500 years BP in Northern Europe and around 7,000 years BP in North America. Nat Academic SEI, 1975. At that time, too, the ice sheet in the west of the Antarctic receded. Oceans. The rise in sea level, which reflects the average melting state of the world's glaciers, was still very rapid between 12,000 and 7,000 years BP. More than 1 meter per century on the average, but with a considerable deceleration. or a fall around 11,000 years BP. The oceans seem to have reached a level very close to the existing level after 6,000 years BP and to have oscillated only a few meters above and below it ever since. In addition to this general trend, sea level fluctuates in accordance with general climatic variations. Morner, 1973. The zones in which marine sedimentation was reasonably rapid, zones studied by Volin and Eriksson, also enable us to follow changes in the distribution of foraminifera, in particular, the variation of the percentage of sinistral Globirotalia truncatulinoides. According to Morner, 1973, the peaks in the corresponding curves could reflect the peaks in the curves of climatic changes recorded by means of isotopic surveys of ice in Greenland, palynology scales and fluctuations in sea level. However, the limit of precision of the radiometric dating method is reached here and linear interpolations are required between the dates, the variations in the sedimentation rates being taken into account. Besides, the distortion of the chronological scale of carbon-14 in relation to the time scale makes corrections necessary, and it is tricky to correlate phenomena which existed for only a century or two after the extreme aridity of the period extending from 16,000 to 14,000 years BP and from 12,000 years BP onwards, the lakes in the Saharan regions expanded in a remarkable fashion from the Atlantic coasts to the Red Sea. In nearly all the low-lying regions, lacustrine deposits, often consisting of diatoms, are to be observed. 386. 387. In Niger and Chad, M. Servant, 1973, worked out a continuous curve of the P/E ratio, Fig 16.7, on the basis of a study of various types of lake, taking into account their source of supply and their hydrogeological and geomorphological situation. This climatic curve illustrates the major oscillations, which seem to have a general character, great expansion of the lakes around 8,500 years BP, to diminution around 4,000 and minor fluctuations after 3,000 years BP. These major oscillations affected the various lakes in a far, too, though with some minor differences due to their sources of supply, gas, 1975, Fig 16.8. A definite analogy is to be observed between the Chad curve and the humidity curve for the Siberian continental zone. A study of the other African lakes shows a fairly comparable line of evolution, Fig 16.6. Livingstone and Van Zinderen-Bakker consider that there is a fairly close parallelism between the climatic evolution of East Africa and that of Europe. The expansion of the Sahara lakes up to 8,000 years BP seems to be connected with the better distribution of rainfall throughout the year and a cloud cover thick enough to reduce evaporation. M. Servant, 1973, suggests that atmospheric circulation was different then from what it is now. The presence of several levels of cold climate diatoms leads him to postulate possible intrusions of polar air over the Sahara. Present climatic mechanism would appear to have become established only after 7,000 years BP. Southern Hemisphere. In the north of Australia and in New Guinea the glaciers disappeared 8,000 years BP. Mount Wilhelm, while rainfall increased, with minor fluctuations, according to Bowler and others, 1975. Between 8,000 and 5,000 years BP the average temperature would appear to have been 1 degree or 2 degrees higher than at present. The climatic optimum, hypsothermal, would appear to be a global phenomenon, while the rainforest between 7,000 and 3,000 years BP enjoyed the most favorable conditions for its development since the preceding interglacial, before 60,000 years BP. Similarly, the lakes in the south of Australia, which had dried up 15,000 years BP, began to fill again around 11,000 years BP and attained high levels around 8,000 and 3,000 years BP. It seems likely that in general temperatures rose and humidity increased in low-latitude zones during the first half of the last 12,000 years, leading to conditions characteristic of the present interglacial. Conclusion with regard to the climatic chronology of the past 25,000 years. This period gives us a picture of the climatic evolution during the glacial maximum, at the end of a glacial period, and during a deglaciation leading to 2 diminution just before 7,000 BP, another expansion around 6,500. An interglacial, the present. This model of half a deglaciation cycle shows generalized aridity lasting about 5,000 years in Africa and characterizing the end of a glaciation, followed by a humid epoch of comparable duration, fluctuating but gradually reverting to an arid stage. These climatic pulsations can be explained on a time scale of 20,000 years by the displacement of the polar fronts and their effects on the intertropical front, and by the two extreme types of circulation, rapid or slow. It is also likely that this model is representative of other comparable situations on the same scale as the quaternary, that is, similar in duration and amplitude. However, there is no justification for extrapolating to the whole of a glacial period lasting 100,000 years, and still less to all the quaternary glaciations, covering a period of several million years. For this reason, the chronology of a glacial period will now be examined as a whole, dating and climates over the past 130,000 years. The past 130,000 years, Upper Pleistocene, afford an opportunity of studying a climatostratigraphic model on the scale of a complete glacial/interglacial period. The chronology of this period far exceeds the reach of the radiocarbon dating, which has enabled us to establish a fairly accurate succession, to within a century or at least a millennium, for the last 25,000 years. However, this interval of time, corresponding to the last major interglacial, Eemian, before the present one, and the last major glaciation, Worm, Wisconsin, Weichselian, Valdai, is fairly well known, the risk of error in dating being of the order of 10% or 20% in the case of the remotest period. In point of fact, in oceans and sedimentary basins, extrapolation from known settling velocities, the application of methods involving the disequilibrium of uranium and potassium argon at the upper limit of its range, provide additional chronological data. Linear interpolation between dated points in a continuous sequence gives an approximate chronology. However, correlations over large periods cannot be made accurately enough for events which did not extend beyond several millennia. So, it is mainly general trends over average periods, 10,000 years, which are best identified and can be compared from one region to another. High latitudes. The vegetation of the Eemian interglacial indicates that during the warmest epochs oft had interglacial, between about 125,000 and about 80,000 years BP, the temperature in Eurasia and North America was quite comparable with that of the Atlantic period, between 7,000 and 5,000 years BP, that is, not much different from what it is now. Both these interglacials occurred suddenly after a considerable drop in temperatures, the last very cold stage of the RIS, 135,000 years BP, and the last very cold stage of the WURM, 20,000 years BP. 390. Oceans. variations in the level of the oceans reflect the two glacial maxima fairly well, dropping considerably, NO meters plus 20 meters for the second. MAXIMUM around 20,000 to 18,000. The highest levels reached during the Eemian interglacial and the present one are comparable, to within 5%. Rises in sea level during the interim stages, 45,000 and 30,000 years, may have attained from 60 to 80% of the maximum rise, the Inchirian. In Mauritania, for instance, they confirm that an equivalent mass of ice melted during the interim stage. Africa. As in the case of the oceans, the repercussion of glacial phenomena was probably attenuated towards the intertropical latitudes. The differences between the temperatures of a glacial stage and those of an interglacial stage, from 50 to IO degree at average latitudes, may have been only from 2 degrees to 30 between the tropics. In Africa, the effects on the distribution and quantity of rainfall constitute the most readily observable phenomenon. Few regions in Africa possess a well-established radiometric chronology for the past 130,000 years. However, by sounding Lake Abaye, F-gas, 1975, was able to find evidence of 3 lacustrine stages in the upper Pleistocene, before the aridification from 20,000 to 14,000 years BP. These lacustrine stages were as follows: the period from 30,000 to 20,000 years BP. Temperate humid tropical climate, separated from another expansion of the lakes from about 40,000 to 30,000 years BP by a considerable regression. Around 30,000 years BP, and earliest of all, the lacustrine stage from 50,000 to 60,000 years BP. Or perhaps from 60,000 to 80,000, corresponding to a cooler period, as indicated by the diatoms. A further indication concerning a climatic variation of uncertain date in the upper Pleistocene was yielded by a study of pollens in the upper valley of the Awash, Afar, where R. Bonifil, 1973, 1974, found evidence of a climate distinctly more humid than the present climate, and perhaps colder, characterized by a steppe vegetation on high tablelands. Mediterranean Basin. Situated between the two geographical zones studied above, the Mediterranean Basin is an important climatic field, the evolution of which seems complex. In particular, the glaciations can no longer be considered as a simple cause for the establishment of a humid climate. Analyzing the palynological, micropaleontological, and isotopic studies made in the eastern Mediterranean, in Greece, and in Israel, by Emiliani I. 955, Vernyad Grazini and Hermann Rosenberg, 1969, Wijmstra. 1969, Vander Hammen, 1971, Rossignol, 1969, Isard, 1968, and Isard. And Picard, 1969, Farrand, 1971, reached the conclusion that the drop in temperature during the last glaciation might have been 4 degrees in the case of the 391 air and from 50 to IO degree in the case of the sea. In Greece the drought was more marked during the glacial period, whereas the reverse was true on the coasts of Israel. On the other hand, a study of fragments of mammals, rodents, made by Chernov, 1968, in Farrand, 1971, seems to indicate a gradual evolution of humid conditions in the direction of arid conditions during the past 80,000 years. Around 20,000 years BP, the level of Lake Lisan, in Israel, dropped by 190 meters in 1,000 years as a result of drier conditions, combined with a tectonic movement in the Dead Sea Rift, and, as we have seen, p. 386. The end of the maximum extension of Weirmian cold was accompanied by cold and arid conditions throughout the Mediterranean basin. As with Africa, the complexity of the geoclimatic situation in the Mediterranean basin is such that further very detailed studies will be required to enable us to have a clear idea of the climatic evolution in the WURM period. Conclusion with regard to dating and climates over the past 130,000 years. The last glacial period gives us a model of a complete climatic cycle on the scale of 100,000 or so years, interglacial, glacial, interglacial, with its fluctuations during and between those stages lasting something like 10,000 years. In Africa it is characterized by stages of lake expansion, of comparable duration, separated by stages of desiccation. Given our present state of knowledge, dating is not exact enough to allow of correlating cold or warm periods with any certainty with humid or dry periods in Africa. It is to be hoped that the work underway, supported by sections and samplings yielding a continuous succession of events, will enable us to answer this question in the future. Dating and climates over the past 500,000 years. The slow trend towards lower temperatures, which is a feature of the Quaternary, began nearly 55 million years ago, Cenozoic climatic decline. Nat. Academic. SEI, 1975. The Antarctic ice sheet, which had already formed about 25 million years ago, increased considerably about 10 million years ago, then again about 5 or 4 million years ago, when it nearly attained its present volume. The Arctic ice sheet over the continents neighboring the North Atlantic appeared about 3 million years ago. The first big drop in the temperatures of the oceans generally began about 1,800,000 years ago. Bandy, in Bishop and Miller, eds. 1972, shortly before the lowest level of the Calabrian marine stage, around the same time as the occurrence of the Gilsa, 1,790,000 years ago. In Africa several regions, Chad, East Africa, and so on, have yielded a wealth of vertebrate fauna, first ascribed to the Villafrancian, between 392. 330, 0000 and 170, 0000 or 1 million years ago. Some associations of mammals presuppose much more humid conditions than those which are a feature of the present environment of the deposits. They have therefore been regarded as marking pluvial periods in Africa. The most detailed stratigraphies, based on potassium argon and paleomagnetic dating, are those of the East African rift deposits. In this type of sedimentary filling, the effect of the climate is more difficult to discern than that of tectonic and volcanic activity and the topographical changes which they produce, so that present authors have abandoned the attempt to establish a detailed climatic succession. On the other hand, the chronostratigraphy is well established and constitutes a world reference. In the various deposits of vertebrates and hominids in East Africa, Figs. 16.9 and 16.10, dated sedimentary successions are as follows. Onto, Ethiopia. The Shungura Formation about 1,000 meters thick, extending from 3,200,000 to 800,000 million years ago, the Usno Formation, from 3,100,000 to 2,700,000 years ago, according to de Heinz, Ellen, Brown, and Howell, 1971, Coppens. 1972, Bishop and Miller, 1972, Howell, 1972, Brown, 1972, 1975. A study of pollens in the Shungura Formation has revealed a considerable climatic change in the direction of drier conditions nearly 2 million years ago with the development of a grassy savanna, Bonneville, 1973-1974. This change is confirmed by a study of the fauna. The suggestion might be made that it be paralleled with a world drop in the temperatures of the oceans, 1/800,000. Hadur, Central Afar, Ethiopia. Finally, the formations at Hadur in Central Afar, which contain hominids and a wealth of fossils and which have been studied by the International Afar Research Expedition, IARE, are 3 million years old according to Johansson and Taib and others, 1974, 1975. In a few years' time the work actively pursued in these parts of East Africa will make it possible to suggest another theory of climatic evolution based on sedimentology and plant and animal ecology, and taking into account the intervention of tectonic and volcanic factors. Intensive studies have been made of other parts of Africa, such as the Saoura, Alaman et al., 1959, Alaman, 1975b, the Nile Valley, Vendorf, 1968, Butzer and Hansen, 1968, De Heinz Ellen, 1968, Jijengok, 1968, said. In Press, Chad, Coppens, 1965, Servant, 1973, and North Africa. The climatic variations proposed are based on the succession of sedimentations and bed lowerings of the new Earth, or the successions of MAMMAL fauna. Failing a radiometric or magnetostratigraphic dating, it is not yet possible to correlate these variations with the European glacial fluctuations. Conclusion: a feature of the Upper Cenozoic over the past 5 million years is the accentuation of the thermal gradients of the globe combined with considerable climatic changes in the course of time. This accentuation has led to considerable variations in temperature at high latitudes and hence to glacial and interglacial periods. At intertropical latitudes thermal fluctuations were somewhat attenuated, but atmospheric circulations, disturbed by the strengthening or weakening of the polar fronts, brought about considerable variations in the distribution and quantity of rainfall, which helped to change profoundly the environment of the different climatic zones, periodically modifying the geographical and plant environment in which the fauna lived and in which hominids developed. These climatic variations establish the rhythm of the evolution of Africa more clearly than do the glaciations in Europe. What should be borne in mind in this brief survey of the state of our knowledge concerning climatic variations and dating in Africa is the need for continuing observations and measurements before fitting our heterogeneous knowledge into the rigid framework of a theory. On the other hand, we see the importance of the time scales of the various manifestations of climatic change. Care should be taken to place each observation and each phenomenon within the correct time scale. By way of conclusion, this is illustrated in Fig 16.11 taken from the volume of the National Academy of Sciences, 1975, in which 5 examples of climatic variations are given for time scales ranging from a century to a million years. Hominization. General problems. Part IY. Coppens The paleontological data. MAN is a MAMMAL, to be more precise, a placental mammal. LHE belongs to the order of the primates. Paleontological criteria. The primates, of which MAN forms part, differ from other placental mammals on account of their precocious brain development, improved stereoscopic vision and reduced face size, the replacement of claws by flat nails, and the opposability of the thumb to the other fingers. Among the primates, which are divided into prosimians and simians, and comes under the second category, which is characterized by increased stature, the displacement of the eye sockets on the face with the resulting improvement of vision, and the independence of the temporal cavities. There was a sudden proliferation of forms among these simians in the Upper Oligocene about 30 million years ago, which suggests that the differences occurring in the hominidae family may date back to that epoch. In order to be able to write the history of these hominidae, we accordingly have to search among the simian fossils of the past 30 million years, in a bid to identify those whose evolutionary tendencies point towards the features which typify us as the genus Homo, as bipeds, with all that this implies by way of changes in the feet, legs and pelvis, the orientation of the skull, the proportions of the spinal column, the development of the brain case, the reduction of the face, the rounding of the dental arch, the reduction in size of the canine teeth and the hollowing of the palate. The Proplyopithecus of the Upper Oligocene displays discrete signs of some of these tendencies, which is why some authors have been prematurely enthusiastic in regarding him as being akin to ourselves. The tendencies that can be observed in Ramapithecus are more relevant, in that the brain appears to have grown in volume to 400 cubic centimeters, the face is reduced in size, the dental arch is rounded, and the incisors and canines are likewise smaller and are implanted vertically. Since another primate, Oreopithecus, for which we have a complete skeleton, has the same skull features and the pelvis of an occasional biped, it can be presumed that the postcranial skeleton of Ramapithecus, which we do not yet possess, may also bear the same first signs of adaptation of the body to the upright posture. However, there can be no ambiguity about the evolutionary tendencies of the Australopithecines, since these permanent bipeds have human feet, very modern hands, a distinctly larger capacity brain, small canines, and a smaller face, and can accordingly only be regarded as hominidae. At the end of the chain, the genus Homo differs from the Australopithecines by his increased stature, improved erect stance, increased brain capacity, which may be as much as 800 cubic centimeters in the very earliest species, and a change in dentition, with a relative growth of the front teeth, compared with the side teeth as a result of the change from a vegetarian to an omnivorous diet. It can be seen that the paleontological approach involves a study of anatomy which is at once comparative and dynamic. Since paleontologists know that evolution always moves from the simplest to the most complicated, and from the undifferentiated to the specialized, they have to find fossils that are both sufficiently comparable and, with due regard to their geological age, are sufficiently different from man whose ancestors they are seeking. The oldest primates are the prosimians. At the present time, this group is represented by the lemurs of Madagascar, the tarsias of the Philippines and Indonesia, and a small galago of tropical Africa. From the Eocene II onwards, the simians divided into two main groups. The Platyrrhina or NEW world monkeys, with a broad nasal septum and 36 teeth, and the Catarrhina or Old World monkeys, with a narrow nasal septum and 32 teeth. The Catarrhina are divided in their turn into a number of families, the Cercopithecidae, the Pongidae, the Hominidae, the Hylobatidae, the Oreopithecidae, the Gigantopithecidae, and so on. 20 to 40 million years ago. Lack of evidence makes it difficult to see what was afoot in the Eocene and Oligocene ages, between 20 and 40 million years ago, but a rich site at Fayum, about 60 miles south of Cairo, investigated by numerous expeditions, has yielded up signs of an incredible variety of primates. Parapithecus, Apitium, Oligopithecus, Proplyopithecus, Eolopithecus, e.g. Topithecus. Parapithecus and Apitium are notable as having 3 premolars, that is, 36 teeth like the prosimians and the platyrrhines, New World. Monkeys. Amphipithecus, a third type, found in Burma, with a similar morphology, belongs to the same group. But many other traits cause this group of primates to belong rather to the catarrhines, characterized by 32 teeth. They are in fact ancestors of the catarrhines, or protocatarrhines. Thus our first look backwards reveals an introductory stage, the protocatarrhine, with 36 teeth and existing in 3 types: Parapithecus, Amphipithecus, Apitium. Oligopithecus, Proplyopithecus, Eolopithecus, and Aegyptopithecus have 2 premolars and are true catarrhines with 32 teeth. Oligopithecus is a small primate about a third of a meter high, with